Hello everyone.
Hello,
Hello
everyone.
Matt. How are you doing?
Hello. I'm doing well, thank you very much. This is good. This is exciting. I'm looking forward to today. Today's going to be a good day. Lots of interesting sessions, I think.
Yeah, I hope so. So we're talking about the game dev, which is fun, right? So I do hope we'll have fun with the game dev. Any big news in the game dev world, or we better skip that part?
Let's just talk technical stuff. I think that'd be a good thing.
Okay. So by the way, Matt, so what was the first game system you owned? Do you remember that?
Oh, straight in. Oh, you see, well, I'm a bit old school, so it's I don't know. Can we count the ZX Spectrum? It's I've got the heady days of loading games from tape, getting the volume just right in the tape machine and everything. But the first actual sort of console I got was PlayStation. I bought a PlayStation purely to play Wipeout. Wipeout was great, but I've had Amiga, Commodore 64, all those as well. So I think, what about you? What games are you in?
I was playing Kanga console. I don't remember more details. I think I was playing DuckTales. That was fun. Yeah, that was fun. But anyway, so we're here and we have awesome speakers today who are ready to talk about Unreal Engine, Unity, Godot, CI/CD, many other fantastic topics. And I think we have a great lineup and many speakers ahead of us. And we have also a great audience from all over the world, actually. So we have people from Australia, Germany, Latvia, and many others. I saw so many nice countries in the chat. Thank you guys and welcome everyone. And Cyprus also welcome. There's a huge audience there, and I guess you're having fun. Yeah, and you can chat and meet.
Yeah, we've got an offline event going on in Cyprus at the same time as this, so people are watching there and they can join in, they can ask questions. We've got staff people there as well who can help with them and show stuff as well, which is fantastic. Speaking of questions as well, if you ever have any questions throughout the day about any of the sessions, just fire a question away on YouTube. And Twitch and any other places where we're streaming. Send us your questions. We'll grab them together. We'll try and add them and get them to the speakers at the end of each session. So please let us know any questions and let us know how you're getting on.
Yeah, and I think with that, we can start and we can bring our first speaker to the stage. And we're starting the day with two JetBrains speakers. So let's invite Daniel here. Hello, Daniel. How are you doing?
Hi, Daniel.
Hi, Anastasia. Hi, Matt. How are you?
Yeah, so Daniel is a solution engineer on our TeamCity team at JetBrains. So he does lots of interesting stuff, and he will be sharing that stuff today with us. But before we start, let me ask you, Daniel. So what was your first game system you owned?
So like Matt, actually, I owned a ZX Spectrum where you loaded games from tapes. I used to play Dizzy, where it's like an egg that you kind of walked through this land. And yeah, that's probably my first game.
Wow, sounds amazing. Great.
ZX Spectrum, it wasn't amazing, but we loved it.
But I guess at that time, right? At that time, it was fine.
It's fantastic. Horace singing. It's wonderful.
Yeah, I guess so. Okay, so Daniel will be talking to us about the build pipelines with TeamCity for Unity and Unreal Engine. So Daniel, if you're good to go, let's start.
I am. Yes. Yep. Sounds good. Cool. So hey everyone, I'm Daniel. As Anastasia mentioned, I'm a solutions engineer on the TeamCity team, and TeamCity is JetBrains' CI/CD solution. So I'm showing here today our TeamCity Cloud offering. So I'm logged into a TeamCity Cloud server, and this has a couple of projects on here. So I have a Unity project, which is called JetBrains Token Chaser. And this consists of a few different parts of a build pipeline, including some tests, building for different platforms, and also deploying to different platforms, including deploying the iOS version of the game to Apple's TestFlight service, and deploying a WebGL version of the game to a Amazon S3 bucket, which is running as a website. So if I click this shortcut here, I can see a running version of the game, and I've got this character that can run through this world and collect these JetBrains tokens. Unfortunately, these aren't redeemable for any cash, but that's the web version of the game. And if I switch over to my phone, I have the same game running on my phone here, so I can do the same thing. So before I go into too much detail about how TeamCity is configured, what I want to do is make a change to my game because I want to show what happens when I commit a change and have TeamCity respond to that commit. So one of the things I like to do as part of this demo is go into my Unity project and just change the color scheme. So if I change it from the current blue color to something else, maybe go for a purple color to match the event color scheme. Yep, so we'll save that. And over in Rider, I can come in and commit that change to the scene file. And I'll say new color scheme for Game Dev Day. And we'll commit and push that. So over in TeamCity, this project for JetBrains Token Chaser, this is configured to point to the GitHub repository here. So this is where my Unity game is stored. So whenever a commit is made to that repository, TeamCity will immediately respond because I've set up a GitHub webhook. And hovering over any of the build configurations in my project here, you can see a summary of the commits. And if I click on the commit message, I can see the actual files that were changed. If those were text-based files, I can use the built-in diff viewer to see the before and after. And you can see that the build is immediately running. And for this, I have a bunch of tests executing. So first of all, I am executing some Unity edit mode tests, and you can actually see that a few of these tests are running concurrently. So if I go to the end of my project, I can show you the build pipeline. So in TeamCity, we call build pipelines build chains, but they're essentially the same thing. And this is a great way to visualize the pipeline for your project. And based on the dependencies of each part of your project here, TeamCity figures out which parts of your project can run in parallel. So because all of the tests that are being executed have no dependency on each other, TeamCity knows that it can run all of those jobs in parallel. And another nice thing, I'm also making use of a parallel tests feature for some .NET shared module tests. And this allows TeamCity to split a large batch of tests across multiple build runners or build agents. I'm then building the game for a few different platforms. And again, because those don't have dependencies on each other, TeamCity is able to run each of those jobs in parallel across different machines. And the way TeamCity runs the builds, so we have the server that we're looking at here. You then have one or more build agents that are connected to this server, and that one of those agents will take a job from TeamCity, run through it, and pass back the log file and any artifacts back to the server. In the example today, I'm using persistent agents that are running on AWS EC2, but TeamCity also supports what we call cloud profiles. So if I go over to my project and look at the cloud profile screen, this is where you can define your own custom cloud provider, for example, EC2. And this will enable TeamCity to spin up agents running under your AWS account, and it can resume and suspend instances as and when they're needed. It can also create a new instance from a AMI. So this is a great way to provision agents as and when they're needed, rather than having them running 24/7. So back to my project here, if we look under here at the tests, we can see that the tests have finished executing. And the way that I'm executing these tests, if we go down and look at the build steps, when you add a build step, there are a number of types of out-of-the-box runners that we provide our users. So if you're using .NET, there's a .NET runner. If you're using Node.js, there's a Node.js runner. But more importantly, for game dev, there is a Unity build runner built into TeamCity. And just a few weeks ago, we actually released a Unreal Engine build runner for TeamCity. And this is available as a JetBrains plugin. And this makes it much easier to configure your Unreal Engine builds and your Unity builds through TeamCity. So jumping back to the build step for my tests, All I had to do here is define the working directory for my Unity project. So looking at the repo, my Unity project is within the Unity project subfolder. So I've set that as the working directory. And then scrolling down, I've checked the option here to run tests from the project. And then the test platform, I can choose the type of tests I want to run. And over in Rider, I have a bunch of tests under the edit mode tests folder, and these will be executed by TeamCity. And then scrolling down for the Unity version, you can set the detection mode to auto. So the installation directory will be automatically located on the build agent. And then if there's a particular Unity version you wish to use, you can define that version here. So jumping back to the test results, whenever tests are executed by TeamCity, the results will be automatically passed. So there will be a tests tab, and you'll see all of the test results inside of the user interface. You can also drill down into each of these tests and see the time that it's taken to execute that test over all of the previous runs. And you can also see whether it was successful or failed over any of the previous runs. So that's the testing. Then over on the build side of things, we can see that all of the platform builds have finished. So if I hover over the Android build, for example, we can see that there is a game android.zip. And if we expand this in the TeamCity UI, you can see the APK file inside of that zip. The iOS one typically takes the longest, and this is a kind of two-stage build because the way I'm executing a iOS build is I first of all generate the Xcode project, and that could happen on a Linux or a Windows machine. And if your Mac OS resources are constrained or you don't have too many Mac OS resources, this is a great way to cut down the build time on those machines because the generation of the Xcode project can be done on a lower cost machine. And then when you need to sign the game, so generate the IPA and sign it, that can run on a Mac OS environment, which we're doing here. And I'm actually making use of Fastlane for this build, and we'll look at that in a bit more detail shortly. The WebGL game has also finished building, and we can see the zip file for the game. And then under the deployment jobs, most of these have finished, including the WebGL version of the game, so we'll come back to this shortly. But looking at the build iOS and how this is configured, so under the build steps, there are a few different build steps here, and the first build step will grab a few secret values from AWS Secrets Manager. So because I have the AWS CLI installed on my build agent, I can make use of the AWS command and retrieve the different secret values, which would be my private key, the sign-in certificate, provisioning profile, all of those kinds of things you don't want to store directly inside of your repository. And to make it easier to authenticate to AWS, one of the great things that we include in TeamCity is the ability to define various connections to third-party services. So under the connections here, I have a connection defined for Amazon, so AWS. So we include this as a out-of-the-box connection option. And what this enables you to do is come in and choose the region you wish to use, the authentication type you wish to use. And when you are using access keys, those access keys are never passed down to the individual build agents. Rather, TeamCity can issue temporary credentials only on request, and those are time limited, and it's much more secure issuing those temporary credentials to the build runners, and they're invalidated after a certain period of time. So jumping back to my build, that's the first build step for generating the iOS build. I'm then downloading the latest Apple CA certificates from the Apple website. And then the third build step runs a Fastlane build, as well as getting a few more secret values from AWS Secrets Manager. And what I'm doing down here is executing Fastlane and passing in the lane name. So the build IPA. And if I jump over to my repository, there is a fastlane folder, and this contains my fast file with my various definitions, and you can see the build IPA here. So this is where it's going to create the keychain, import all of the certificates, and then scrolling down a bit further, we can see it updating the code sign-in settings, and finally building the app and also signing it. So that's how the game is being built by TeamCity. And then if we go down to the deployment, we'll look at how the deployments happen. So first of all, the web version of the game, so the WebGL version, the way that this is deployed is we deploy the web version of the game to a S3 bucket, and that's running as a website. So I have a very simple command line build step here that will sync the copy of the game folder to this S3 bucket. And how we get the game folder within the deployment is through the dependencies screen. And in TeamCity, there are two types of dependencies. So the first one is called snapshot dependencies, and this is what gives us our build chain. So by saying that the deployment depends on the build WebGL, that creates a direct linkage between those two jobs, and that then forms part of the overall build chain. And then scrolling down a bit further, we've got artifact dependencies. And this is important because when you run a build in TeamCity, there's a chance that each part of your build chain won't necessarily run on the same build machine. So you need a way to pass build artifacts through your build chain, and that's done through artifact dependencies. So I've configured this as follows. So I've added a dependency on build WebGL. Once you've selected a job, you can click on the icon here and see a list of the recent artifacts that were attached to the most recent build. So you can click on this and it will add the file to the list of file names here. So because it's a zip file, I've used this syntax to automatically extract the contents of the zip to this folder, so the game folder. And that's how the build step here has a reference to that WebGL game. And then I've got a couple more AWS S3 commands that just fix the encoding for some of the gzip files. And that's pretty much all that's needed to deploy a web version of the game. So quite simple, really. And then back under deployment, we're looking at how the iOS deployment is executed, because this is actually deployed to Apple's test flight service. So under the build steps, the first build step is to get the Apple App Store Connect API key. And again, this is stored in AWS Secrets Manager. So I'm using this syntax to get the value and make it available to the build agent. And then the second build step, this is using Fastlane, again, to use the deploy to test flight lane. So if we go to my fast file, you can see the deploy to test flight. We generate the API key, and then we use the upload to test flight and specify the IPA file and any of the other settings. And one of the things I'm doing here is earlier on in my build chain, I actually generated a change log, and this is based on the commit messages that are sent with all of the commits. So all of those commit messages are included in a text file. So when the app or when the game is deployed to test flight, we will see a summary of all of the commit messages. So the user that's testing the game on the device can see a list of all of the changes from those commits. So if we go back to the build configuration for the deployment, we can see that the deployment is running through at the moment. The time it takes for this to run can vary. It does give you an estimate for how long it normally takes to run this job. We're slightly over time here, but we'll leave that running. But the WebGL version of the game has finished deploying. So if we click the link here, we can see hopefully the new purple version of the game, which is great. And I've just lost. Okay, so over on the deployment for iOS test flight, this is still running, but we will let that run through for a bit longer. But this is showing a good example of how to build and deploy a game for Unity, but we also offer a similar build runner for Unreal Engine. So, and just as I said that, the deployment to iOS has succeeded. So if I go over to my device and bring up the test flight and just click the update button, this will download the new version of the game, and we can actually test that live here. We'll leave that to run for a minute or two. While that's downloading, we'll look at the Unreal Engine version of the game we've got here. So how you can configure a Unreal project in TeamCity is very similar. So under the configuration, we have a build step for Unreal Engine. And in here, this contains options specific for the Unreal Engine games. So you can choose the tool you want to use, whether it's UAT or whether it's editor. And if it's editor, whether you want to run the automation tests. And if you do, you can choose the project and the tests that you want to execute. So if we look at a already finished build, we can come into here, and similar to the Unity project, we have the test results automatically passed by TeamCity. And then this game is being built for both Linux and Windows. And there are two different ways that this game is being built. So in the Unreal Engine build step, for this game, I'm using build graphs. So we do have basic build graph support in the Unreal Engine plugin. So you can point it to your build graph file and define any particular options. And this will generate the Linux version of the game. And very similar, we also have a Windows build. And if we look at the configuration for this one, we're making use of build cook run. So I've just defined the uproject file and told it which platforms to build for, so Win64. And then under the general settings, this is where I've defined the build artifacts. So I'm grabbing the contents of the Win64 folder, and that's stored as a build artifact over in TeamCity. So at a high level, that's pretty much how Unreal projects are configured in TeamCity. So very straightforward. You don't have to figure out all of the command line options to execute. An important note is TeamCity does provide out-of-the-box support for Perforce. So this game is actually hosted on a Perforce server. So if we look at the VCS routes, we can see that this is a Perforce type VCS route. So this is also supported along with Git. So let me check if the game has finished downloading on my phone. It's downloading at the moment. That's fine. Let me jump back to the project screen and just check I haven't missed anything. But yeah, I think that's pretty much everything. So are there any questions in the chat at all?
Yeah, so like there is actually some nice discussion ongoing in the chat. We're trying to help with it together with Matt, but maybe like, yeah, you can also address it. So there are like some discussions about what actually is needed to have all this magic regarding the plugins. So what the people need to install to get all of this in terms of Unity, Unreal, and also maybe like because you have Writer, maybe there is also something needed for integration with Writer. So if you can just briefly describe this setup required for all this fantastic magic you are showing.
Sure. Yeah, so one of the easiest ways to get started with TeamCity and Unity or Unreal Engine is to sign up for TeamCity Cloud. So we do actually have a free 14-day trial for TeamCity Cloud. We bundled the Unity build runner as part of TeamCity Cloud. So there's nothing extra that you need to request as part of your evaluation. If you wish to try Unreal Engine, then that's something we can make available to you on request. But yeah, there's no additional plugins required or nothing extra needed to set up. Yeah.
No, sounds cool and quite smooth.
Yeah.
Yeah, awesome. Also, there was a question about the running engines locally on the user machine. Is it possible?
Yes, you can. So you can set up your own build machine as a build agent. And so we would classify that as a self-hosted build agent. So there's a TeamCity agent process that you can run on your local machine, and you can connect that to your TeamCity server as an agent. So that'd be quite useful for testing purposes if you just want to use your own agent to ensure that the TeamCity build will run through. Once you're satisfied it does, you could then set up proper agents that are hosted in the cloud that can be used for your repeatable builds. Yeah.
Mm-hmm. Okay, thank you. Thank you very much.
Sure.
Matt, do you see more stuff we haven't answered yet?
Well, I was wondering how you handled large assets, because obviously game dev requires assets which can get very large there. And if you've got big projects and things, how do you get that working with different agents?
Yeah, that's a good question. So there are a number of ways that you can handle large projects such as Unity. So because Unity does have a large number of assets or a large library folder, one of the easiest ways to handle that is through the use of persistent build agents. So agents that are used over and over again for the same builds. Those agents can either be resumed and suspended as and when the builds need to run, or alternatively, you can keep them running all the time, and then the build will just run on that same agent, and it has all of those dependencies and the library folder cached already. In TeamCity, we do also have a preview feature of that's called build caches, and this enables you to easily cache a subset of files or folders on the build agent and store them on the server for subsequent distribution to another agent. So that's another option. And then a final option I can think of is we have an upcoming feature called AWS Image Builder, and this will enable TeamCity to actually generate a new EC2 AMI, and this can help you to bundle a copy of the repository inside of the machine image, and you could run this on maybe a nightly basis, and you could also include the assets or any dependencies that need to be included, so they're kind of preloaded. Yeah.
Okay, that sounds good. Speaking of dependencies and things, the chains that you've got going on within the builds there, how do you set those up?
Yeah,
so all you could quickly demonstrate.
Yeah, of course. Yeah. So the build chain, which I showed earlier. So if I go into here and show the build chain view, this shows the overall dependency chain. So you can see how each of the jobs depends on each other. How that is set up is done through the dependencies section under the configuration of each job. So for the deployment of iOS to test flight, this will depend on build iOS. So that sets up the build chain configuration. And then you've also got the artifact dependencies for passing down artifacts through that chain. Yeah. And just before we handle any other questions, if there are any, the version of the game has actually just downloaded to my phone. So if I click on open, and you can see here under what to test, it's got the text from my commit message. So because I'm generating that changelog and including that as part of the game, the user that's testing this on the device has a list of all of the recent commits. So if I click next, we can then start testing the game, and we've got the nice purple version like before. Yeah.
Wow, looks
good
impressive.
to see it. And we do love purple as well. So this is
exactly. That's right.
A kind of a bit of a follow-on question from the dependencies there as well. Seeing as you're in the config of the project there, it's dealing with different environments. So question from the chat really. So if there are different branches which trigger a deploy in TeamCity, where can you handle sort of doing different things there with different environment variables, different setup, and different, how to handle doing different stuff with different branches?
Yeah, sure. So multiple branches are supported in TeamCity. So if for this example, I'm just running everything against the main branch. But if I were if I were handling commits from different branches in my repository, I would actually see a branch filter on this screen, and there would also be a branch next to each of the builds shown in the list here. Because I'm just working from the one branch, I don't see that option here. In terms of handling builds for different environments and different settings, in TeamCity, there is an option, or rather there's a screen to define different parameters. So under the parameters screen here, this is where you can define shared parameters that you want your builds to use. So rather than hard coding string values or hard coding passwords or access keys in your build scripts, you can define them here and set their type to password if they're sensitive values. Environment variables, these can be passed down to the build machines. So this is a good way of sharing environment variables across those machines. And lastly, if I go down to one of the jobs, for example, build and build iOS, if you wish to run this build on a particular type of agent, you can come to the agent requirements screen and choose a particular OS using one of the options here. For the demo today, I've just set it to a particular build agent name, and this is how you can set the requirements for how and where the build is executed. Yeah. Oh, and one final thing I haven't touched on, the configuration I've shown here is actually done all through the user interface. So the demo today I've shown is UI based, but TeamCity also supports what we call configuration as code. So all of the configuration that you've seen in the UI can also be done through Kotlin DSL, and this will show you the equivalent configuration if you were to define this using Kotlin.
Yeah,
that's really cool. I like the Kotlin example there as well, because you can commit that into your repository with your game as well. So you build config changes with your game itself, which is nice. We've still got a couple more questions. If you're happy to carry on there.
Yeah, of course.
We've got a question about licensing as well. So how do you handle the licensing for Unity? And also, that's like a related question there, is if you're building games for Unity, doesn't each environment require a different license?
Yeah, so typically,
sorry.
Yeah, that's a good question. So yeah, typically each environment requires a license. So if you have a couple of options, you can either initialize the license on each of those build machines if they're persistent. Alternatively, TeamCity does include a build feature which is called Unity Build Settings, and this enables you to choose from a particular license type, whether it's Unity Plus or Pro or Unity Personal, and this can help you to automatically activate that license on the build agent, and then the license is revoked at the end of the build, which will free up that license for any other agents.
Yeah, just before we go to the next question, I just want to briefly engage, because we have also people on Cyprus who might also have their questions. So I would like just to engage, like if you're there, you have a nice host, so please just either share your questions in the YouTube chat, we'll handle that with all the others, or just share your questions with your host, and he will nicely pass it to us. So feel free to do that. No worries, we'll try to handle all of them. And while you're maybe collecting your questions, we'll go to the questions we have in the chat here. So there was a question about building to consoles. So if you do support building to consoles as well.
Yeah, so it depends on the environment that your Unity build is running within. The way that I'm executing the Unity builds in TeamCity, if I go over to my build here and we look at the WebGL build, for example, under the build step, the way that I'm executing the build is through the execute method here. So this is calling the WebGL game builder class and then the run build method. So over in my rider project, I have a WebGL game builder class, and this has a run build method, and this contains a config for the scenes that will be bundled, the output folder, and the build target. So the build target you could specify here. So as long as that target is supported by the environment that you're running Unity on, you should be able to build for any of those respective platforms.
Okay, thank you.
Sure.
That sounds good. Okay, Daniel, thank you very much for a fantastic session there. There's a lot of interesting things for people to go and try with their own builds there. And once again, thank you very much. I think we'll move on to our next speaker now. So
Cool.
Yeah, thank you, Daniel.
Thanks, Matt. Thanks, Anastasia. Have a great day, everyone.
Thank you. And our next speaker, then we're going to go straight in. Then we've got Oleg, who's also a JetBrains. Is someone from JetBrains? And Oleg is going to be talking to us today about testing and Unreal as well. So we're going to start talking now a bit more about Unreal. Let's bring Oleg on, I think. Hi, Oleg. How's it going?
Hello. How's it going? Yeah, it's fine. Thank you.
Oh, good. Fantastic. Shall we get straight into it? Shall we? Are you happy to get started?
Yes, I guess probably I'm ready.
Yeah.
So
Yeah,
let's
let's
start.
go.
Fantastic. Okay, so let's bring your slides on and let's give it a go.
Okay, yeah, folks. So first of all, thank you very much for the introduction, since honestly it just was the most complicated part of my talk. So yeah, hello everyone. My name is Oleg. I'm a quality assurance engineer at JetBrains and this is my first public speech. So I'm really glad and a little bit nervous to take a floor here. And I sincerely hope that you will enjoy this presentation. And yeah, today is Friday the 13th, and I hope nothing goes wrong and I won't be killed by Jason Voorhees or other bad guys during this talk, or something like that. And today I'm going to talk about pretty scary things that also might seem to someone. Specifically, I will talk about how to test complex software systems. And in particular, I will uncover some insights on testing and Unreal Engine support in JetBrains Rider. So first of all, some of you might not know what is JetBrains Rider, and let's just resolve this unfortunate oversight right now. Well, Rider is an integrated development environment for developing .NET and Visual C++ applications, including some games on Unity engine and Unreal Engine. And basically, my whole today's talk will be about what's happening inside Rider. So let's move on and define some key points of this presentation. So today I'm going to cover topic of testing really complex software, and I will reveal some internal and external dependencies of Rider, which make our product that complex. And then I will tell you about problems one can meet while testing such tool, and how these problems can basically be solved. And also I'll talk about how we manage risks. And at last, I will tell about automation in Rider. So let's move on. And I guess that some of you just heard that this talk is about testing. And moreover, it's about testing complex systems with an IDE taken as main example and subject throughout the whole presentation. So probably some of you are listening to this speech and having a fair enough question of how does this talk even relate to game development? And I've got several answers to this question. This talk is, of course, not about game development itself, but it's built around a tool that helps to develop some of our favorite games, And secondly, IDE can be easily compared to any tool that is used in game development. So for instance, we can compare IDE with Scene Editor, and Scene Editor allows us to modify and beautify some objects that are placed on the scene. And in IDEA, we can consider our code to be one of such objects, and we can also modify it and make it look better. And finally, if we compare game development and IDE development, in both cases, you have a huge number of dependencies, and this fact should be always kept in mind during the whole product's life cycle. Like when your product is in development, when your product is in testing, and even when it's in production. And what dependencies here can mean really a lot. like starting with some software dependencies and ending with how some events in game depend on each other and what can happen to game if these dependencies are broken. So now, since I mentioned something about dependencies, let's turn out to our subject, to our rider, and let's take a look at what's hiding inside it. So here on this slide, I will show the structure of rider and of its software dependencies. So here, first of all, as you can see, a lot of things are developed in rider itself only for rider. So it can be its own product features that make our product unique on the market. And also it can be some UI elements, icons, and so on. So it can be considered like a circular dependency on itself. However, Rider is based on IntelliJ idea that provides general UI for all JetBrains IDEs and some core functionality like working with file system or rapid search of some IDE features or classes or something else in your code. So like all this kind of stuff comes from IDEA. So we can unofficially call it as Rider's front end. Well, we talked about front end, but Rider's backend, though, is another JetBrains product. It's ReSharper C++, and it is responsible for everything related to C++ language support, like quick fixes and actions, Unreal Engine specific language features, like auto-completion for your code with smart include of files where some type is declared. And also Unreal Engine code indexing for quick search of code, etc. So all such functionality comes to Rider from ReSharper C++ just for free. And you won't believe yet another dependency of Rider is yet another JetBrains product. It's called CLion, and Rider inherits C++ debugger from it. And this debugger is based on open source LLDB, and it is developed and tuned mostly by folks from CLion team. But in Rider, we manually test it and fix some issues that are directly related to debugging Unreal Engine projects or C++ projects by the forces only of Rider team. So we just don't ask folks from CLion to fix our bugs. And it's worth mentioning here that debugger behavior is really different on different operating systems. And I don't know how to provide some example over here, like for data visualization, for example, and evaluation of expressions. And basically, these facts slowly brings us to our next dependency. It is Unreal Engine itself. Well, I know because we are providing advanced support for working with Unreal Engine projects, we need to be always kept up to date on what's happening in Unreal Engine. And we have to support some new features that are provided by Unreal. And we need to track all the changes that are made on time and deliver our product with minimal quality risks. So we just must be sure that Rider will properly work with the new release version of Unreal Engine. So also I'll provide some examples of functionality from Unreal Engine where we have to track changes. First of all, we need to check if there are some changes in format of data visualization and storage, like objects in debugger, for example, and format of game assets, like blueprints and so on. So Rider could provide some advanced functionality related to working with blueprints. Also, loading project in Rider directly depends on internal Unreal Engine tool that is called Unreal Build tool, that is also responsible for almost everything related to project files and compiling the project. So just project loading speed depends on how fast Unreal Build tool generates project files and how fast Rider parses them. And also changes made in Unreal Engine might affect functionality that is provided by plugins developed by JetBrains. And here I would like to make a lyrical digression and tell you some details about plugins that allow to have advanced Unreal Engine integration with Rider. So you can see Rider on this slide, and it has two plugins for Unreal Editor. They are called Unreal Link and EasyArcs. And Unreal Editor also has two plugins for more advanced integration with Rider, and these plugins are called Rider Link and Rider Source Code Access. So let's look at all these plugins, and I will tell a few things about each plugin and show some real issues that were caused by them. So let's start from EasyArcs plugin, because it kind of corresponds to its name, and it's really easy to understand. Like all that it does, it adds a UI element, a combo box on a toolbar. And when you launch your Unreal Engine project, you can pass some additional arguments to command line, and these arguments will be applied. So like you see, everything is really quite simple. And you will definitely ask, how can such small innocent plugin cause any bug or break something in the product? And here is a real example of the bug. Like you see, EasyArcs freezes Rider completely, starting from some versions. And that's the reason why it's happened. Because plugin adds a UI component, it interacts with ID frontend, and all the UI components in IDE should be loaded sequentially on IDE startup. So UI component that was provided by EasyArcs wasn't loaded on its time, and that caused such behavior, like IDE is unusable when this plugin is turned on. So the second plugin in our list is Rider Source Code Access plugin. And this plugin is bundled into Unreal Engine distributions. And this plugin allows users to select Rider as an editor for source code. So it finds all the versions of Rider installed on the machine, and it lists them, so user can choose any version that they want. And after version is chosen, any action in Unreal Editor that is related to code will open Rider and focus its editor on a concrete place in the code, like on the declaration of class or some method, and so on. So that's basically how the plugin works. And regarding which bugs it can cause, I think some of you might already have some suggestions, so you can just check yourself now. Like the most common problem is that Rider Source Code Access plugin in some cases cannot find some Rider instances that are installed on the machine. And here is an issue, and you can see in issue summary that there we have some toolbox mentioned. And actually, toolbox is one more dependency of Rider that appeared due to Rider Source Code Access plugin. Just a quick remark, JetBrains Toolbox is a tool that is developed by JetBrains, and it allows to manage installations of all the other JetBrains products. So in the issue description, we can see that instances of Rider stopped being found by Rider Source Code Access plugin after Toolbox was updated to version 2.0. So this was a brand new version of JetBrains Toolbox, and it was in closed preview only. So we needed to test how our plugin works after update, and this bug just revealed itself. So now we have a new look of our dependencies diagram, and here we have JetBrains Toolbox app added. And this look even isn't final. It's just transitional, and we're still not done yet. Because we have two last plugins, Unreal Link and Rider Link. These plugins are coming together because Unreal Link is kind of playing role of front end or client if you want, and Rider Link plugin is playing backend or server role. So here on the screenshot, you see Rider, and there are several zones highlighted. So you see some play buttons on toolbar. you see some panel with logs and counter of usages of some C++ class inside Unreal Engine assets. And these are features of Unreal Link plugin that allow to interact with Unreal Editor without leaving Rider. So you can start, pause, and stop your game. So like checking logs for what's happening when your game is running, and jump directly to some assets inside Unreal Editor without leaving Rider. So yes. You can jump directly to these assets and see what's going on inside them. And these assets are basically inherited from the C++ class. And on the slide, there's one thing left on the left side on the screenshot. You see some C++ projects in project tree. And this is basically backend part of Unreal Link plugin, and it is called RiderLink. So RiderLink plugin contains C++ code, so all earlier mentioned functionality could actually work. So without RiderLink plugin installed inside your project, we will be able only to see all these buttons and panels, but actually not to use them. You can extract RiderLink into your Unreal Engine project, and after it's started, it's required to compile it before it actually starts working. And this is the most problematic place with this plugin. We have tons of requests that RiderLink cannot be compiled due to some reasons. And here's one of such issues that was reported to us. Like RiderLink cannot be compiled after updating Visual Studio to the latest release. How's Visual Studio related to Rider? Well, Unreal Engine is working only with MSVC toolchain that is provided by Visual Studio. And it means that Rider uses all the Visual Studio tools like compiler, linker, and so on to be able to build Unreal Engine projects. And the same situation is on macOS, where toolchain for C++ is taken from Xcode. So Rider as well cannot build Unreal Engine projects without Xcode installed on the machine. And so this fact gives us two more dependencies, Visual Studio and Xcode. So this basically is our final form of Rider's dependencies diagram. And look how ginormous and massive it is. It looks really impressive, isn't it? Like, I personally like it and love it. Yeah, but actually not. So yes, it's terrible. And I guess all of you understood that such number of dependencies and such deep level of integration, of course, brings some problems to us. So let's take a look on them and see if they can be solved. Well, so the first problem is that you see some angry user came and blamed Rider that it broke everything again. So it's like not the first situation when something similar occurs. And the problem actually here is that users will always blame your product first, and they don't care if a problem is caused by some other program that is included into product they use or not. So they just will come to your bug tracker, and next morning after your product's release, you'll just open your eyes, stretch yourself, pour yourself some coffee, open your laptop, and see such requests like directly pointing that this was your project that broke everything. So users be like, hello, how are you? We're under the water, literally sinking without ability to work. And of course, such issues usually cause much stress for people involved into product development, support engineers, developers, quality assurance engineers, like whoever. And these people usually have really little time to make a proper fix, test it, and cover all the scenarios that might have been affected by the fix. And also, these people need to roll out the hotfix version as soon as possible. And the question that appears here is how to prevent such situations and minimize risks. And thanks God, there is a solution. And this solution is to use for testing some preview versions of tools that your product depends on. And this solution is a lifesaver here. Because in this case, you will be aware of changes in new versions. You can notify your team about these changes, and then you can just make sure that your product works properly with these versions of external tools. So it's like a win-win for everyone. Like for people who develop the product, for people who test it, for its users, and for everyone. Okay, so let's slightly move to the second problem that is caused by such a huge number of software dependencies. So I guess you remember how Rider's dependencies diagram look like, and it becomes quite clear that only manual testing of such product is definitely a bad decision. So you will get mad immediately. Like you will lose some important changes. You'll forget about some required checks that must be done before the release. You'll spend a lot of time doing the same checks for every single Unreal Engine version in the existence. So, like all these emissions are unfortunately inherent to manual testing, and cost of a mistake is really big, not only for testers, but again for everyone, especially for users. And here, our undebatable helper for minimizing risks that are brought by manual testing is automation. Yeah, look how happy I am. So let's take a deeper look at how automation in Rider basically works and how we automate things in Rider. And here I need to make yet another lyrical digression here. Just a little rewind into the history of Rider. So in the very beginning, Rider was planned as an IDE for .NET. So its development, including the development of test framework, was carried out having in mind only .NET projects. So tests were written for .NET as well, only for .NET. And only after some time from the first release, idea for supporting Visual C++ and particularly Unreal Engine appeared. And when necessity of tests for C++ and Unreal Engine projects became obvious, it just turned out that we have some problems in existing test framework. And that's why I split it into .NET projects and Unreal Engine projects. So let's take a deeper look at it and trying to understand what's the difference between writing tests for .NET and for Unreal Engine. First of all, .NET development is associated mostly with C# language, which is quite a little bit different from C++. .NET projects are loaded in other way than C++. So during the first attempt to run tests for C++ projects using existing test framework, it turned out that projects loading couldn't be validated at all. So it was needed to make some changes in the test framework in order to make it work. The other problem that was met that we cannot reuse already existing API for testing C++ projects, since some systems for .NET and for C++ are implemented in different ways. So here I can think of an example. It will be about debugger in .NET that was written and implemented by a Rider team from scratch, whereas C++ debugger was developed by another team, and they took existing open source LLDB debugger, they tuned it and integrated it firstly in CLion and then into Rider. So due to this fact, API that is used for writing .NET debugger tests cannot be used for writing C++ debugger tests. So test framework in Rider was again in a strong need of new APIs that would allow to automate testing for C++ in Rider. Well, the next thing that makes a difference between tests between .NET projects and Unreal Engine projects is that .NET tests are setting up environment on the fly, whereas Unreal Engine tests need pre-installed environment and some separate machines where these tests can be run. And it is caused by the fact that Unreal Engine itself is huge and massive, and setting it up with every single test run is absolutely useless and has literally no sense. Therefore, Unreal Engine tests should be run on some special testing machines, which have special setup of tool chains, concrete versions of Unreal Engine installed and configured, while .NET tests can be run on any machine, since .NET SDK is downloaded and installed within the tests. And, to be honest, there are many, many more reasons why there is such a difference in .NET and Unreal Engine tests. But if I kept talking about them, it would be taken for at least 2 years. And I don't think anybody is actually interested in it. But now you are partially aware of our way of the samurai. So that's great. Let's move on and take a look on the algorithm of running Unreal Engine tests. Well, firstly, we actually need to start our test. And so when we start it, we then almost immediately start to look for all the Unreal Engine versions installed on the machine. And then we are filtering them so to pick only those versions that we want to test. And after that, we sequentially set Unreal Engine version to the corresponding uProject file. And by meaning uProject file, here, so uProject is an Unreal Engine project descriptor. And then we have a condition on how we basically load the project. So if test is opening and loading project as a Visual C++ solution, then we need to call a special Unreal Build Tool command that will generate Visual C++ project files that writer can open. And if test is opening and loading project directly via your project file, we just run tests, since in this case, project files are generated on the stage of project loading, and there is no need to explicitly call some other commands in order to generate project files. It's done automatically within the tests. So as you can see, after Visual C++ project files are generated, we run tests as well. So there's only one extra action if test is opening project as a Visual C++ solution. And after that, when we're having our tests running, we are doing some test magic, and test either passes or fails. And then it is cleaning all the leftover data, and it is getting ready for the next run. So here's such a diagram of how do we run tests. And this approach of running tests can be called as write one, get X free. And I will explain why. So let's take a look at the following table. So here columns are the ways of opening Unreal Engine projects, and rows here are versions of Unreal Engine that we use in order to open test projects and run tests against them. Each test equals to some scenario that we check, and this test multiplies on number of ways of project opening and on number of versions of Unreal Engine that we use for running tests. So currently we have only two project models, like ways of loading project. It's Visual C++ solution and native Unreal Engine, so-called uProject model. But if we suddenly decide to support or invent some new way to open Unreal Engine projects, who knows, we could write tests for this new way of project loading with minimal efforts, and these tests will work as well. And as you can see, usually we take four-mentioned here versions like latest Unreal Engine 4, pre-latest Unreal Engine 5, latest Unreal Engine 5, and Unreal Engine 5 taken from GitHub. And there we are testing branch UE5-main because we are using preview versions for testing. I guess you remember it. And also you can see that there are also 3 dots, both for project models and for Unreal Engine versions. Here I just wanted to show that independently from how many project models we could have and how many versions of Unreal Engine we could use, tests will still work. So that's why I basically named this slide as write one, get X free, because there's no fixed number of test runs. It depends only on the environment where tests are running and by filters that are set by the test itself. Okay, so let's move on. On the previous slide, I mentioned that mostly in test runs, we take 3 versions of Unreal Engine from Epic Games Store, and these versions are pre-built. So you install the distributions with already built and working binaries, and there is no need to compile the whole Unreal Engine by yourself. But also in tests, we use a version that is built from source, and I would like to tell about the differences between how tests are running against versions that are taken from Epic Games Store and against GitHub version. So first of all, we have different constraints on how do we basically load a project that targets either a version of Unreal Engine that is taken from Epic Games Store or which is taken from GitHub. And that's happening so because in this case, number of loaded projects on project opening is significantly bigger than number of loaded projects when opening Unreal Engine project that targets Epic Games Store version of engine. So we are reducing number of projects to be loaded, abandoning from loading all the projects that provide some extra functionality which isn't required for test running. So the second thing is that when we compare Epic Games Store and GitHub engine distributions, it turns out that many things are located in different places and work slightly different as well. So here is an example of what we should call in order to generate project files for the C++ part of your Unreal Engine project. In case of engine is taken from Epic Games Store, we need to call Unreal Build Tool directly. So you see Unreal Build Tool.dll over here in the first line. And if engine is taken from GitHub, we need to call a special script that first will check that everything is ready for generating project files. Then, if it is needed, the script will build all auxiliary programs that are required for performing generation of project files, and only then it will actually generate project files. And there are many other cases which brings us a lot of conditions both in the product and in tests, like if engine is built from source or is taken from GitHub, then blah blah blah, and you can see lots of this in the code. And one more thing that's worth mentioning here is that not only tests for engine versions taken from Epic Games Store and GitHub distributions are different, but also many things have changed with the first release version of Unreal Engine 5. So, for instance, our good old friend Unreal Build Tool was rewritten from .NET Framework to .NET Core, and its extension changed from .exe to .dll. So again, we should write some very interesting constructions, like if Unreal Engine version is 5.0 or later, then blah, 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 else blah, blah, blah. And again, it can be seen all over the code base, in product itself, in tests, wherever. So, of course, manual testing and automation complement each other, because some bugs caught by manual QAs are provided to automators then. And manual case can provide more context for automation team about how things do actually work, depending on the concrete cases and conditions. And automators, in their turn, warn manual QAs about tests that failed and ask them to recheck the scenario that failed in the product itself. And it's worth mentioning here that in our case, because we have a lot of software dependencies, we can let people from other teams, like from C-Line, from ReSharper C++, from IntelliJ IDEA, we can let them know that some scenario might be broken in their tool as well. So, like friendship and happiness is everywhere. We are helping each other, and it basically works great so far. Okay, so let's take a look at the test data, I think, and I will show that it's very important to choose the data for your tests, because you need to have some granularity of tests, and you need to cover all the basic scenarios. So we are using an empty Unreal Engine project, which is created from template that is provided by Epic Games. And such choice of test data allows us to quickly and automatically check some very basic scenarios. And despite the fact that Unreal Engine itself is huge and massive, you remember, loading speed of empty project is really fast. And this is ideal for test running. So manual case could have a little break and then investigate some more serious scenarios on bigger projects that are closer to real ones. And another important point is that we use 4 different engine versions for automation, and this helps to keep backward compatibility. So we are making sure that all our changes to support newest versions of Unreal Engine don't break support of older Unreal Engine versions. And as I've already mentioned here, we also use Unreal Engine from GitHub. You see it highlighted with red on the second screenshot. So we use it in our auto tests, and the fact that we are using main branch there also allows us to make sure that when a new Unreal Engine version is released, Rider will properly support it, because all the basic scenarios are covered by our auto tests, and therefore we have guarantees for all the versions of Unreal Engine, actual versions, and not released yet versions. Such choice of test data gives us full protection. And also it's worth mentioning that test framework was significantly improved and enhanced in the last couple months. And this fact gave us an opportunity to make our auto tests being run on larger projects that are closer to real ones. Like, for instance, we can run our tests on Lyra Starter game sample that is provided by Epic Games to learn features of Unreal Engine 5. And if it happens so, after such project is added to auto tests, like manual QAs could just have a break and chill. No, sorry. I mean, they could investigate some more serious scenarios, and they could have even more time to just test some new cool features of the product without rechecking the same scenario for 8 possible configurations for 50 times a day. And that's cool. So kudos here to automation. And I would like to sum up my big talk. And I would like to say that all the solutions and tricks I taught about here aren't our own inventions. We just try to apply some facts from testing theory to our reality. And, it works pretty well, to be honest. And of course, we haven't reached good results at once. We had a lot of bugs. We had plenty hot fixes. Like, we had angry users coming and saying that our product break their daily routine workflow. And, after having all these problems, you were just looking at this, and almost immediately you started feeling yourself like this frog from Muppet Show. And every such negative situation, though, gave its positive fruits. And now, by trial and error, we know that we are on the right way with our testing, and we finally have an understanding of that we are doing everything correct. So I have to mention there that testing theory is usually invented by some very smart people who have some understanding about how things work. So just theory is also a good friend over here. So also, even if your product has a lot of software dependencies, just don't be afraid. It can be tested well without spending your whole life for it. Just communicate with your teammates and people from other teams, get some help, use preview versions of your external tools that your product is bound to. And remember that almost everything can be automated. Just give it a try, and again, request help if you feel that you need help. And automation is also your good friend over here. Don't cancel or abandon it, especially if tool that you test is too complicated. And also, the last thing that I wanted to do here is to thank my colleagues who helped me to not go nuts throughout my everyday working life, and in particular with preparing this talk and making it actually happen here. So kudos here to Tatiana Koroleva, who provided me with idea to prepare a talk for this conference. Also to Andrea Kinchin, who helped me a lot with these slides. Also for Anastasia Kazakova and Alexander Pirogov for being my helping hands with any questions. And my brave teammates Artyom Chuguyev and Maxim Golubtsov for their support and sharing some sacred details about how our automation works. And just look how suspiciously these guys stare at you. Like if you don't automate your tests, they will find you. So just handle your business correctly. So that is all, folks. Thank you very much for your attention, for attending my talk, and I hope you found this presentation interesting, or at least you've learned something interesting and new from it. Cheers. Thank you.
Thank you very much. I've learned that I need to automate my tests, or these scary people are going to get me. This is a very important takeaway from this talk, I think.
Yeah, indeed. And you had some nice pictures of us. Thank you. That was fun. Hopefully, like Alex is also having fun there on Cyprus with his fantastic pic. Yeah, so before we proceed with the questions, I will just give you some small break to breathe after this fantastic talk. And so yeah, and because I saw some discussions in the chat, so I'll try to explain the thing which I used to explain many times already, but I think that's still worth explaining because it's important. So in JetBrains, we have several tools covering sometimes the same languages and technologies, and sometimes the people are confused which is a proper one. So if you're doing a game development and would like to take a JetBrains tool for a run, so Rider is a proper choice here. So Rider supports Unity and also Unreal Engine. And there is Godot support. There is a special plugin for that. So if you take any of these, or if you do any like custom C++ engine, Rider is also good for that. Like we also have another product which was mentioned in this talk, which is C-Line, which is a general purpose C++ IDE. It doesn't have the Unreal Engine support. And the like quite popular question here is like, why actually? And the reason is very simple, because we think that we should not like just divide tools by languages, but we should divide the tools by the like use cases in the environments that people are using. And the Rider is just a better fit for game developers because it already has this, like when we were adding the C++ support, it already had this Unity support, Godot, so it was like perfectly tuned for that. And also it actually works with all this Microsoft environment thingy, and I guess like game development is still a lot about Windows, right? So it's like focused on that a lot. But if you do any other general purpose C++ development, C-line should be good for you. So yeah, hopefully I kind of answered that typical thingy often asked during our like game dev streams or under the game dev talks, and we can get to questions with that. So like first of all, maybe I can just ask Oleg here. You have like this amazing shim and that many things here. How long does it take you to do like, you know, like a general check before you say, yeah, guys, this build is fine. You can go with it to production and deploy to these amazing people in the chat who will be using it then?
Well, yeah, that's a really good question. And, you know, because I'm not working alone, I have my teammates. It just takes much more little time than it than it would take if I was working on my own. So yeah, I guess that it's taking about 2 whole days of continuous testing. Like you're sitting and rechecking some scenarios, then you're waiting for auto tests to pass, which also takes some time because there might be some problems on CI/CD tools or something in the code that might have been broken. And you know, yeah, I guess 2 days would be enough just to require some checks between 2 people. So that's okay, I guess.
Yeah.
And I take it that that's a lot of scenarios being tested there as well.
Yeah, sure. But you know, you to it, so you know your business correctly and just your manual testing, you know.
Well, we're having a couple of glitches there with the stream there. Could you repeat that last little bit, please? Sorry.
Yeah, I'm sorry. So yeah, can you hear me well?
Hopefully, yes.
Yeah, okay. So, you know, you're kind of getting used to all the scenarios. So it's like automation testing when you are doing it manually. Like you are going there, you're pressing this button, you check that everything is correct, and, you know, it's like really, really fast. So if you're doing for the first time, it's complicated, but then you are getting used to it. So it's kind of easy and simple.
That's cool. We had another question from the chat, which was to ask if TeamCity had any templates to help with working with previous versions of Unreal Engine there. So I know you were working in the code you've got set up there works with lots of different versions of Unreal. Are there any templates in TeamCity to help with that, or is this all sort of custom built?
Well, that
looks like we've lost you again, I'm afraid. Streaming's causing problems.
I don't understand.
Streaming is hard. Yeah, we can hear you. You are back.
Yeah, okay.
That's
okay.
Fine.
1 second. Yeah.
No, I think we might have lost Oleg there, unfortunately.
Yeah, can you?
We can hear you, but I think your stream's frozen. I think we might have to move on. So thank you very much, Oleg. Your session was very interesting. There's a lot of great comments about how well you did in the chat there as well. So thank you very much, and I think we'll move on to the next speaker. Thank you, Oleg.
Thank you. Yeah, and we'll try to answer the questions in the chat later. So don't worry if you like have a question to Oleg. We'll do that. And so, yeah, let's welcome our next speaker. So we are back to the CI topic. So we have Tadashi here. Let's add him. Hello, how are you doing?
Hello.
Hi, Tadashi.
I'm good, and you?
Yeah, having fun?
Yeah, excited.
Yeah, I actually wanted to ask you because, like, you know, the game dev is that much an exciting area. So I wanted to ask you actually which games are inspiring you?
Inspiring. So I think so. There are many mobile games, specifically like in Japan. So like that's why I'm excited playing this, and like since there are more like game developer in Japan. So that's why like I'm interested in like how like game development was, like what's their problem. Yeah.
Yeah, that should be exciting. Yeah. Okay. So Tadashi is a senior solution engineer in Circle CI, and so today he will be talking about another topic around CI. We previously had Daniel present, and now we have another topic around that. So let's move to that. So I think if you get to go, Tadashi.
Yes. So again, hello everyone, and thank you for joining this session. And I want to thank organizer for holding this event. I'm Tadashi Nemoto, and this session title is Scalable and Cloud-Native Mobile Game CI/CD Environment using Unity. Let me introduce myself. I'm Senior Solutions Engineer at Saku CI, and I technically support development teams to introduce or improve Saku CI and CI/CD techniques from web, API, infrastructure to mobile and gaming. Previously, I was software engineer in test and DevOps engineer to implement, improve CI/CD, automated test, and so on. You can know about me more on GitHub, LinkedIn, and my portfolio site. This is a description of this session. This session provides an easy-to-follow introduction to creating a scalable and cloud-native mobile game CI/CD environment using Saku CI, Game CI, and Unity, which enables you to continuously deliver high-quality mobile games. This is the agenda of this session. First, I will talk about the importance and challenges of CI/CD in mobile game development. Then I will explain the overview of Unity mobile game CI/CD pipeline using Game CI, Fastlane, and Saku CI. After that, I will explain how to create this CI/CD pipeline step by step. Finally, I will summarize key points and there's time for Q&A. So if you have any questions, I will answer them during that time. First, I will talk about the importance and challenges of CI/CD in mobile game development. Nowadays, mobile game development has been actively developed all over the world. Mobile game is getting important from business perspective for several reasons. For example, since most of people already have mobile devices such as iPhone or Android, there's potential that many people play your game compared to PC or console games. Since we only have to submit game app to Apple App Store or Google Play Store, and these platforms distribute worldwide, your game app can be highly profitable with low cost. And since you can play mobile games anywhere and anytime, users can play your game long time and continuously. Let me explain the characteristics of our mobile gaming from development or product perspective. First, as mentioned, mobile games can update software with low cost. Second, in order to play games for long time continuously, retention rate is important for success. Third, since mobile games are played from various devices, even from tablet, we should continuously improve its quality for various devices. Therefore, it's very important to provide and improve features quickly and continuously. And CI/CD is essential for this development. We understand the importance of CI/CD in mobile game development. However, implementing and managing mobile game CI/CD is not easy compared to such as web development or API development. There are mainly 2 points of challenges, and first point is managing build fleet. Especially iOS platform needs to be run on Mac, and normally you have to buy Mac hardware. There's option to use cloud providers such as AWS, EC2 Mac. However, there's lots of limitations and cannot use easily compared to other Linux machines. In addition to maintaining Mac hardware, you have to regularly update Mac OS and Xcode, which happens several times per year, and it's very difficult to automate. Second point is difficulties setting up CI/CD pipelines. If you are using Unity for developing mobile games, and if you want to run CI/CD pipelines, you have first install Unity editor to each machines. After that, you have to activate Unity license to these machines and prepare build script for each platform. It's difficult and troublesome to setting up from scratch. Therefore, some mobile game projects are not yet implemented CI/CD, and build and test are run on local machines. Or currently managing on-prem environment such as Jenkins, but there are problems. For example, high maintenance cost. When your game or development team is growing, but it's hard to scale development. It's not easy to enhance developer productivity, such as build and test are slow, or like build test are freaky, unstable, and poor debugging experience. I believe some of your development teams are working remotely, but on-prem CI/CD environment is not suitable for remote development. Therefore, I don't recommend keep managing on-prem CI/CD environment. I talk about the importance and challenges of CI/CD in mobile game development. Next, I will explain the overview of Unity mobile game CI/CD pipeline using GameCI, FastLane, and CircleCI. First component is GameCI, which is open source project. As I mentioned, CI/CD setup and maintenance, installing Unity editor, activating Unity license, build settings per platform. GameCI helps to make it easy to implement them. GameCI now supports CircleCI, GitHub Actions, and GitLab CI. This time, I will use two components provided by GameCI. First one is Docker image, which Unity editor is installed. Second one is CircleCI orb, which is reusable config packages, which make setting up pipeline easily. Second component is FastLane. FastLane is open source project written in Ruby and helps automate tasks specific to mobile app development. such as running tests, taking screenshots, iOS code signing called FastRate Match, build, distributing beta or debug versions, and releasing to Apple App Store or Google Play Store. Fastlane is mainly used for mobile app development, such as native iOS or Android, React Native or Flutter, but can also be used for mobile game development. Third component is CircleCI. This is where CircleCI sits in the toolchain. CircleCI currently supports GitHub, Bitbucket Cloud, and GitLab. CircleCI triggers from these VCS changes and run, build, test, and release. For release, you can integrate multiple platforms such as AWS, GCP, Azure for cloud. But you can also automatically release to App Store or Google Play Store. CircleCI provides several powerful features, but one of the most effective features for game development is resource classes. CircleCI provides multiple free managed build machines from Linux, Windows, macOS, ARM, and GPU instances. In addition to it, these resource classes have options, for example, medium, large, or X-large. You can easily customize which CPU or memory you want to use. As you know, gaming CI/CD needs lots of memory and CPU, so you can optimize these build and test and run faster. As I mentioned, Mac is needed to build for iOS platform, and CircleCI also provides powerful and constantly updated macOS environment. In addition to Intel Mac, CircleCI started to provide M1 Mac, which includes M1 Medium and M1 Large from 2023, which is up to 2 times faster build speed than Intel Mac. We are constantly updating new Xcode version, not guaranteed in SLA, but we aim to support a new Xcode version within a couple of days. I summarize the advantage of using CircleCI for mobile game development. CircleCI provides various and powerful build environment for game development, and no maintenance is required, especially for Macs. It scales automatically as needed and charges based on time and resource class of the build. I took the overview of mobile game CI/CD pipeline using GameCI, Fastlane, and CircleCI. Next, I will talk how to create this CI/CD pipeline step by step. First, we will activate Unity license to use in CI/CD pipeline. Activation varies depending on the license used, and in this example, we are using a personal license. If you want to use another type of license, please check below link. In order to activate Unity license, we should create an activation file. This config file is a CircleCI pipeline to create activation file, and this uses GameCI to simplify settings. After running this pipeline, you can see unity.alf file in Artifacts tab. This is activation file, and we will download this for next step. After downloading the activation file, we will upload this to manual activation site by Unity. After upload and activate, you can get .ulf file, which is license file. We will download and use this license file for running pipeline on CircleCI. So how to store Unity license file to CircleCI? CircleCI provides secret management called CircleCI context, and you can store environment variables securely. This time, we will encrypt the license file with base64 and put as Unity encoded license. In addition to it, we will add Unity username and Unity password. We activated Unity license, and we are ready to run Unity CI/CD pipeline on CircleCI. Since we want to build Unity project for both iOS and Android platform, I created two pipelines. I will talk Android part first. This is CircleCI job called Build Android. At top, you can see we will use game CI op, which we used previously for activating Unity license. Build Android job consists of two components, executor and step. In executor, we specify Docker image provided by game CI. As I mentioned, this image already installed Unity editor, so you don't have to additionally installing it. In addition to it, since we specify target platform to Android, software needed to build for Android platform, such as Android SDK, is also installed. Resource class is Xlarge, which is build fleet provided by CircleCI. In steps, first we check out source code. Then we prepare use environment variables such as Unity license, which we put previously. After that, we build for Android platform. Build target is Android. After this step, you can get Android binary called APK, and we will use this binary for next job for distribution. After the build pipeline is completed, you can see CPU and memory usage of the job. As previously mentioned, CircleCI provides feature called resource classes, and you can optimize this resource class using this dashboard. For example, if the job hit 100% CPU and memory usage, you can upgrade resource class to speed up build and test. On the other hand, if the job does not use CPU and memory so much, you can downgrade resource class to optimize cost. After we build for Android platform and get APK binary, we will distribute this to Firebase app distribution using Fastlane. You can also distribute to Apple App Store or Google Play Store if you change the Fastlane code. Since FastLane is a Ruby project, in executor, we specify Ruby Docker image provided by CircleCI. In steps, we check out source code, attach build binary, which is APK, install FastLane, and run FastLane command to distribute Firebase. You and your team members can download the game app and debug with them. That's build and distribute for Android platform. Next is build and distribute for iOS platform. This job is called export iOS. This job does not change so much compared to Android job, which I explained. We will use same game CI org, and just differences is target platform and build target. This time we change this to iOS, not Android. However, there's a differences in building between Android platform and iOS platform. For iOS, previous job just generated an Xcode project from a Unity project, not the application binary compared to Android pipeline, which I showed. If you want to get a binary for iOS applications, which is .ipa file, you have to build this Xcode project in macOS environment in which Xcode is installed. Therefore, in next job, we will build this Xcode project in macOS environment. This is job called build and beta iOS. As you can see, this time macOS executor is specified. Xcode version is 14, and resource class is M1 Mac Large. In steps, first check out source code and attach the Xcode project, which was generated in previous job. At last, install FastLane using Ruby org and run FastLane command, which includes code signing, build, and distribute to Firebase. This is FastLane code. Since this is too long, some of codes are omitted. You can see full code from below link. First, we do FastLane match to fetch iOS certificates. After updating some code signing settings, we build the app. As you can see, the project path is in the build folder of Unity project. After build is succeeded and generate IPA file, we will distribute to Firebase app distribution. You can download and debug this iOS game app on Firebase app distributions after all these FastLane succeed. If you want to know more about this CI/CD pipeline, you can read my blog article, which describes in detail. Demo is also available on GitHub, so you can fork and play. At last, I'd like to summarize the key points. First, I talked CI/CD is essential for continuous development mobile games with high release frequency. However, CI/CD in mobile games tends to be a challenge in terms of build machines to run, especially Mac, and difficulty of setting up. In this session, I explained Unity Mobile CI/CD pipeline using Game CI, FastLane, and Circle CI. Game CI makes it easy to activate Unity licenses and build for iOS and Android platform. FastLane makes it easy to set up code signing called FastLane Match and distributing such as Firebase, Apple App Store, or Google Play Store. Circle CI provides maintenance-free and on-demand build machines required for mobile game CI/CD, including Mac. That's all for me. Thank you for watching. And if you have any questions, I will answer them during this time.
Yeah, thank you, Tadashi. That was great. It was very insightful. We indeed have some questions, so maybe we should start with some basic ones because looks like we might be missing some important differences. Like, for example, what is the difference between a job and a step? Maybe you can just
Job and
explain that.
step. Okay. Job is the Circle CI's definitions of, for example, build and for example testing, and you can do organize to for example parallel, or if build is succeeded, you can do it testing and distributions. And in steps, so it's in jobs and you can specify what to do. For example, normally we first check out source code, and for example you can do, for example, creating build script, or such as distributing or anything you want in shell script.
Okay, yeah, thank you for the explanation. Okay, Matt, do you see?
Well, I'm going to jump in with a question then. I was going to ask about the, again, about large projects and how you handle large projects, large assets, and so on.
Yes, thank you very much. And I heard from customer the game project is very big, for example, large asset, and they cannot handle with cloud provider. So in that case, I recommend to use that's called self-hosted runners. And if you connect to Circle CI, so you can build on your machines. So for example, in Linux environment, you can create self-hosted runners and make it easier to run these large asset build environment. But I suggest to utilize macOS environment as much as possible. For example, if there's big large asset projects, and first we build for iOS project, and there's Xcode project is creating. And after that, we will upload to our Circle CI macOS environment and build the binary. So you have only to manage Linux environment, not macOS environment. It's fully managed. So I recommend such way. Yeah.
Yeah, okay, thank you. And you talked about, I guess, Unity, and what about the Unreal Engine?
Yes, about Unreal Engine, actually, Unreal Engine also supports and provides Docker image. So you can run at the same. Game CI does not support it, but you can specify Unreal Engine Docker image, and same flow for Android. I think it's already, you can build on its Docker image. For iOS, you can build Xcode project in that container and build on macOS executor.
Okay, got it. Maybe Godot, quite popular in our chat.
I'm not sure. Yeah, maybe I'll take a look.
Yeah, but literally, we have quite many people trying Godot today in the chat. I think they will all wait impatiently for our Godot talk after lunch. Yeah, it's great to see. Yeah, okay. So Matt, do you know if we have anything else there?
I think that's it for questions, to be honest.
Yeah, I think that's it. So yeah, thank you very much, Tadashi. That was really fun and very insightful. So thank you.
Thank you very much.
Thank you.
Yeah, bye. Yeah, actually, Matt, I was following the news here, and we are missing this, picture of the breaking news. I just read that UK actually agreed on the Microsoft Activision Blizzard deal.
Yes,
It's happening.
finally, it's gone through.
things are happening.
I wasn't sure whether that was going to get agreed or not, but yes, finally it has happened. We do need the
so
big breaking news splash
forward.
across the screen there. Yes. So yeah, I mean, that would be interesting to see what people think about that. Pop your comments in the chat and let us know whether you think this is a good thing or a bad thing, or what's gonna change and what's gonna be improved by it.
Yeah, we can only hope that the change is for the good, but let's see.
Yes, exactly.
Yeah. And I would suggest, since we have some time before the next speaker joins us, I would suggest we play a raffle. And what JetBrains could raffle? Matt, what do you think? What we could raffle?
It's a tricky one, isn't it? How about a license?
I like that. So yeah, I think we can raffle a license. Yeah, and so I guess we can do .ultimate license, which not only covers ReSharper and Writer. So if you stay in Visual Studio, would like to continue your development in Visual Studio, you install ReSharper extension on top. If you would like to extend alone tool, you take Writer. But also .ultimate includes our profilers like .trace, .memory, and also a coverage tool .cover. So let's raffle a license. How are we going to do that, Matt? What do you think?
How about we just ask a nice question, and whoever replies first in the various different chats we've got going can get a license.
I like that. I have some questions here. So let's indeed do that. So if you throw your answer first and it's correct one to the YouTube, then you'll be the winner. You can also, if you're on Cyprus, voice it to your host, make sure he can actually hear you're the one. Yeah, and other channels, they're also covering them with other hosts. So
we're going to have to be careful not to actually say the answer before everybody has had a chance to reply as well.
Yeah, we'll do that. So we'll give some time to the people. And I actually, because I mentioned ReSharper, right? So that it's covered by the .ultimate license, I would like to start with a question about ReSharper. So when was JetBrains' first .NET tool, ReSharper, released? So the year is just enough. No need to tell us the exact date. But if someone remembers that, that would be awesome. I don't know, maybe. And yet ReSharper team can't answer, please, if you're on stream. Don't do that.
Yeah, no shouting out. And bonus points if you were using 1.0 there as well. You don't get anything for bonus points, but there we go. My first version, I think, was 4.5 maybe. But that was when I was first introduced to ReSharper. So I've been using it for a little while now.
I joined JetBrains later. I haven't seen here the first version of ReSharper, actually. Yeah, even though it's quite many years for me here, but still. So we have answers coming. I see a correct answer among them. So let's just give some other channels a little bit more time.
We need to hear from Cyprus to see if they've got a result as well.
Yeah, so let's just give them some time.
But I do remember the first time I saw someone using ReSharper. It was doing some pair programming, and I was sat down, and somebody was just an absolute wizard at ReSharper, and it was just the whole kind of like, how did you do that? It's like, show me that keyboard shortcut. They were flying around the code there. It was fantastic. It's a very impressive way of getting you hooked, showing somebody who knows what they're doing, and then. Yeah, we would kind of regularly swap keyboard shortcuts because that's how exciting we are. That we'd like to swap keyboard shortcuts, but yes, been a big fan of ReSharper, and then the other tools ever since, really.
Yeah, that's true. Okay, so we have the correct answer, and literally like, yeah, the correct answer is like coming from Martin, but Martin, you're not counting because like you're not the first one and you're from the .NET team. Okay, so the correct answer in YouTube was coming first from the Gabriel Federico. So what would do for you to get the prize will be very, very simple. So I will just write you my email here in the chat, and you'll write me an email in return, and I'll send you the license. And that's how we're gonna handle this today. Okay, so it's year 2004. Can you imagine that? It's how much? 19 years already? Oh gosh.
19 years,
19
yeah.
years, yeah. And like the product is still evolving a lot. It gets many new and insightful things. Like quite recently, we added AI assistant to all our tools, including ReSharper. So it's kind of limited access right now, testing mode still, but I do hope it will come out of this beta stage quite soon. And actually, yeah, it uses the whole power of the AI to help you write, like, for example, Unity games. You can like ask AI for some help with your Unity game. Not sure AI will write a full game for you, but at least you can rely on some templated codes and steps probably. I don't know, Matt, have you tried writing the games with AI?
I haven't tried doing the full thing, but it's quite. One of the things that's really nice is that we give it the context of what your project is. So your project knows, so the AI assistant knows that you're in a Unity project, and it can use that context when it's making the request. So you can say in the chat window, you know, how do I add an editor window? And if you're in a Unity project, it'll understand that it's a Unity editor window that you're trying to do, and it'll show you a snippet of code which you can then add into your project and work with a nice editor window. So it's good to be able to give it that sort of rich context.
Yeah, and it's actually available not just in ReSharper, it's also in Writer. So if you're there, you can try it there. Yeah, and it can help with many things. I especially like that it like follows where are you exactly, that you're in the Unity, say, project, and suggests you the relevant stuff. Yeah, okay, so that was nice. Let's maybe do another question. We still have some time to play around. So let's now do something more game specific, okay? So please write the name. So which company's conference was Unity Engine announced? So do you remember that? So
that's
just
a good
write
question.
the name.
So when Unity was very first announced.
Yeah.
Okay.
When was that?
That could be another quiz question. Let's
okay. Let's first deal with the name. Okay, yeah, let's first deal with the name. Yeah, I'm wondering if like the people could jump on that with the correct answer. Actually, I do hope that we'll learn about some conferences maybe from the answers. Not that many options for now. By the way, I don't know like how many people are here on the stream who are like going to GDC regularly, like maybe was this year or going next year. We were at GDC this year. It was so exciting, right, Matt? It was like full of fun.
Oh, it's a fantastic exhibition. Yeah, it's absolutely huge, and there's so much going on there. There's so many different companies and different things being shown, and the number of people you get to talk to, and the variety of people as well. So being an IDE tooling company, we do go to a lot of conferences, but quite a few of them are sort of more business oriented, enterprise oriented. Game dev is much more interesting because you don't know who you're going to talk to. People come up and say, "What does JetBrains do?" And it's like, well, what position do you do? And they could be a level designer, a musician, a story writer, a character designer, an animator, a coder, and so on. There's a huge variety of different disciplines at work there, which is it's really exciting, really interesting to see how people use the different tools to do different things. It's a great conference. I really enjoy it.
Yeah, that's true. And like what I personally enjoy is that it's very, very different. I mean that you can find like a huge booth for like Epic Games or Unity or Amazon or like Google, but you can also like find these indie games, small booths, and just go play and enjoy. And it's like so much fun. And like you talk to these people, and like they all are in this game development, but just doing different things. That's like really exciting. Yeah,
there's the I can't remember what it's called, the alt GDC hall, where you get to see people who have made fantastic games out of anything. You know, there'll be like a puppet game where you have to put on a puppet show, and you get scored points for doing that, or you know, it's the equivalent of the goat simulator type stuff, and that is fantastic. Wandering around that and seeing the creativity on display is brilliant. You know, there's people come up with the craziest ideas, and yeah, it's all games, it's all fun. It's great.
Yeah,
It is my favorite conference of the year.
Yeah, that's true. But coming to the original question, like Unity engine,
yes.
it was actually officially first announced at Apple conference. So, Michael Ryan, you were the first. I pinged you with my email address. Just drop me a small email saying that's you, and I will share a license with you. And with that, I think we can bring our next speaker and say hi to him. Hello.
Hello, everyone.
Dmitrii.
How are you doing?
Hey.
I'm well, thank you. And you?
Good.
Mm-hmm. So we have been asking, you know, well, what kind of games inspire you? What's your favorite game? What was your first game system?
It was an old Soviet 8-bit PC, and it was a games like Arkanoid and something like that, maybe Shake, Snake.
Yeah, some proper classic
old school, yeah.
Yeah.
I'm always keeping it old school. This is good.
Yeah. I actually wanted to ask a specific question to Dmitrii, because I read in your bio that you're the member of the International Game Developers Association. So I was wondering what it actually does. So what is responsible for, what it is about. Maybe you can briefly tell us.
Yeah, inside this association, I usually doing mentoring of some students, and sometimes I have some benefits from events like this, and Gamescom and other. Yeah, and when you become a leader of some chapter of this organization, you can provide some meetings, some calls, some events to boost your community, to share your knowledge and so on.
Yeah, sounds nice. And I also saw a mention of the Academy of the Interactive Arts and Sciences, which is also sounds intriguing. What's that about?
Yeah, you have to release some projects in game development, and you have to you need to have some years in game development industry and working projects to be part of this organization. But it's mostly the way to have some discounts on some conferences, some talks, and be ready for to be involved in some events, so like this, for example.
I see. Yeah, that's interesting indeed. Yeah, that sounds good. Actually, by the way, just another question from a different thing completely. So we were asking you about your first games, but do you play now? I mean, I've met many game developers who told me yeah, we're big fans of game, but we don't have time for playing now. Do you play now?
Yeah, I really play, but usually I try to communicate with physical world more than virtual. Yeah.
Okay, so virtual world is enough at your job for you.
Is enough, of course.
Yeah. Okay.
Yeah, this is it's always tricky to find the right level, the right balance of you know, spending as much time as possible in front of a computer and also seeing the real world as well. But it's good. Yeah, I don't find that I have much time to play games these days either.
Yeah. My kids are playing. I mean, they have time.
Oh yeah. Yeah, loads of time.
Yeah. Okay. So should we proceed with the talk now? So are you ready, Dmitrii?
Yeah, I'm ready to start.
Okay. Yeah. Then you're good to go.
Okay. Hello, everyone again. Thank you for joining us today. My name is Dmitrii Ivashchenko, and I'm a software engineer at My.Games. And in this session, we'll talk about Vue classes in Unity UI. And let me briefly tell you what I do. I've been making video games for over a decade now, and I started with development browsing and some Flash games, then switched to Kakao engine, and later started developing games on Unity. We have released many browser MMORPGs like Legacy of Dragons. We also produce some clicker games developing using Lua language and the Cocos creator, and many Unity projects like Evolution, Battle for Utopia, and our latest hit, Rush Royale. Let's discuss the primary methods of organizing layout in Unity UI and consider the state-based UI development. We'll touch on some issues of reducing the amount of code, generating API and documentation for prefabs. And in order to have a more productive session, let's outline the scope of our conversation today. We can find different architectures and patterns in different projects, and certain projects may be rooted on MVP or maybe MVVM, or it could even be designed around the principles of clean architecture. But in any case, we always have a bundle of a mono behavior successor and the prefab it resides on and interacts with. And at this level, we usually deal with changing sprites, localizing some text, changing the appearance of screens depending on different situations, and maybe playing some animations, getting user input, and so on. In our case, to manage all these elements right from the code, we make use of component which is situated on the prefab itself, and this precise combination is our focal point for this discussion. When starting to discuss this topic, it's necessary to realize that first of all, we will talk about Unity UI. And we cannot fail to mention another existing solution in this area, of course, known as a UI toolkit. And this alternative has relies on heavily standard common web techniques that you may already be familiar with. But despite the fact that it's 2023 and the UI toolkit has been around in use for some time, it's not still not the preferred option for creating user interface at runtime. According to Unity's documentation, they still recommend using Unity UI. Yeah. Now let's look at the offerings that Unity provides us out of the box at this level. And the first one is, of course, serialized field. Everyone is familiar with this approach. When you open any tutorial on the internet, you immediately get here. And what's prepared for us here? Yeah, we create an inheritor of mono behavior. Serialized field are added in this class, and draw any reference to internal game objects into these fields. And that's how it works. From the code, we control colors, object positions, animations, sounds, and anything else. And what's interesting about the solution, yeah? The fact that over time, these view classes based on mono behavior start to grow continuously. And the more functionality we need, the more we need references. The more we need something to change in our UI, something to move, something to hide and show. And for this, we need more and more links. It becomes difficult to navigate and understand these links. It's difficult to maintain their proper naming so that it's obvious what is responsible for what. So we end up with a solution that as efficient as possible, but it's much more efficient than anyone will ever notice. And at the same time is the most labor-intensive. Implementation of any change in the user interface built in this way is done only by a programmer. And programmers' tasks have expected and known costs because they have to be reviewed, merge conflict have to be solved, and tests have to be covered. That's the whole set of related tasks. And in the end, we get such some expensive, maybe long, but very efficient solution. Yeah, an additional system that came across in various projects can be called as all-powerful animator. It configured quite simply. We have a root of our prefab, and we augmented it with an animator controller. In this controller, we create a unique graph. This graph, combined with animation, drives our user interface. And It controls many elements such as text placement, button color changes, position of different elements, and it's essentially a way of organizing our layout. And at this time in Animator, we need to create several variables, and it can be triggers, some Boolean values, maybe integers, maybe floats, and programmers have access to these parameters. They can change them at the right moments. It will affect the controller, which in turn will change our user interface. Customizing the solution is easy enough because we use only Unity's built-in toolkit, and it's quite easy process. However, as time goes on, we start to discover potential problems. The first Animator supported window appears, followed by a second, then a third, and we discover one day maybe 5 active screens, each controlling different animator in each frame, and we may notice a gradual decrease in the frames per second rate. So this solution is really fast to configure and inexpensive, but unfortunately, it's not efficient enough in terms of performance. And another alternative is to utilize the conventional animation component. With this method, you can control the actions of prefab without having to use the animator. This is how performance optimization is achieved. Along with the prefab, programmers are provided with a package of animation files to be used at particular point in time. And using the standard tool provided by Unity, making modifications become user-friendly and swiftly done. But naturally, the principal downside of this approach is not avoidable. It is the challenge of altering the animated prefab. In the animation timeline, all changes are committed based on the location of the game object in the prefab hierarchy, as well as the names of the elements. And as soon as you change the name of one of key game object or its position in hierarchy, your animation breaks. And particularly if the modification impacts a state that is seldom used, this type of error can be easily overlooked. The next is data binding. The principle of data binding is interesting and advanced technique software development. It's important to know that it's not a built-in solution, so using it will require evolving third-party libraries or creating your own. And the main purpose of using data binding strategy is to establish a clear separation between logic, data, and visualization. This separation is important not only for integrity of the project, but also for adapting the visual component without interfering the business logic. And this task is solved by implementing the model view model architectural pattern. Schemas become widespread in numerous frameworks. This strategy is based on a special mechanism that creates a bridge for data exchange between the view and view model. View model acts as an intermediate structure between the view and the application logic. And despite all the advantages of this approach, it has its own disadvantages. Although it is beneficial for large projects, it requires initial training, and it's very difficult to debug sometimes. In addition, using data binding can become unexpectedly complex and redundant, especially in situations when you need to quickly prototype a new idea for testing or evaluation. Yeah, and now we've highlighted some problems from out-of-the-box solutions, and let's move on to stateful UI. And first of all, what it is. Like many libraries, this one was born out from a pet project, and I was looking for ways to separate layouts and the implementation, but still maintain a robust format of interaction between these components. Then my team and I tried it out in production, and everyone liked it, and we decided that it was worth releasing to open source and at some point. So what the library is, at the heart of the library is the stateful component. It's added to the root of the prefab of our screen, and it contains named references to all elements that we are interested in from the code. And the link contains a field with an object as well as a role. A role is an ordinary enum from the point of view of the code, but we generate it automatically. Elements don't need to be added to this enum manually. All these processes and adjustments can be widely controlled and executed from the inspector. And the hash code from the string that with the role name is used as a value. It allows us not to overlap and merging. In a situation where someone else create a new role within our branch at the same time as you, merging these changes become relatively more manageable. And stateful component aims to cover all user input and output. It collects all references to buttons, some texts, maybe images, animators, and any other elements. Anything we would like to use from code. And each link comes with its own role. And as a result, we get a complete markup of all elements inside our prefab. And then having references to all these objects, we can access them from code using just one reference to our stateful component. The example shows how we refer a text. You can see that view is our stateful component. We have a title role, and we set the text for it. At this point, this list of the UI elements on the right is supported. It includes buttons, images, text inputs, drop-downs, and so on. And this list can be extended. And for what is not supported at the moment, there are separate abstract type object, which is just a reference to game object. You can get any component of them later. However, the correct approach is to expand the list of available types, of course. And the library already implements a large number of getters and setters for each type of supported UI elements. For example, get button, get toggle, get slider, and so on. And there are also setters. For instance, in the example screen class, we set the value of hours, minutes, and seconds in the timer, and then we set image with the role of user avatar. The library can either use the path in the resources of image or regular sprite. And in the example, you can see how buttons with specific roles are fetched and how event listeners are added to them. In this case, you can either use a reference to a stateful component, but alternatively, you also have a choice to construct an inheritor class stemming from stateful view. In doing so, an automatic reference to the stateful component will be gained by the inheritor class. It will also have a set of methods of the same name for quick access to them. And now let's talk about text and localization. This step is a bit different from others because there is more information here. And we support working with localization stateful component, but we have not included any localization engine in the library. This means that when using the library, you can adopt any custom localization system, whether it's based on Google tables or maybe your custom backend solution. And this can be done easily by implementing a very simple interface. And localization key may be noticed in the code column. And you can also notice the localize column. It's responsible for the necessity of localization because not all texts are interesting for us from the localization point of view. For example, player level and player name are not subjects to localization. All the rest are marked with a localized checkbox. We come up with a localization key, and then implementing one simple interface, we get a translation. Marked codes together with these values can be taken to the clipboard using the copy localization button and immediately passed into Google table, for example. Now let's dive a bit into the detail of internal components. So far, we've considered stateful component as a component on the root of the prefab. However, it's important to know that it's not always the case. There are times when we desire to use some elements of our prefab repeatedly. And for this purpose, we have made support for internal components. Take, for example, as can be seen at the image, our example screen incorporates two additional components. There are the header and the footer. In the section inner comps, we have established links directed to these internal components. The links are also named header and footer, for clarity. And header and footer themselves can be nested prefabs and can be reused in other windows. Upon successfully marking up our internal components, it becomes available for usage within the code. We can get the component using the get inner component API method. All they need is role name and all. Now we can access our internal view, which we can interact with using the exactly same methods. Now let's talk about containers. Internal components is the way to do static markup, but we often need to add content dynamically, for example, lists of different objects, And containers are handy tools for this exact purpose. Containers work in tandem with container view component. It's a small component in which you can put a reference to a prefab and specify the route where this prefab will be instantiated. Each container has its own role, of course. In this innovation, you can see two containers, the player container for leaderboard and the stars container for stars at the bottom of the screen. After configuring the containers, you can add and remove objects directly from the inspector. This is useful when we need to test the adaptability of our user interface to different screen sizes, as well as to make sure that our UI behaves correctly when overflowing. Once we've made sure that our UI behaves as expected, we move on to the code. And the right side shows how we can fill the container with items using fill these items method. You can pass in a collection and a method that will be called for each item in the collection and its own view. In addition, we can use some methods like add instance and add stateful component to manually control the process of adding objects. So by default, we use simple object.instantiate method to create new instances. But if you're not satisfied with this method, you can override this behavior, for example, to instantiate using your DI container, like Zenject, So far, we've talked mostly about the markup, but in this library, much more attention is paid to user interface states. Let's understand what we will call states here. Let's consider this example, these two screens. On the left, we have reward screen, and on the right, the card screen. On our reward screen, there are multiple states or stage or situations present. Let's say the first state, intro, will display chest. The second state, reward, will show animated appearance of the reward from this chest. And the final state, summary, we will summarize and display the total number of rewards that have been given out so far. There are these three configurations within the same window we will call states. And it's a different situation of your screen, of your window. And now let's take a look at the right, the card screen window. In the left state, we can improve our card. Here, the button is green, the characteristics are highlighted. And in the left state, we can't improve the card. The button is gray and the characteristics are dim. And these two states can be labeled as upgradable and locked. So let's see how it's implemented. Each state is a named set of changes in the prefab. Every individual change can be considered as an instruction. These instructions may include various operations, such as turning an object on and off, changing sprite, changing the position of objects, starting an animation sequence, starting a sound effect, and many more. The more types supported, the more convenient it for us to work with our user interface. We gather all these various changes into a specific set, and this set is something we've named description. Let's take a look at what description includes. On each state, there is a test button. Upon clicking this button, it triggers the corresponding state into activation. You can see at a glance what the state looks like, how it changes the layout, and how it fits these other states. And all of this happens in edit mode. We've even learned how to play animations in this mode. And with a full set of customized states in place, we move on to the code. The most commonly used and simple state function is to turn objects on and off. To do this, just select the game object type, then drag the desired object into the field and specify whether to turn it on or off. Next is image. In state description, you can control many parameters of image objects. In addition to turning rendering on and off, setting specific sprites, you can set a specific color, for example, or material. You can also set material parameters from the state. In this case, a separate instance of the material will be created, allowing you to apply spot effect to a specific image. The figure on the right shows how the frame sprite around the character changes when switching between common, rare, epic, and legend states. In addition, you can control any text parameters. You can replace text with any localization key. You can control the size and the position of the text. You can change the color and font of the text. Yeah. And the example on the right shows how the content of the text item change at the same time and as its color. In the state settings, there are a wide range of tools for working with rect transform. Here you can set any object positioning, dimensions, any constraints, so you can fully control and customize your rects. And the animation on the right shows how the position and rotation of our tooltip arrow changes. This way we adapted it to display tooltips to elements located anywhere in the screen. Also, you can control the canvas group properties. You can change the alpha and the interactable parameters. This is useful when you want to add a state that blocks user input or disable rendering of some UI elements. Such customization provides flexibility to our user interface. And states is also a good place to customize animations. You can run one or more animations at the same time. You can stop animations from the state. And you don't have to go into played mode to test the state with customized animations. We supported sampling animation frames in the editor coroutine. So you just need to click test button to preview the animation in edit mode. No animation or animator component used to start the animation, but the animation clips themselves are needed, yeah, on lead. And the animation has the ability to use some events, and we supported this feature as well. On the right, you can see how we use state to stop all animations on the prefab and replay the animation of get on level and idle. And of course, any animator manipulations are supported. From the one state, you can set the necessary parameters to several animators at once. It makes them more detailed and convenient for use. It supports working with triggers, setting bools, integers, and float values. But in general, animator support is implemented to overlay a set of ready-made animations, controlled by animator in some existing screens. You should use animator only in rare cases when it comes to some complex animations, some maybe blendings and layers. In all other cases, it's sufficient to use a pure animation for it. Along with support for internal components and stateful component nesting, we implemented support for activating desired states in internal components. You can have small customizable prefabs on which to build a large, complex user interface. Here we impose only one reasonable restriction. Yeah, only child objects with any level of nesting can be managed from the parent object. In this case, the states of the end screen will control the states of the internal components. In the example on the right, you can notice the simultaneous change in text about rarity and the border around the character image. In fact, the entire character cell is a separate card view prefab with customizable states, and it's reused across multiple screens in a project. And the purchase confirmation window states change only the text and apply the desired state to the card view. We support other types of elements as well. You can control the clickability of buttons using UI states. You can manage change material or any graphic elements. You can change the configuration of the layout element. For input field, you can control the interactable property. There is an option to regulate the functionality of entire game object or its individual components. Presently, we supported most common element types along with the most frequent modifications related to them. And one of our goals for next version is to support all the user input and output elements and all types of interactions with them. Another goal is for the next version is full support for sounds through states. Playing sounds and stopping them will be available, and this feature is already available in one of our projects, but it's a project-specific solution, and in the near future we'll release a universal solution that can be integrated with any sound system. Along with named states, you can configure a init state to be applied each time on the onEnable method is called. Typically, a reset of the screen to the initial state is configured here, and so you can always expect that user interface will be in certain state when it's opened, to which the following modification can be applied. It's also a good place to set up the opening animation of the game screen and maybe play some sounds of its appearance. Yeah. From the code perspective, applying a state is some is called an API method with a role specification. This approach allows us to significantly reduce the amount of code of our view classes. We no longer need to move elements manually, change any colors, texts, sprites. Yeah, all these used to be done from code, and it was very long and cumbersome. We had wait to compilation every time after adding fields. We often lost the links on the prefabs. But now with the customized states, we know exactly what they work, and we can just apply the desired state by its name. In this example, we changed the color scheme depending on the time of the day. It's a small artificial example just for clarity. Yeah. Now, we should mention one more feature of the library. In fact, it's very convenient to use states. However, when there are more states over time, we have another problem. First of all, maintaining a large list of states is not very convenient. For a complex window, we had a number of states increased to 50. And a long list of states is not convenient for perceive. And secondly, over time, there appear states that make sense only in the context of some other states. And to solve this problem, Stateful UI has another tool, the state tree. It can be accessed by clicking state tree editor button on the states tab. Yeah, for example, we have on the left, we have a box with our rewards, and tree center states, money, emoji, and cards are all dependent on the reward state. The reward state plays an animation of chest bouncing, and internal states themselves only change the type of picture that comes out from the chest. The money state appears coins, and the other use emoji or a card. Yeah, we also have two other states, intro and results, which are responsible for appearance of the chest and the display of the summary page. The money emoji and card states only make sense in the context of the reward state, and the intro and result states have no dependencies. On the right is a code snippet that describes the behavior of awarding rewards. This code a bit simplified just for clarity, but in real projects, it's not much bigger. Here we can see how such a complex UI behavior on the left is implemented by such small and clear code on the right. The intro state is applied in the show intro method. Next, depending on the type of reward, we call one of three states, cards, emoji, or money. And in show results method, we show the result state and populate the total reward container with the final rewards. And in this way, state tree helps us organize the states into a dependency tree. We can pass only the necessary states to programmers, hide all other technical states, optional states, and greatly simplify the understanding of our user interface. Here we can see another example of using state tree. The states at the top part, we have many technical functionalities. They aren't used by programmers. This includes resetting states, turning pictures on and off, visibility of state entities like chests, and some text positioning. After state at the bottom, states at the bottom are functional, and they combine some of the technical states to produce the desired bubble appearance. And when any state is activated, all of its parent states are applied in a chain. Here I just wanted to show our latest state tree. As the project progresses, individual screens get more and more states that take their place in this structure. Programmers are usually only provided with leaves of this tree. All the internal states are technical, and they are needed mostly for reduced duplication of the state descriptions. And thanks to the documentation, we managed to keep the structure up to date. We'll talk about it in a few slides. And to make it even better, we added APIs and documentation. In each individual tab of the state component, you'll find options such as copy API button and copy docs button. The first one will copy the code fragment to the clipboard. Here we will get the generated code to access all named links and states. And each API call will be accompanied by a comment if one has been prepared. And the copy docs button will copy the description of our user interface in Markdown format to the clipboard. Next to each role, there is a button with a pencil icon. By clicking it, we can write a comment about why this role is needed and under what condition it should be used. The comment will be saved directly on the prefab, and the documentation can be put in your knowledge base, for example, in Confluence, and the code can be used right away. It's quite convenient for day-to-day use, keeping together the markup, the API, and the code documentation under version control. So let's summarize the result. What we get using stateful UI. First of all, it's the markup of all elements inside the prefab. This advantage allows us to organize our user interface in the same streamlined manner you know what to expect in a new prefab that our colleague made. You don't have unnecessary references to objects, and what's required is just single reference to stateful component, and it allowing us to access all the elements that have been marked up within the UI. The second place, we get the stateful component and state tree tool. This powerful tool is instrumental in massively reducing the amount of code within the view classes. It efficiently handles most tasks related to modifying prefabs. The generation of documentation APIs should be highlighted the same way, because in fact, when we generate documentation for our user interface, we may find that doing user interface and code for it can be done in parallel. We use this library in different development team configurations. Some teams had dedicated UI developers who did only prefabs, and in other teams, all the programmers were involved in layout as well, and the library suited both of them perfectly. The project roadmap includes the following items. First of all, since we have full markup for each button, text, and any UI elements, it's possible to organize a test system that will be available to interact with user interface in the same way as we do it from the code. It will be able to click buttons to enter some text into text inputs, maybe read some content of text blocks and check it. Secondly, since we have full markup, we can create scripts for a tutorial system. This can be scriptable object-based resources containing sets of instructions. And an example of instruction might be a show pointer at some button with role upgrade, for example. Yeah, and another desirable addition is to increase the number of supported elements and cover all the possible ways of interacting with them. So finally, I just want to say thank you for your attention, and also thank you to JetBrains for hosting me. If you enjoyed this, and if you want more, I suggest you to go out the project's repository. And thank you very much for having me today. Again, if you have any questions, feel free to email me and contact me to ask you questions. Yeah, thank you very much.
Yeah, thank you very much. That was very impressive.
Yeah, thanks, Dmitrii. Yeah, there's a lot of good feedback in the chat there. Lots of people very interested in this. The state trees, for example, they look really, really useful. They look like you can build something, very nicely reusable and complex, and yet with a nice user interface for the API and everything. Yeah, it looks really cool.
Yeah, and I spotted some nice comments because we have some people who are just starting with the game development. They say that they're not game developers right now, that they're just interested in the technology. So looks like you inspired them. That's good. Okay, so let's go to questions.
Yeah, the first question really is, how do you add it to your own project there? So we can see it's on GitHub, but sort of what does it come as, and how do you add it? Is it available as a package, for example?
Yeah, it's a Unity package right now. We didn't publish it in Asset Store yet. You just need to get this package, unzip it, and there will some generated classes have to be appeared in your project, and you can immediately use stateful component in your new prefabs. You can also have some existing prefabs and try to remake it for stateful view, but of course it will need you some time to put on it.
And is it easy enough to add into an existing project, rather than having to start from scratch with stateful UI?
You don't need any additional steps to adapt existing projects to stateful UI. You can immediately start making new prefabs using this library, and if you want, over time, you can adapt some of your old interfaces to stateful UIs. This almost it will reduce the amount of your code, but it also will take some time.
Sure. In fact, we're at, somebody asked. Listen, they mentioned that one of the original challenges was the usage of programmer bandwidth and the time it takes to sort of implement the UI there. Has the library sort of succeeded in that? Has it reduced the amount of time for building the UI implementation?
Yeah, you don't need to add any serialized fields in your view classes. You don't need to wait any kind of recompilation for this operation. You don't need to maintain the links because all the links contained in this stateful component object, and you just need to have the link to this stateful component and use the roles and states inside it. Yeah, so you can at the same time configure your prefab, your stateful component, and write some code without any recompilation. It's fast enough, yeah.
Mm-hmm. And it looks as well that you can do some. You can get non-developers, non-coders to actually add to your states there as well, which makes that more useful.
Yeah, it was the first purpose because we tried to make the prefabs without any programmers.
Mm-hmm. Great.
Yeah.
We've got a bit of a follow-up on the installing it, adding it to your project there. Is it just as simple as downloading the zip from GitHub, and do you then re-import that as a custom package, or do you put it in your packages folder, or quite, is it just as simple?
Right now, it's just a Unity package from the GitHub, and just download it and import it in project.
Import into project, so it would live under assets then.
Yes, it's in the plugins folder. Yeah. In the assets.
Yeah. Cool. Thank you.
Yeah, sounds good. Yeah, so there was actually a question regarding the like more maybe in depth about how do you manage different UI states which have different duration. So like what if they switch the state while the previous one is still running? So how is it done? So can you comment on that?
Yeah, that's a good question. We tried several implementation options, and in one of them we made applying states as a long process, and each next state in the tree was applied only after all animations on the previous state were completed. But it turned out to not so convenient, and almost nobody used it. In the end, we settled the implementation where the state is applied instantly, but the set state method will return the time. Time will be in seconds, and if there are no animations in the state, it will be 0. But if there are multiple animations in the state, we'll return the time of the longest animation. So we can, I don't know, use your coroutine to react for the state was applied.
Okay, got it. Thank you. Matt, do we have some more?
Yeah, we've got another question then asking about a container view. So can the container view do object pooling for the view prefabs?
It's a now desired tool for feature for our library, because right now it's not has any pooling, because it's just an instantiation of the prefab, and there are no methods to delete it, to remove it from the project hierarchy. But in our project we has integration with some other libraries which has object reusing, and it's a third-party library. We can't include it in this solution, but in future versions we will implement our own solution for these kind of tasks. Of course we will have pooling.
Yeah, as it's up on GitHub there, are you sort of fully open source and taking pull requests as well?
Yeah, it's fully open sourced, and I am welcome to contribute and give any feedback about it.
Fantastic. Yeah, sounds good. I think we're going to have to share the link to GitHub again. We'll add that into the chat.
Yeah.
on YouTube.
Absolutely, for sure. Yeah, thank you very much. That was really impressive, very insightful, and I guess useful for many of those who are like for a longer time in game development, who are just starting. Like everyone found that very insightful. So thank you very much. Yeah, and
Thank
yeah,
you.
have a good
Thank you
day.
very much.
Yeah, thank you,
See
Dmitrii.
you.
Yeah,
you.
so we're gonna bring another speaker here, and actually I'm very excited because that's the only speaker who has this kind of interesting photo in the bio on our announcement page. So that's the only speaker whose face you haven't seen yet, and maybe he or she is a robot. So we'll learn soon. So let's add our next speaker to the stage and learn. Actually, yeah, something about our next speaker. Hello. So it's not a robot.
Hi,
Hello.
I am indeed not a robot. Sorry for that.
No, that was fun. Yeah, that was fun. I really like that, and I indeed like the robot picture. It was remind me of Wally a little bit by how it looked, right? Oh yeah, that was a good reference. Yeah, so we have Ant here, and he's a senior Unity developer. And yeah, it does many interesting stuff, and it was involved in various like iOS and Android free-to-play games development. So we're gonna talk today about a very interesting topic, and because we have some people here in the chat who says that they're not a professional developer, I think they will be super excited because it's called like empowering non-developers. So that sounds intriguing. But before we start, we are asking people here actually which games are inspiring them for doing their games or any other kind of thing. So maybe you can also share.
What kind of games I like?
What kind of games inspire you? But like, yeah, I guess you like them as well if they inspire you, right?
I actually like, my philosophy is that like the quality is way more important than genre. Like I don't have like a favorite genre per se, as long as like the game is like really done well. For basically any Supercell game is like, wow, that's like they refine it to like 1,000%.
Yeah, that's a nice approach. That reminds me of like I have a friend who's doing a graphic, various types of graphics, and he usually looks at things from this perspective. Like when looking, for example, at the fireworks, he used to say like, "Oh, I'm thinking about how to draw that." So I think that's a good perspective looking in the world. With this, I think we can start. So if you're ready, you can share your screen, start the presentation. Yep. So we're good to go.
So welcome to my talk. It's about empowering non-developers, more specifically editor tools and workflow customizations in Unity. I hope you are like, I hope you have had a nice day. I saw some very nice presentations earlier. Really good stuff. And yeah, let's start. First, a bit more about me. That's my name. It's maybe hard to pronounce, so just answer is fine. I'm a lead or senior Unity developer. Basically, I do everything. I do anything. I have a couple of years of experience in working in games. And before that, I was also working as a designer and like 3D artist. So I do have quite a background on that side of things. And most recently, in the last company I worked at, and also while doing freelance work, I have been going more in depth into editor tooling and also the technical artist side, like more the optimization, etc. So but I also do like normal feature development, like maybe some match 3 or like some RTS style stuff as well. So yeah. And I like educating. I've been showing some presentations at universities or like a couple of talks as well, and like internal company workshop stuff as well, I guess. And it's really fun. And oh my god, my presentations! I'm so in love. Let's dive right in. Right, the first thing you may be asking is why. It's all about speed. It's all about efficiency. It's all about reducing friction, right? If you have people, like all of them are super duper pros, they need to be in the flow. They need to like just get in there, just put their ideas onto paper, or like, I guess, code, or like putting it into the engine. And all of those are like very expensive man hours and like etc. And also like reducing the workflow complexity, right? So it's all about capturing the intent of the designers and like the intent of the artists and the intent of the creatives, etc. So anytime there is just some like capturing the thought, and then they need to do like 20 steps, etc. And none of the steps are like specific to their thing, right? So for example, they need to create some like import some assets or something like that. They need to check 20 boxes or something, but actually what they want is to be just like, okay, this is a UI asset. Let's just click this button and maybe some specific settings, but like reduce the complexity. And yeah, the last point is that editor tools, they are a competitive advantage. So if you have a couple of people working in a team and they have like super tooled out stuff, they are like going super fast, obviously that's like way better. And also in terms of retention for your people in your company, etc., it's just way more fun if the tools are fun to work with. And if you go into like go to work and you're like, oh my god, like it's so good working with this tool, it's like, just, I don't know, it's cool. Yeah, that's my last point. It's fun. So yeah, let's think about what to do. So the most obvious thing you would want to do is reduce errors, right? So there's so many steps, like game development. There's every single thing. It has like so many settings. You go to some different window you've never seen before. There's so many settings. You go to the IDE. There's so many settings. Every asset, audio, video, like textures, models, etc. All of them have so many settings. All of the scenes have like super incredibly complex connections. You need to have like assets work together in interesting ways, levels be connected, etc., etc. And in each one of these steps, there can be errors introduced. And if you can have tools that just, if you click a button, it automatically sets up all of the things, reduces all of the complexities and like all of the menial tasks, that's like way better. Both for like, you will be doing your QA team like a big favor if everything is like serialized and works well. The next thing, everyday problems. There's like, if you just go to the teams and like just ask people, maybe just ask them to look over their shoulder for half a day or something like that, see what kind of tasks they do. Like sometimes people will be just importing or exporting stuff from Figma for hours on end, or like, oh, I need to change this small thing, export again, import again, etc., etc. It's like so much time. So the more you can just reduce the time it takes for these tiny everyday problems, each one of them may be a couple of seconds only, the better, basically. For game designers, right, I saw some guy go through each level and make screenshots of the mobile game app. And every time the levels changed, he would go through each one of the levels, like 50, 60 levels or something like that, make screenshots, and then take all of the screenshots, put them into Figma. Oh my God, it was so much work, right? So just ask them, hey, what do you need? How can I help you? What kind of things are you spending your time on? What are the things you actually enjoy doing and you're good at doing, right? So none of the things about like taking the screenshots are like something that only a game designer can do, right? Artists and creatives, right? There's in many companies, there's people working on marketing, etc., and maybe they need just some assets. And obviously, if they're the existing assets from the game inside of the game, that's way better, right? And for artists, import, export pipelines, etc. And also for developers, right? If you have maybe an internal tools kit or something like that, or like an internal pipeline on how everything can work together, it's way better for developers. They can save so much time. Setup can be so much easier, etc. Yeah. And the next thing is actually how to display information, right? Inside of Unity, there's so many different places where there will be data saved, just folders and folders of description of level data, etc. And sometimes it can be hard to go through each one and every one of them. So maybe creating a custom window that just like picks out all of the information you need, or just showing or compiling data and into one single place where you can, yeah, basically exactly that. And improving those interactions with data, right? Sometimes it can be quite hard to configure, and like automating data and all of the cascading effects it has can also be quite beneficial. So yeah, what's in it for you? Why should you care, right? Become the 10x developer, right? Everyone has heard it. Everyone's like, I need to become the 10x developer. In my personal opinion, that's not really a thing you can do. Like, you can't write code 10 times faster. But the thing you can do is make the lives for 10 developers maybe a bit easier, right? So that's the way you can think about tools development, just making the lives of entire teams or maybe even like entire departments way easier, and thereby saving hundreds of hours for basically in the entire future, right? Once it's done and the tool works, you can maybe support it every now and then. Maybe there's some bugs, but basically, like it's free man hours for the entire team. Make games faster, make games cooler, right? And with that comes also better career opportunities, right? You can go into the tools team, etc., make some cool stuff, and it's also like people underestimate this. Like you're way harder to fire. Like we've seen a couple of mass layoffs in recent history, and if you are essential to the productivity of other teams, and like you're maybe one of the 3 people who know all of the tools and can maintain them, etc. Like it's going to be way harder to be laid off, etc. Yeah, but you know, this is not a guarantee. Yeah. So in this presentation, like there's obviously 2 kind of approaches. Either you go breadth first, so show many different things, but on a low level, so to say, or you go depth first, right? So you show one specific super technical thing, and kind of the way I want to approach this is to show a bunch of different things first, kind of depth first, and then maybe in the end show some goodies, you know, some cool stuff. Yeah, we will go over all of the approaches. I will share some slides, get a sense for what's possible. I will show some of my own tools and some of the things you can actually do inside of Unity, and some fun examples, right? What can you use this for? Some actual workflow improvements or changes that have been implemented, and just some neat tips and tricks. Yes, let's get technical. So first question, how do you draw UI? So there's 2 different approaches. Unity kind of has been making a shift the last couple of years, and I think the shift is still happening, and I'm sure it's not going to like be finalized anytime soon. So yeah, the first is ImGUI or ImGUI, I don't know. Basically, it's the old way of drawing things. You just call a couple of static functions and construct the UI hierarchies inside of C#. Like everything is C#. You make one script per editor, and everything will happen inside of there. The nice thing about ImGUI is that you can hook into any callbacks that are already inside of the editor. Everything is still inside of C#. The entirety of Unity obviously is at your fingertips. You can easily work with the asset database, etc., and these kinds of things. And in my opinion, like this is a personal thing, it's way faster to just bash together. Like some developer or some game design person says, hey, can you make this like quick window here? And you're just like typing, half an hour, bam, it's ready. Maybe check the Google a couple of times, but basically that's it. And the nice thing about ImGUI is that all of the stuff you see on the left side here can be contained inside of a visual element, while a visual element cannot be contained inside of ImGUI. So this is something to consider. If you start using the visual elements, you cannot put them into ImGUI. For example, there is the Odin inspector, right? And if you have were to use visual elements, like do that kind of workflow, none of that would be displayed inside of ImGUI stuff. So I don't know, just keep that in mind. And on the side of the visual elements, this is more akin to a web workflow. So it uses UXML, which is Unity XML, you know, and USS, which is basically CSS for Unity. Some changes, right? Not exactly the same thing, but basically, like if you know the one, you will know the other. And it's using an MVC-based architecture. So all of the model view and what does C stand for? Controller, yeah, sorry. All of that stuff is basically separated, and all of the styling is also separated from the layout or the hierarchy, so to say. That's just something to keep in mind, and it will result in the amount of files being much greater than the ImGUI side of things. And in my personal opinion, oh no, yeah, it's better performance, right? Better performance is obviously better, but in my opinion, it's a bit more complicated. Not in the sense that it's not possible to do anything and it's like super crazy, but it is definitely something that makes sense if you have a bigger project and you need the architecture, etc. So if your project is already complicated, feel free to use visual elements there. It makes sense. But on other things, like if you just want a couple of small changes or something like that, using a big complex system like this may not make sense. Oh yeah, and the other thing is, oh yeah, it's just slightly more complicated, but nothing major. And I would say also the amount of code you would need to write to achieve the same thing is probably greater than using IMGUI. So yeah, let's just dive in, right? How to draw things. There's basically inside of IMGUI 4 ways to draw things. The first is the GUI and editor GUI class. You can just do this by, for example, there's some class or something, and you use GUI dot, and bam, there you have it. There's like labels, buttons, windows, toolbars, basically having groups vertical or something like that. And the other thing is editor GUI, and basically very similar interface as well. You have toggles, text fields, buttons, color pickers, etc. And basically this is GUI and editor GUI. If you don't find one thing in one of, just try looking for it in the other, right? The interesting thing for these two methods, or like these two classes, is that you need to create rects, like create rectangular shapes and draw UI into them. What this means is that you have pixel perfect accuracy for all of the tooling you do, right? So if you want to move something 1 pixel to the left, just modify the rect and like change the position or change the width, the height, or the Y minimum, Y maximum, etc. This is like sometimes really nice because you can have like super in-depth control over everything, but other times it also results in like way more complex, or maybe not complex, but way more bloated code, I would say. And it's maybe harder to see what actually you are doing because you're doing so much math and like, okay, because this button needs some space, I need to like move everything 15 pixels to the side, and then you add like minus 15 to like 5 different places, which sometimes, I don't know, it can be a bit hard to read. And if you make changes later on, it can also be a bit confusing. Exactly, it's a bit harder to read and understand. And one thing always to keep in mind is that if you make tools or something, and just make it easy for the next person looking at it. Like code is always way more read than it is written, right? So maybe if you're doing some math or like some calculations or some crazy stuff that's maybe in transparent, just add a comment. Okay, I'm moving this maybe a couple pixels down because this other thing needs a bit more space. Yeah, but generally it's great for properties. You know, for example, if you look at the vector, that's probably been written with this. Like you have multiple things in the same line, and you need to change it on a pixel by pixel basis. Really nice. And if you are doing multi-line properties, etc., that's also like super great. Yeah, the other approach is using GUI layout and editor GUI layout. Basically, just this layout suffix right here. This is the main difference. And you can use it in very much the same field. For example, in this class, it's already using editor GUI layout and then a text field, right? And if you were to look for the same thing, editor GUI dot text field, you would see that the first parameter here is a rect, like the rectangle it will draw into, and then only after that you will be able to like provide the label, the text, and maybe a GUI style, etc. And for these layout functions, you just provide the name and maybe the text content itself, or if you just do the toggle, you just provide what the current state is, etc. So it just automatically does all layout for you. And the other thing you can do is use scopes. This is this up here, horizontal scope, for example, or vertical scope. And you can also do your own scopes. Basically, what this does is under the hood, if you use the writer decompiler, oh yeah, this is just like jumping from place to place. Basically, this is using a disposable class, and by closing the bracket here, it basically calls some function inside of the dispose function. Basically, the same thing as if you were to say editor GUI layout dot begin horizontal here, and then do the same thing down here with end horizontal. But using these scopes is like super nice and very readable in my opinion. But I don't know, maybe some people are like, oh no, my code style is super different. And basically these scopes define like, okay, I want a horizontal group or a vertical group, basically the direction the layout is going. Yeah, that's the biggest advantage. And the auto layout functions, and all of the layout is happening from top to bottom. So if you write code here, the text field would be above the toggle field. So that's very easy. And if you are using a vertical, like a horizontal scope, the first thing would be on the left and the second thing would be on the right. If you want, you can like see what that looks like. For example, here, my custom class, this is the text field. I can write some stuff in here. And this is the button, right? So text field, button inside of a horizontal scope. Exactly. And there's also like space. You can tell the GUI layout to add like maybe 6 pixel space or something like that, to make like improve the layout a bit. And in my opinion, it's a lot easier to understand. You just have the basically you just write the intent of what you want to do, and all of the math basically gets figured out in the end. There are some things where you will need to rely on the non-layout versions of these functions, but basically most of the time you can just go with these. The next thing is editor styles I want to talk about. Oh yeah, look at him change his style, right? You can define the look of UI elements by applying a editor style. Usually it's the last overload inside of the method, just it's usually set to null or something like, or like the default style. And you can choose and modify these styles very easily by picking one of the default styles. For example, there's basically 2 places where you can find styles, GUI.skin, then maybe, 1 second. For example, GUI.skin, and then you have a couple of different styles here, for example, buttons, font settings, or like text fields, etc. And the next thing is like editor styles, if I could write editor styles. And for example, pop-ups or like search boxes, etc. And these oftentimes also have icons already inside of them. And you can modify these styles by basically making a copy of them and changing maybe the padding or something on the side. The last thing you sometimes need is just to say, okay, I want a GUI style of none, like nothing at all. Yeah, let's move on to icons. There's a bunch of places where you would need icons, for example, on buttons or something like that, or just on top of the window, for example. You can either load images with resources.load or something similar with the default Unity stuff. I personally wouldn't recommend this unless you really need it. But for all of the other stuff, I would recommend to use editor GUI utility.icon content. And then you can basically get a bunch of default icons. I provided this GitHub repository. It's really nice. It has most of the, or basically all of the icons Unity is already using. So for example, if you go to the editor, like all of these icons up here, here, inside of these window tabs, etc., all of them already exist inside of Unity. They don't require any space. You don't need to worry about them, and you can just implement them really easily. feel free to check it out. I think the slides will be provided later on. Don't worry about that at all. So yeah, how do we use it? We know how to draw stuff, but we don't know where to draw stuff and how to use any of it. So yeah, there's a couple of different places. The first one is custom inspectors. So for example, this is what a minimal custom inspector would look like, right? You just define this custom editor attribute and tell it which component you are trying to add this editor to. So for example, I have this my component class right here. It has a custom serialized class in it. It has a test boolean, a couple of floats, etc. And you basically just define it, and it needs to derive from editor. That's really important. The editor class is a scriptable object or something like that, or derives from scriptable object. And these automatically overwrite the default inspector. And all of the code, all of the custom code I just showed you, like editor GUI and GUI layout, write all of that into onInspector GUI. And in there you have basically this function draw default inspector. This will draw the default inspector, very creative naming. And basically this is what, 1 second, where's the drawer here? Custom inspector. Yeah, exactly. This is what that would look like just this code. And it's drawing the default inspector here. And down here you have this extra additional line, hey, custom editor, which is the same thing as here. If I change it, it will obviously be reflected inside of Unity. And obviously you don't just want to have a couple of text stuff. You also want to have a state or change some of the serialized values. But yeah, more on that later. Yeah, just overrides default inspector. It's for mono behaviors, scriptable objects, and also shaders. So if you are editing materials, etc., and you want to maybe not show a couple of variables or something like that, just write a custom editor for it. The important thing is that if you want to change values inside of the object, is to not use the public values or maybe even reuse reflection or something like that to edit all of these, but to instead work with serialized object and serialized properties. I decided this was maybe a bit out of the scope for this presentation, but generally speaking, instead of changing the value directly, maybe when you see that some changes have been detected, you would write the changes to these serialized objects or serialized properties, and then call a function, okay, this object has been dirtied, please record it into the undo redo history, and then all of that works as well. I have seen quite a lot of tools that use custom editors where undo and redo doesn't work properly because they are like directly modifying the properties. So every time you change something, just tell the undo redo system, hey, this object has been dirtied, please record it into this step. And the other thing is to keep multi-object editing in mind. So if I have this custom inspector here, it's totally, it should work if I do this, right? If I just select one thing, or if I do multiple things. You can see that here, down here, the last thing, it disappeared, right? So that's because I'm not really 100% set up for using multi-object editing. So there's a couple of things. I think in the documentation, there is one page where it just says, hey, keep these things in mind. It's kind of out of the scope for this presentation though, but yeah, just keep it in mind and try to look it up. The next thing is property drawers. This is for custom classes you have that you want to serialize. If I go into here, I have this my custom class. It just has a string and it has a Boolean. I want to draw it so that the string and the Boolean are directly next to each other, right? So usually it would have like a drop down and it would show them above each other. And I'm like, okay, my inspector is way too vertical. I want to move it to the side. It's just this like small checkbox. I can do that, no problem. So what you need to do, obviously, it needs to be serializable, and then you go to this class. You provide this custom property drawer attribute, and tell it which class to draw for. And it needs to derive from property drawer. It's not a drawer in the sense of like a cupboard or something, or like a table or some, or like a, I don't know, what are they called? It's supposed to draw, right? So that's why it's called drawer. And it has the function onGUI. And as you can see in here, the onGUI function, it gives you a rect position. So anything you do inside of here, it makes sense to use this rect position inside of maybe editor GUI stuff if you want to really go in depth and be like pixel perfect. For example, the custom inspector, it doesn't have the rect, it doesn't pass it into there, but this one does. So it's like super nice working here. But obviously all of the GUI layout stuff also works. So that's the class I just showed you. Horizontal scope, text field, toggle. And if you were to define a label here, it would actually it would actually look a bit more like this, right? This is not something we want, so I automatically like use this overload. But basically, yeah, it's in one line. It's showing the name of the god property and all of this stuff. The thing you need to keep in mind, right? I'm clicking on this checkbox, right, and I'm writing text in here. As soon as I press enter, all of it disappears. That's because I'm not working with the serial objects and at any. And all of the, for example, the text field, it's returning a value. So if I introduce a value variable here, for example, text field, I can it wants the rect. It should just show all of the stuff I'm typing into here down there. Or maybe it doesn't, I don't know. Let's move on. So yeah, they overwrite the field that's drawing the inspector, and this happens for any instance in the entire project. So one property drawer will replace the way the property is drawn in the entire project. If you want to do like in different cases, use different drawing styles, you would need to switch inside of the property drawer. And this is for all serialized fields. These sadly don't work for non-serialized fields as far as I know. Yeah. The next thing, this is the exciting stuff. This is the special sauce. This is the cool stuff. Here, the real magic happens, right? You will have a class that derives from editor window, and this is also a scriptable object and can be instantiated, etc. And first of all, you would need to have a method where you can call it from. So just using menu item and something like that, and calling the get window function with this as the generic parameter and the title you want in there will automatically give you this up here, like click on it, and it will show you the window with the window title you provided and content of the window, hey, custom window, right? And this is exactly what's happening down here. GUI layout dot label it with the text. It's pretty straightforward. Just use the exact same thing I have been talking about, the horizontal layout, vertical layout, stuff like that, and all of the layout functions. Or you can even go pixel perfect with it if you want, or as I mentioned before, with the visual elements, define a XML thing and all of that stuff. Yeah, these are just normal Unity drag and droppable windows. Feel free to change it. It's really like is property attribute. Oh, I'm sorry. I think someone's. I will be right back in 2 minutes. Sorry about that.
Yeah, that happens. So sometimes someone is interacting with you and like want to chat. So while we're waiting for Anne, I just wanted to we had a poll recently in this chat on YouTube, and we asked you what UI toolkit are you using in Unity, and it was actually fun to learn that 63% are using UI Elements toolkit, and 46% are on IMG UI, based on this poll we did in this YouTube chat. I'm just like sharing the numbers because we just recently had a poll which UI toolkit are you using in Unity specifically. So I think it fits the topic nicely. Yeah, so good to have you back, and yeah, you can proceed. Just unmute yourself and yeah, unmute yourself, please.
The next thing is property attributes. This is something really exciting, and I don't know if people even realize this is something you can do. Basically, if you are using normal attributes inside of Unity to maybe add some extra information to your classes or your components, you can derive. Wait a second, let me find my component here. For example, this is the I created this custom attribute here, which is deriving from property attribute, and it should go onto the attribute target of type field, and it has just one parameter called limit. So if I add this attribute right here with the limit of 10 on a field, like a float field, for example, it will automatically try to use a property drawer for attributes, right? Because it's using these property attributes. And then you just draw create a property drawer and define what attribute it will be linked to. And all of the code that happens in there, let me just get the custom attribute drawer here. For example, this is a nice quick implementation I did for this custom attribute. It basically gets the attribute, casts it towards the class, gets the value and compares it to the limit. And if it's above the limit, it will draw everything in red. So what this effectively does is like this coolness, and if the coolness turn everything red, right? So just a couple of fun stuff like that, or you can even disable the rendering, or like add extra additional lines here, etc., or change the height, or add additional extra information. All of that should work just fine. And there's one plugin I want to highlight, which is called it's called Naughty Attributes. I don't think I actually have it installed right here, but it basically gives you a bunch of these attributes. And another add-on would be called Odin Inspector, and it basically does the same thing. You can have lots of automatic editor tooling, or like very simplified nice editors with just a couple of attributes. If you want to have a slider, or if you want to have automatic stuff like that, it should work all just fine. Yeah, so very, very nice, very cool. That's it, right? So is that everything? No, you can have more. There's inside of Unity, there's a couple of places where you can hook into existing editor and events. They have callbacks where you can just add your own functionality into. So the thing I want to highlight here is the project window and hierarchy. For example, you may have already seen it down here. These are like not stuff. This is something that's totally custom and something I made myself. For example, if you want to show the GUID here, it will show you the GUID, and if you click on it, it will automatically copy it to the clipboard or something like that. And all of the same stuff applies. You can just hook into this event. It's called editor application.project window or something like that. And the same thing should work for the hierarchy. So I have this event hook right here. And if you do the project window item on GUI or the hierarchy, like for example, here I'm just displaying a couple of GUI boxes with a red color. So if I uncomment that line, it should, inside of the hierarchy window, yeah, you see it's a bit red. And you can like add text or information in here. Very straightforward and very simple to hook into. And there's a couple of other places, for example, this bar up here. These are also custom buttons. It has a place where you can hook into to just add a couple of extra buttons. For example, here I added this screenshot button. And this is also a custom window where you can have, like, for example, just do all of the screenshots for Android or for iOS. Let's say we want to take iOS screenshots. We click on play and click on take screenshots. It will automatically go through all of the resolutions, make screenshots, and save them to like a screenshots folder right here. And there you have it, all of the screenshots, etc. This is super useful if you want to do like store listings, etc. And I also have like buttons for build settings, for the preferences window and the project settings window, and also something for resetting user data, which is like super useful if you just want to quickly go in there and start a new session without, I don't know, there's maybe a window up here, or I don't know. Basically, it's like way more accessible, and especially for game designers, they don't want to always go up here into some settings. And the other thing I added is you can make it conditional. So for example, now in play mode, we have these additional 2 buttons. If you click on this one, it automatically pauses the game and opens up the profiler. You can go in here, see all of the profiling stuff, or if you can do the frame debugger and just go into here and check everything out, what the camera is doing right now. Yeah, feel free to like check out inside of Unity. There's a couple of endpoints you can just hook into. The sad thing is that many of these are not documented. So it makes sense to just explore around and see what works. Yeah. And the last thing I wanted to really encourage anyone to just explore is hacking Unity, right? So these endpoints here, these editor callbacks, these are public, like anyone can access them and hook into it. But this stuff which I'm talking about now is a bit more, I guess, unorthodox, and I'm not even sure if it complies with the terms of service or something like that. You can use Rider to like click here and go to assemblies, and then you have the Unity core module. And the core modules have all of the compiled stuff inside of them. So for example, Unity editor dot package manager. Sorry about that.
Yeah, so we can still speak right here. So maybe like, yeah, while we're waiting for Ant, so he is showing this amazing things in Rider. I just wanted to add regarding Rider that actually in the current release, we did many things in Rider, reducing the red code in the USS and UXML files. And the upcoming 0.3 release, we're actually gonna finally connect the C# code and the UXML code for some cross features, so providing some usages, completion, and navigation in Rider. So I think that will be also quite useful if you do this kind of UI elements development with Rider. So yeah, you can try that. And don't forget to unmute you before you proceed.
Sorry, I think I will actually need to leave because the hotel I'm staying at, there was an error or something like that. I'm terribly sorry, this is really unprofessional. But basically the end result I was trying to hint at is that you can add custom buttons or something inside of the any place inside of the editor by using reflection and accessing visual elements inside of the core Unity stuff. And all of this stuff, like all of this exploratory stuff, is inside. You can access using Unity's or Rider's decompiling features. This is really amazing and makes it super easy. And you can basically add UI elements to any place in the editor. I'm terribly sorry. I think I will need to leave the conference. this is really unprofessional. And I have a couple of other slides. If you are interested, I think the slides will be provided. Yeah. Sorry about that.
Thank you very much. So
yeah, thank you very much, and don't worry.
Yeah, no worries. Things happen. Life is different, so that's fine. That was amazing presentation. I think people got lots of insights, and yeah, we'll share your slides. So I think the people will just.
Thanks for having me.
Yeah, thank you very much. And yeah, so since we have some like extra spot, so Matt, what do you think? Like, because we already started talking about Rider. And I was like, yeah, promising people some nice features for visual elements for the hopefully for the 0.3 release. But maybe you can do some brief demo to us here, like showcasing Rider for some whatever you prefer, Unity, Unreal Engine.
Yeah, let's do some. Let's have a look at some Unity stuff. How about some debugging tips and tricks?
I love that. Just don't forget to share your screen to us.
I'm doing it. I'm clicking.
Yeah, I love debugging, right? It's so insightful usually. Yeah, and we can get more into that and learn some fun stuff. Oh, yeah, Tower Defense. I know that project.
Tower Defense, yeah, it's my favorite demo project, really. It's a nice one. Let's just click that into run mode. Yeah, so I got a demo project here, which I use a lot just to show sort of things working and whatnot, and how Rider can work with things. And yeah, why don't we have a look at some debugging kind of tips and tricks? Really, there's a bunch of things that Rider can do to help you with debugging, and a number of these things are going to be kind of Unity specific, I guess, but they'll apply equally to some Unreal type stuff there as well. So the features we've got across the debuggers, although they're different debuggers, they're not 100% the same. There's a lot of similarity, and I'll point out some of the differences as we go. First thing, I know it's not really debugging, but we can see we've got the debug log format. A lot of people like to use the kind of the console write style of debugging, and this one's good. So I've got one here, spawn agent. If I didn't mean to come out of play mode. If I start my game here, and if Unity wants to reload the domain, there we go. And if I just kick off a wave here, go on, you can do it. Okay, it's going to look awful. I'm not quite sure why that is. Good old Unity. But we've got there, it's the graphics of the game is not important right now. The important thing I wanted to show here is the log. We're seeing the log messages coming out down the bottom here. It's a useful way of being able to show information that's coming out. We can use the debug log format. You can use simple sort of markup there to say put things in italics and things like that, and we can see that here with spawning agent and bold there and taking damage. And I know that the font there is a little bit small. I can zoom in just a little bit here just to sort of show that. There we go, it's a bit better. You can see that there. It'd be nice if we could zoom in the UI of Unity itself. And then we can kind of click the links here to sort of open that up in Rider. But Rider, we can do one step better. We can actually use the Unity toolbar here. And when we are using Rider and Unity, we actually sort of talk to Unity itself, and we pull the information from Unity as it's running there. So we can see here we've got items there like taking damage, spawning agent, and again with the italics and the bold and stuff like that. And if I just move that over a little bit, in fact, let's just make that a little bit bigger, we can see we've got our call stack again, and it's just very easy to navigate around because we're bringing the logs where your code is. So it makes sense there. We can just actually kind of click around. We can click on the method names, spawn agent, and it'll take us right to the right place. Same with log format. It'll even decompile it for us and take us to the right place, which is useful. And a couple of useful tips with this one as well is that we can actually collapse items too. So if we've got similar items like the taking damage and the spawning agent there, you can see if I move out of the way of the scroll bar, that's being hit 14 times. And is the taking damage one is being used 10 times as well. So we can do that. We can filter based on errors and information and so on. If I just undo that, I can do things like filter down by hover buggy. So if I've got a particular enemy with a message that I want to be able to use, I can then filter those down as well, which is quite useful. But the downside of using that is that you've got to, edit your code, add in a debug log format, go back, recompile, restart the game, and keep going. There's much better ways of doing debugging than that, and there's kind of some of the things I want to show you. So one of the things that Rider does, it kind of automatically configures the debugger for you. So we've got this nice little drop down in the top here, which allows us to sort of automatically attach to the Unity editor, and you just have to click the debug button next to it, and we can then start debugging, which is a great way of working. We don't have to do anything too complicated there. Just click the button and go. And if I just come back to my main menu, and I got a breakpoint there, I can hit. I should have a breakpoint there. There it is. Yep. So we've got show title screen. There we go. So we just got a breakpoint clicked in the gutter there, so I can add a breakpoint very, very easily. If I wanted to, I can sort of remove it. And I can then just click to add a new breakpoint, and we're good. When it hits there, we've got a little arrow to tell us where we are with that, and we kind of show information about what's going on in this area here as well. So I can click on these things directly in the editor there and see what's going on. Now, Rider does a couple of nice things for when you're debugging a Unity game. We add a bunch of useful information. So if I just slide this up a little bit. Why can't I grab that? Come on. Yep, slide that up a bit. On the right-hand side here, you can see the useful information about where we are. So we've got this this object here, and so we can see what's in scope right now, and that's useful. But we also add a couple of extra items here, things like the active scene and the game object as well. So the active scene immediately tells us what scene we're looking at, so that's nice to know. So if I'm in the main menu or in my level 1, 2, 3 or whatever, and I can open those and can look at the data there. So some of that might not be useful to me right now, but what might be useful is this game objects. And again, this is something that Rider adds for you, and it kind of gives you a hierarchy then of all the game objects that are attached to this scene. And it's very much like the hierarchy view that you can see in Unity itself. So we can go into like the canvas, and we can see all the game objects that are there, and we can see what components are attached to the game object, and also what children are attached there as well. So we can navigate the sort of the full hierarchy of game objects, and having a look at menu buttons and everything that we want. Or we can go into the components as well. We can see the transforms, we can see the canvas, we can see which scripts are added to that as well. And if I open up the script, then I can see all the information, and that is part of that script. So it's really useful. The debugger is trying to give you that information without you having to dive in and go and find it. So I can get all my components, my game objects, and the whole hierarchy of things. We also show you the this.game object as well. So what's the current game object that your breakpoint is in? And so we can see that this breakpoint, which was for the main menu, is attached for the script for the main menu, is attached to the canvas. And again, I can see what components I've got in my canvas here, and then I can look through those. I can also see what children are available in there too as well. We also do some nice things about showing some of the information. A lot of things which you're not necessarily going to notice. We give you a better view of what's going on in your of how we display some of the objects there. So for example, if we look at a mesh, we can actually then just sort of see how many points there are in there, and so how many vertices there are in there. If we're looking at points themselves, Unity in a debugger tends to show them with 2 decimal places, precision, which when you're looking at something like, well, why is 0.02 not the same as 0.02? That's because Unity is truncating it in the debugger, or telling the debugger to truncate it. We override that and provide a much better amount of precision, so you can actually see that these values are different there, so it's a little less confusing. So that's enough about looking at that. A couple of other things we can do in the debugger is the usual kind of stuff. We can look up and down the call stack, and we can see what has caused this method to be called. And you can see these are all highlighted in a different color. That's because it's third-party code. It's from the from Unity engine itself. And with Rider, you can just double-click that. Again, let me just reduce the size there a little bit. And we can see now that we've actually decompiled that, and we're now inside Unity code here as well. So we're looking at Unity engine events, and we've got the invoke method, and I can navigate down. We can actually go down to button press. And so I could put a breakpoint in here. And if we just sort of restart that here, we've got the resume button here and carry on, then Unity crashes, which is not really what you want when you're trying to demo something. Let's just fire up the Unity Hub again and start tower defense. And where did Rider go? Okay, so then we have to wait for Unity to reload there. But setting a breakpoint is very easy. Well, wait there, you just have to click in the sides there. So if I just go back to my tower defense main menu, I can just put a breakpoint there. I can then right-click on it as well, and I get more interesting options here too. So really useful things you can do is you can just sort of disable a breakpoint. So if you've got a bunch of things set up because you're debugging, you can then sort of click the enable button to disable it. So you don't have to remove it all the time, and you can use that then to work with it. Another little tip here is this bookmarks tool window, which we've got in the side here. It shows you all the sort of bookmarks that you've got available. You can bookmark code so you can easily jump around and navigate to something, but it also shows you the breakpoints you've got. So it's a nice way then of sort of remembering where those things were in the control flow of your program to be able to navigate around and continue debugging these kinds of things. So, right. One thing I wanted to show before things crashed is, again, if I'm going to attach to the Unity editor, now that it's started again, and I wanted to have a look. Again, it's one of the ways that Rider shows the data to you differently than you would normally get to see. Is it follows on nicely as well from what Ans was talking about with editors. I've got an editor window here, which is working with our ballistic projectile, which is a gun, a bullet kind of thing, gun that we've got going on. I want to put a breakpoint in for editing this. And if I just go and see what it is that we're editing, one thing I can do, which is really nice, is click on this asset usages and find out where this component is being used, so that I can then go off and inspect that object to see what editor we've got. So one thing we do when Rider does is it indexes all of your assets. And so we can then show you where this bit of code is being used in your assets. And we see that it's being used in these prefabs. Let's go with rocket projectile 0. And then if I swap back to Unity, then, oh, that's just done too many things all at once. Let me just get rid of that and jump back to that. If I go back over here, rocket projectile 0, I've shown my results that we've got here. I can select that, and it now selects it in the project view for me. So let's just hide that project view. I've got rocket projectile 0, and over in the inspector on the right-hand side here, I've got a script, ballistic projectile script here. Let me just zoom in on that. So I've got things like arc preference and fire mode and so on. What the editor's doing isn't necessarily important here. What I want to do instead, though, is put my breakpoint back into my uninspector GUI. Hello, breakpoint. Breakpoint there, and if we go back, there we go. We can see now that Unity has called our uninspected GUI callback, and now we're going to be working with a serialized object. This is the object that we're going to show inside our editor, inside our custom editor. And normally these are a tricky kind of data structure to work with because it's showing us a lot of information there. You've got to have a serialized object which has serialized properties. And again, Rider pulls all this information out for us. So we can say this is our serialized object that we're working with. The serialized property we've got is this property type of a monobehavior. And we can see the value there we've got there. There's lots of information going on there. But the really important thing is this children item here. So we can see that we've got a mono behavior, and then the serialized properties of this mono behavior are being pulled out for us. So if you're working with an editor and you want to be able to debug it and find out what's going on, this is a great way of getting to all that information in the debugger. Writers bring it forward to you so you can really work with it. You can see I've got my arc preference, which was the item there, the fire mode and the firing angles. I can see what those values are. And so I know now it's like, oh, okay, this is the data I need to go and get to be able to show it in my editor. So let's just get rid of that breakpoint and carry on. And if we go back to our wave, where we had the spawn agents. In here, what we were doing before is we have this debug log format. And again, I was saying, if you wanted to be able to do that, it's great to be able to use it, and you can get output to the console, and it's great, but it's not necessarily a good way of debugging because you have to change your code, recompile, respawn, restart the app domain every time. So there's a different thing you can do here. You can right-click on your breakpoint, and if you uncheck this suspend execution item, you get a different set of options. So normally when you hit a breakpoint, Rider will suspend execution. It stops the sort of .NET side of things, the Unity side of things, and it allows you to use the debugger to examine the state of the program, but the program is not running. But what we want to do instead is actually say, well, no, keep the program running, but every time you do have something, you can do evaluate and log. We can do a couple of things. We can log a simple message, which is breakpoint hit, and it'll tell you where it is. We can dump the stack trace at that time, or we can evaluate a message here as well. Let me just remember what this one was saying. In fact, I could probably just copy that one almost exactly. If I go back here and if I do something like string dot, in fact, I don't even need to do that. I can do a string value and then add the agent instance dot name there. And if I say done, we're now going to have a simple logging expression going on there. We're not going to suspend. We're going to have a simple logging expression. And if we now go back to our game and start playing again, we have to reload the app domain because that's what we always have to do. We can ignore that breakpoint now. I'm showing the title screen. And we select our level. We've got another breakpoint. Skip that one. If we start playing, and we've got our very glitchy graphics for some reason. All right, that should be running. If we have a look at the console, we can see these things are spawning messages here. But what we should also do now is if we go over to our debug output, we should now have the messages as well. So this is the message that's coming from our breakpoint here. So go back to my wave. And that's the output here. So it's like, well, I don't need to have all of that information here, so I can just delete that now. And if I do done, and I need to restart my game level because it's done. If I go back over here, you can see now I'm getting a different output coming out, but I haven't had to recompile. I've only had to restart the wave because it finished. So that's a much better way of being able to sort of dump outputs while the game is still running and see the state and examine what's going on without having to stop and hit a breakpoint every time or recompile and add in a new debug log format. Let me just quickly check something over here. Yeah, this is cool. And right, so next thing, what's the next thing I'm going to show you? Yeah, so there's more interesting breakpoints we can do as well. Let me just get rid of that one, and we'll add in, let's add a new one in here. Doesn't want to do, add a breakpoint there. So if we right click on this, there are much more options we can have here as well. So condition is a good one here. So if we have a condition here, do I have a loop there? That's just the thing I want to show. So we can add in a condition. In fact, I can just type that, and if we start typing, we should get co-completion. Maybe not. Okay, current index equals 2. What we can do is say that, well, okay, I want to break here, but I don't want to break for the first one. I want to break for the next couple here. So let's just clear my log file there, and let's restart this. and start the wave again. And we should see that we're going to have a couple of objects launching. Hopefully, we can't actually see it in the graphics. But now we've had a breakpoint here where it's saying that m current index equals 2. So we've actually spawned a couple of enemies, but now we're breaking when we're on the second or third item there. So we start at 0, we didn't hit then, we incremented it to 1, we didn't carry on there, and we get to index 2, and now we've hit the breakpoint. So conditional breakpoints are a great way of being able to allow your game to run for a little bit and then hit a breakpoint under a specific condition. It might be a different kind of condition there. So for example, here we've got if poolable equals null. It's like, yes, I can put in a breakpoint in the return statement here, but I could add a breakpoint there and add a condition here, which just says poolable equals null. So again, a very good way of being able to test what's going on there. So if you're trying to figure out a bug, it's like, well, you know, I've got a value here which is 100, but it gets called 20 times before it reaches 100. How can I find when this bug happens? You can add a conditional breakpoint, set it to be the value is equal to 100, and then it's going to stop for you and break at that time, which is again a really, really useful way. It's a very, very powerful way of debugging your code. But you can even take that a little bit further as well. So let's just in fact, let's just remove that breakpoint. And if we go to this one, and if we click on the more item here, then you can see now we've actually got a much larger set of options that we can have. We've got our condition again, we can suspend execution again. We've got our logging going on here. And in fact, we can do a hit count here. So I could get rid of this condition here and say, well, actually, I want a hit count here. So I can say, well, the different items that I got there. So only break when this breakpoint has been hit 10 times or 5 times. So then I can say, well, okay, I know it's spawning my enemies, so I'm going to do my hit count when I've had 5 enemies spawned, which again is a really powerful way to work with debugging. You can do more complex kind of conditions that are going on there. You've got lots of options there: less than equal to, greater than, even multiple of. So if you know that it's going to be a method is called 3 times per enemy, then you can just do it, well, okay, multiple of 3, and it'll work with you there. Another useful option is to remove once hit, because if you're in a loop and you want to hit a breakpoint and you want to stop, well, then remove it once it's done. So then as you carry on, it's not going to cause problems again. So you can create a temporary breakpoint, which is really useful. And then finally, really, really helpful one is a conditional breakpoint. Now, this is great when you've got a common routine which is called lots of times. So let's say, for example, you know, taking damage, and there's something wrong that when the 5th enemy comes in, taking damage goes wrong. You can put a breakpoint in your taking damage routine, and then have that conditional on, say, another breakpoint, which says this is going to happen on the 5th enemy. So you know that after a certain number of enemies, you hit a breakpoint, and then you start to enable your other breakpoint again. And you've got the options then to sort of leave it enabled or work around it there. So you can do some very sort of complex conditions to work with things there. Now, then the next thing I wanted to show kind of depends on the graphics, which is a bit broken. So let me just see if one of the other levels works better. That one, let's go back to the main menu. Let's try, yes, thank you. Breakpoints, always useful. Let's try level 2. A little bit better. Let's try this. Okay, good. We can see our enemies, so that's a good thing. So let me just put in another breakpoint back when we're spawning our agents. Let's put the breakpoint in there. That should get hit. There we are. It's hit. It's like, great. We found there's a bug. I can see what's going wrong here. I want to have a look at the state of everything. But if I come back to Unity, everything's frozen, which is perfectly normal because that's what the debugger does. It stops the execution of the program. But then that's no good. It's like I want to be able to look at my hierarchy and be able to do things. Rider's got a great solution for that as well. What we can do here is we can right-click on our breakpoint, and down at the bottom here, we've got this idea for convert to Unity pause point. Now, this is a Unity-specific kind of thing. Everything I've shown you so far should work with Unreal, but this one is a Unity-specific thing. We can convert something into a Unity pause point. And now it's kind of the same sort of thing. We've got a different icon going on here. You can see it looks like a pause button. And then if I bring that back up again, we've got the options. We can still have conditions. So we can still say on my third enemy, do this. Or we can still have dependent breakpoints. So you can say, well, after we've started taking damage, then I can do that. But instead, we're actually going to use our pause point idea. So if I just resume this, we should now get another enemy come through. And what's actually first happened is we've actually gone into pause mode. So we can see Unity has gone into pause mode automatically. The breakpoint hit and Rider automatically put Unity into pause mode. But the good thing with that is I can now look at all the different items that we've got going on here, which if I had the graphics would be even better, because what you can do is you can obviously examine what's going on. You can grab your enemies. You can even sort of move things around and make alterations, and then you can just take it out of pause mode, and those things still apply. And again, of course, now the breakpoint is hit, and we hit the break. Rider puts it into pause mode, and we're good to go. And that's a really sort of powerful way of working with the Unity editor, as well as using with Rider's debugger there. So you kind of get the best of both worlds. You can look at what's going on in the code level, or you can look at what's going on inside the Unity editor as well. Right, so let's just get rid of that breakpoint, and that's all good. So we can unpause that. And what I want to do is I'm going to start an app running, and 1 moment. I have to plug in an Android device over USB. I also need to turn the sound down because I can't hear anything else. That's better. Now, so Rider can also allow you to debug devices as well. So if I go into Rider, I can use this Unity button here, and we've got an item here which is attached to the Unity process. Now, when this starts up, it's look to see what processes are available. We can see now we've got the Unity editor itself, and we already can see that the debugger is attached to that. And if I, on my trusty Android device, my trusty really slow Android device, go on. Nope, that one's not going to work. Okay. Ah, yes, it is. There it is. If I fire up an Android device, a game on Android, and in fact, if I can get my phone as well, I can attach my iPhone by USB. And if I start this, we should be able to debug on here as well. So we can see we've got my desktop player here, and I can simply attach to that. If I double click that, click OK, we'll start debugging. And let's go back into my menu here, level select menu. If I add a breakpoint there and come back to my item here, if I go to level select, then we should see any second the debugger should catch that. Then again, maybe not. Let's go back to the main menu, level select. There we go, that's better. And we can see now that the debugger can work just as well with the desktop applications there. Again, we can sort of see some useful information here. We can see we've got a current scene. We've got my child objects in my game objects. I can still walk up and down the core stack, and I can navigate and edit and look at data there as well. And then if we go into attach the Unity process again, we should see No, Android device doesn't want to fire up. Okay, but we can then debug over USB as well. So I can connect my iPhone device, and let's just stop my Android player. And if we just wait for the debugger to initialize down the bottom. Oh, no, it doesn't want to connect. Let's try one more time. Is this going to connect? Wait for it to initialize. And it's not going to connect to my iPhone. Okay. Right, well then the last thing to show then really, since that doesn't want to fire up, let's just see if my Android device will actually start up, is that when you do connect to a different item here, we add a different run configuration for this. So you can see we've kind of got our attached to Unity editor as something which we've done before. We can easily sort of select between that. I can select them between my MacBook player as well. So it's easy to just decide which item you want to attach to and then click debug, and we'll automatically reattach to that. And let's see, we should have Android working now. There we go. We've got our Android player there, so we can actually connect to it via Wi-Fi as well, or we can connect to it via USB. So let's just try and do it through USB. Again, we've kind of selected this up at the top for you automatically. And we've got a breakpoint added. We initialized. And on my trusty, very old Android tablet, I should be able to click level select, and we don't have a breakpoint. Why is that not breaking? Breakpoints, there it is, and level select, and there we go. We can break at our breakpoint there as well. And again, it's a bit slow because my Android tablet is very old and rubbish, but the data is still there, the information is still there. We've got our active scene, and we can see that. We can see the attached game objects, and this is all then working sort of over USB and on Android. And I think that's really kind of everything I wanted to show. There's some really useful things you can do with debugging. You know, breakpoints are really powerful. You can have conditional breakpoints, dependent breakpoints. Pause points are an absolutely fantastic way of being able to work with the editor as well as with Rider's debugger. And we can, through the attached Unity process dialog, talk to other devices, desktop applications, and mobile devices, console devices, and so on. So I think that's it. I think that's probably bringing us up to time for our next speaker. Actually,
yeah, thank you, Matt. That was
unless
very brave. Yeah, that was very brave, actually, demoing the debugger live with all this iPhone setup. Yeah,
it's
so here's a plus.
It really worked.
You know, this demo effect when everything just breaks every time you try the setup, which was working to you like a minute ago. I guess I experienced that many times.
Well, I got like 4 or 5 different instances of the game running right now and streaming, and yes, it just doesn't quite want to talk to my iPhone.
Right. Yeah. But I think it's time to move to our next speaker. We have Oles here already, so let's welcome him to the stream. Hello.
Hi, guys.
How are you doing?
I'm doing fine, thank you.
Yeah, great. So I've read into your bio that you create educational products for kids, which looks very interesting to me because I have 2 kids at home, always like running around, rushing and asking for playtime games. So I have actually one small question to you. So talking about creating educational products for kids, and like how much a difference from, you know, creating entertainment content or just regular games in your experience, like what do you think about that?
I think the main difference is that when you're creating something for kids, you work with 2 auditories of users. you work with kids, you create for them like mini games with really simple mechanics, but you need to add there something useful to them, so then they can teach something. Or learn something. And other auditory is like their parents, because they are paying for product, and you also need to engage with them. So it's a little bit tricky.
Yeah, right. So you first have to kind of inspire the kid and then also go for parents. Yeah, I know that feeling. You know, my kid is always coming to me and saying like, "Oh, mom, I have this list of games I would like to play next. Could you approve some of them?" I'm looking at them like, "Oh no, I'm never gonna approve these games to you. Let's move forward. Next list, please." So yeah, I do understand what you're talking about here.
Yeah.
Yeah. Okay, so I think Oles will share with us a very exciting and useful topic about the Unity assets that every project should use. I think we should all learn that. So please go ahead if you're ready. Stage is yours.
Okay, hello everyone. Today we will talk about Unity assets that every project should have. Maybe not every, but I think that these assets will make your life easier. And first thing first, we will talk about the agenda of my presentation. I will tell you something about me. Then we will talk about worth mentions, because 10 assets, it's not enough to include all great assets that can make your development cycles more efficient. Then I will tell you about 3 not universal but very great assets that can be used in your game if there are some conditions mentioned. And then we will talk about incredible, or how I like to call them, the magnificent 7 of assets that I think every project can use and can benefit from using it. Okay, what about me? I'm working in Unity like 4+ years as Unity developer in different companies in Ukraine. I work nowadays. I work on Keiki. It's part of Genesis ecosystem, and we create products for children. Before that, I was working in a company that was creating clone of Minecraft. So I work both in 2D and 3D and have some information to share without you. And for last 5 years, I work as lecturer in top universities of Ukraine and develop my course on Unity development. So, worth mentions. What assets can we add to our projects that are not very that not every project should use, but can be very handy. At the first place, we have addressables. I think it's the best approach to handle your project resources in Unity. By using addressables in our projects, we were able to reduce size of downloaded content by 400 megabytes from the get-go, because addressables allow for very efficient management of duplicates in your project. Additionally, by using addressables, we were able to easily switch out our prefabs for screens or game objects without having to release new versions of application. We simply download a new version of a prefab from our remote project remote file system. We use Amazon S3 for it, and end user will get a new experiences without releasing game. And second place goes to Cinemachine, one of the best free camera controllers that you can find on internet. My students, even without much experience, were able to create cinematic sequences in a matter of hours using nothing but Cinemachine. And nowadays, when I create some controller for 3D or 2D game, I don't write my own camera controllers because it can be very handy and it can take a lot of time, and I simply use Cinemachine. Third place is Astar Pathfinding, is great analog of NumMesh with extended functionality. And most importantly, it supports 2D. Because if you try to create NumMesh for 2D, you know how trouble it is. At the first place, I think by the name of this asset, you could tell what it do. It handles all saving that you can do in your project. It lets you save almost anything with ease across different platforms, along with features such as encryption, compression, cloud storage, spreadsheets, backups, and much more. And it's maybe it's a little bit pricey. It's $69, but I think it's worth it. At the fifth place, we have assets that make your game feel better, and name subscribe it. Assets consist of 130, as creator calls them, feedbacks that let you easily trigger screen shakes, particles, physics, text, shaders, and many more to add some juice to your game and feel it more amusing to your customers. And sixth place, we have UI particle image. If you at least once tried to add particles to your UI, you know how frustrating it is. With this asset, you can forget about horror of using particles for UI, and you can use a lot of great features such as attractors, maskings, trials, and it's really simple to use with great documentation. At seventh place is asset for those who work in 3D, and it applies physics to characters' bonds or joints with a simple setup. Eighth place, it's a simple asset that name does everything that it is name. It's a simple third-person controller, the best controller that I saw on internet, so you can use it for get-go. Ninth place, it's little asset that allows you to infinitely fracture, demolish, slice your 3D objects both at runtime and in editor. And at 10th place, it's not polished enough, but very interesting assets that will allow you to change your scripts without recompiling. So you can change some part of your script in editor, and it will work in play mode and edit mode, and even on device, if you have like some remote connection to your device. Okay, and now we will talk about 10 best assets, and starting from 10th place, it's Meshbaker. I think that it is an essential tool for optimizing at 3D projects. It becomes even more crucial if you don't have experienced full-time 3D artists ready to help at any moment. Working with models from stock or freelancers often leads to an excessive amount of unnecessary materials and submeshes. You insert one of such model into your project, and the draft calls are skyrockets. And Meshbaker completely takes off the optimization process. Here you can see some stats about this asset. It starts from Unity Asset Store, price about $79, and you can see that it's very liked and have a high reviews for customers. And here you can see some glimpses of what Meshbaker can do for your project. I used this asset when I was working on Minecraft clone. At that time, I just started my career as Unity developer, but this asset was one of the simplest to use because of its detailed documentation and really friendly creators. And we have a lot of use cases in our project, and it helped us to save time and money, not proportionally to its costs. And now you can look at results of using Meshbaker. This example provided by its developers, and maybe it's a little bit perfect, but it gives you example of what to expect from this asset. If you don't have full-time 3D artists, then this asset is for you. The overall theme of most assets on this list is to fix one of Unity's shortcomings. And Amplify Shader Editor is what shader graph should have been if Unity had put in more effort. When I was working on Minecraft clone, we had a Unity developer on our team who focused exclusively on writing shaders. I can't even imagine how much money and time this asset could have saved us if we had known about it. Don't repeat our mistake, and even if you think that $80 is too high of a price, buy it if you actively use shaders in your projects. And here you can see some features the Amplified Shader Editor provides you with. Also, developers of Amplified Shader Editor created their own Wikipedia dedicated to their assets. There you can find every glimpse of information that you need about this asset. Oh, sorry, here I can see that it's titled Meshbaker, but it's Amplified Shader Editor. And here you can see some features and some examples that Amplified Shader Editor provides you from the get-go. You can create all of these effects without any additional setup, but using pre-created shaders that go in with Shader Editor. Okay, and now I want to talk about Spine. At my own experience, this is the best thing that happened to the animation in Unity. Are you still using frame-by-frame animation in your project, or you are tired of constantly changing Unity tools for working with skeletal animation? Then Spine is made for you. This isn't from asset from Unity Asset Store, but it is the best tool available for working with 2D characters animation in Unity. It's free for Unity. You can download Spine from official site of Spine. Costs lays on animators who work with Spine, and because Spine is comparable, have compatibility with other game engines like Unreal Engine or Godot, it's really widely used. And Spine works on the principle of skeletal animation. The character is cut to parts, and animation is created by changing the state of individual parts of objects. That means that set of 10-20 animations can fit to 1024 on 1024 pixel atlas, a TXT file, and a JSON file. And here you can see that in our project, we have 378 animations, almost 100 characters, and all animation files in our project is only 25 megabytes. Now think about how much space files for 20 states on frame-by-frame animation would occur in your projects. Also, what is really amusing in Spine is that you can fully avoid working with Unity Animator and animation clips. Personally, I hate Unity workflow with animation. It's hard to create animation event. It's hard to get information about end of animation clip, and Spine override it's all with their own functionality. They created a whole list of serialization attributes that give you access to their animation clips, animation skins, animation events without need of use serialized strings in your inspector, because for my experience, strings is one of the worst thing that you can do in inspector, because they're changing rapidly. Someone fixing some bugs and changed to 1 or 2 characters and your animation doesn't work. Also, it's amusing how it's simple to work with information about end of animation clip, end of animation state. You can easily change time scale of animation with all events firing and in right time. Also, if you have great animator or just find one at freelance, you can tell him where do you want to get animation event feedback, and he will add it to animation files. And here you can see some examples of spine animations that we use in our project. It's really simple to get started with Spine. It's really simple to create scripts for Spine. Also, Spine from get-go give you some async methods to run it asynchronously. So if you didn't know about Spine, try it. And if you really like Unity cycles to work with animation, you can use Spine with Unity Animator. And now we will talk about shapes. A little bit pricey, to be honest. It's one of its asset with the highest price inside top 10. But it's really cool asset to draw almost anything in both 3D or 2D. If you're tired of using hundreds of square sprites with different angle roundness radius, or hate using Unity line renderer, then this solution is for you. Three main things that I love about shapes: it's high productivity, open code, and high quality of driving on the screen. And here are some core features that can make you want to buy this asset. In our project, we are using shapes to create tracing games. Letters, numbers, shapes, it doesn't matter. Shapes cover it all. Also, one time I created tic-tac-toe game with smooth driving animation, only using shapes in like 6 hours. Let's go to the next one. And I'll be honest, I cheated a little bit, because at 6th place I have Firebase. It's not a single asset, but a bunch of solutions for your project that will allow you to reach new heights. Firebase is solution mostly for mobile games, but with some simple modification, you can use it also for PC. For example, we integrated usage of Firebase from Unity Editor to make our development processes closer to user experience. And it's really simple. You just need to parse some information from a web service. In Keiki, we use all of these solutions except databases and authentication. And for example, app distribution is like best way to handle testing your games on iOS, because it's really simple to integrate with some virtual machines for build, for example, with Jenkins, and all our tests we run through app distribution. We create build, upload it to app distribution, and our QA engineers can download it and work with it. And what the most important thing that Firebase can do for you? To understand how users react to the features of your project, you can integrate the Firebase Analytic SDK, and by setting up event tracking from relevant parts of your code and monitoring them in the web console, you can gain valuable insights into user behavior. This will help you to identify where users may be dropping off within the application and how much time they spend on each game level or feature. Firebase Analytic is a powerful tool for gathering and analyzing user data to make informed decisions about your project. Pair it with remote config, and you have a very efficient way to test user engagement. For example, here you can see a main screen of our game. And here we can completely change its look without re-releasing a version or releasing new version. At this page, we can change images of these buttons. We can change text, size of buttons, count of buttons, order of buttons on this screen, and space between buttons. So we can make a new look for our main menu without releasing any version. Also, through remote configs, we control various aspects of our application, including localization, privacy policies, list of video content that we show to our users, the list of categories and levels in educational curriculum. You can see its learning plan, or the list and categories of games that we show to our users. So remote configuration provide a powerful way to adapt and customize your application based on your users' needs and preferences without requiring a new app release. After you integrated remote config to your project, you can use A/B testing to monitor how users will react to changes in your app. Workflow is very simple. First, you create a theory, for example, that look of your onboarding will affect its finish rate. Then you choose what percentage of users will be affected by experiment and divide them to two groups. First group will see first version of onboarding, and other will see second version. Then you gather metrics such as completion rate or maybe even user conversion. And on this screen, you can see that a difference in completion rate for two onboarding sequences. First sequence is 23%, and second is 58%, and it's big difference. And what if I say that the biggest difference in competition of our onboarding as a result of changing only one screen in sequence was about 6%? Okay. I see that someone mentioned this asset in chat already, and I doubt that many of you don't know about this asset, but if you don't use it, start immediately. The Twin is an excellent solution for creating animation sequences in Unity. The Twin allows you to create component-based animation from code, combine them into sequences, receive callbacks upon completion, and run them asynchronously. It also supports the use of easing function. It's when you want to change some value depending of some not linear behavior. The Twin is really simple to use and have great documentation. Here I provided prices on free version, it's like $0, and on version that cost $15, but throughout my career, I never encountered a moment when functionality of free version wasn't enough to work with. If you take to account that you can change not only behavior of Unity components, but any given value in your code through .win methods. And at the next slide, you can see some little example of how we using .win in our project. All movement, all animation, appearing, disappearing of text, this all was done by using .win. And it's really simple and efficient way to do it. And I think all not relative to user drag movement, all movements that are not user dragged, on scaling, on color, or all color changes in our project, we handling with .win. And even physics-based movement can be handled by .win. Here you can see my educational project that I was developing for my students. And if you use Spine plus .win plus particles, you can forget about Unity animator for good. Next, we have assets with really simple but very important purpose. The paid and free version of this asset are very important for structuring any project. I believe you encountered files that have been sitting in your project since its creation. They seem unused, but you're still hesitant to delete them. And these two assets will provide you with a full list of dependencies for every file, even if they integrated into an addressable system. And it's really simple assets. They do what they told to do. They just show you dependencies in which files used images, dependencies between prefabs, audio files, you name it, dependency hunter or finder will find it. And at the second place is asset about what I think some people in chat mentioned it too. It's Odin Inspector. Feel the power of Scandinavian gods and understand what the Unity Inspector should be like. Odin is an entirely new way of working with Unity Inspector. First is the static inspector allows you to select and type and view all of its static members. Properties, fields, and even methods are displayed with all their arguments. You can filter the output by member of a type. Also, a decent view of an inspector and the ability to assign their values through a reach. And Odin Inspector provides you with Odin Editor window and extension of the Unity Editor window that lets you forget about writing UI code. A vast number of attributes for working with GUI elements will satisfy all of your needs. You can override the getTarget method and pass an instance of any type for display. It doesn't necessarily have to be serialized or even a Unity object. This allows you to serialize interfaces, abstract classes, and even a collection of such objects. And over 100 attributes that allow you to customize the inspector behavior. You don't need to inherit from anything, just tag the object with the necessary attribute and you go to go. And you can find the full list of attributes and well-written documentation of Odin. Odin provides a powerful set of tools to enhance and streamline the Unity Inspector, making it more efficient and flexible part of your development workflow. And here you can see some examples from Unity without Odin and example with Unity with Odin. look at the monstrosity at the left side, and it's like how Unity 2022 shows serialized properties in editor. Odin fixes this problem. Then you can see how Odin works with enums. Here you can see our system to handle audio enums. We created attribute and marks every enum that should be connected to audio clips. And now in storage, we can choose which type of enum to use. Also, Odin provides you with built-in search. So process of managing hundreds of audio enums is very comfortable. And here you can see a simple way to serialize interfaces in your project. The one thing that when I started working in Unity, I didn't even imagine that it is real. And the icing on the cake could be another asset that pairs well with the serializer, Odin Validator. It will help you detect and resolve issues with broken objects, missing references, and other cleaning-related problems in your project. Okay, it was only 7th. And now I want to talk about procedural UI. There are a few assets on Asset Store that provides you such solution. I chose procedural UI image from Josh Ash because we using it in our project in Keiki World. And I think that you know that when you create in UI, your designers can prepare solutions with a lot of different where buttons have different radius of corners, and there are a lot of different radius, and it leads to a lot of images in your project with difference that only your designers see. And procedural UI image allow you to forget about all of images with simple behaviors that you add into your project. With procedural UI, you can adjust radius of the border of image, adjust the width of the image border. You can smooth borders and so on. I think you know how many megabytes of space in your app this asset will free up for you. And here you can see how one of our screen of our new onboarding is created. At the left, you can see the whole screen. You know that text is Text Mesh Pro, so we clear them. And at the second screen, you can see the only new graphics that I added to project when creating this screen. All graphics that are placed on third and fourth screens is created with Unity procedural image. It's really light on draw calls and a really efficient way to create new UI in your project. And last but not least, is the most important asset that you can add to your project, in my opinion. Because if use of previous assets might be a matter of debate, this particular assets or its equivalent should be a must-have in every project. It's incredibly simple, a debug window for building on a device. If you develop for platforms like standalone, iOS, Android, Windows Store, WebGL, or Web Player, and you're not using something similar, I feel for you and strongly recommend to installing the asset as soon as possible. This asset should be first thing you add to your project after creating it. So what can it do? Display Unity logs in a custom UI on the device with filtering, clearing, and copying capabilities. Get a full stack trace of errors on device, track project initialization, the order of resource loading, and everything you can log without entering the editor. This will help you gain valuable insights into your project's runtime behavior and quickly identify and resolve issues on the target device. Building Profiler for monitoring device resources will help you find problem on device. It comes really handy if you talk about devices with limited resources, such mobile phones or some old phones like Huawei that was released 4 years ago, and you want for your game to run smoothly on it. You just use built-in profiler and you can find place where your game is lags out. Built-in reporter. It's allow you to send logs via email, or if in our case, one of the wizards of my team implemented the debugger integration with Jira, and now our testers can create bugs with logs in just 2 clicks. This kind of integration streamlines the bug reporting process and makes it easier to track and address issues in your project. Open source of this asset allow you to embed your DevTools in the bug panel. Here you can see some DevTools that my team implemented. Changing localization and cleaning cache is most important tool for our QA engineers and makes their life much easier. There were the 10 most useful assets from my subjective point of view, but in reality, there are many more of them. Nowadays, before starting any project, I increasingly check if there an existing solution in the asset store. Water effects, I go to asset store. Realistic ropes, I go to the asset store. To deepest finding, asset store. The answer to the question, why do companies need you if there are so many ready-made solutions, is quite simple. A good specialist is not just someone who can build everything from scratch, but also someone who can prepare the most beneficial business solution in the shortest amount of time. So make full use of the asset store. It will help optimize your work and allow you to spend more time on more complex tasks. And if you scan this QR code, you will get access to my presentation if you want to. Thank you for your attention.
Yeah, thank you very much for that. That's a fascinating look at the different kinds of assets you can get for Unity there. There's a lot of great value you can get for those things there. Some really cool stuff.
Yeah, thank you very much. Yeah, I'm not sure you hear me. I have some mic issues.
Yeah, you're coming through clear. Thank you.
Yeah.
I hear you well.
Yeah, actually, it was an interesting discussion in the chat that people were discussing various assets, like which they prefer, which they installed first. We see many great names in the chat. And also there was a very interesting discussion about which ways to consume the assets that people do prefer, like either it's UPM or asset store. What's your opinion on that? What do you prefer? So like, what's your preferred way?
First, I go to asset store, I find asset there, and then I download from UPM. So it's
so it's UPM
like
also.
Yeah. Asset store I use only for searching and reading about asset because it's more clear way. But loading to Unity is only UPM because it's simpler to delete if it not suits you, and to work to update asset in the future.
Oh, okay.
I mean, I guess that's a good question. You know, simple to delete. How do you decide what package is a good one for you to take or not? You know, how do you evaluate these?
Nowadays, when we're preparing for doing some task, we have our meeting and we put some time to investigation, where there is ready solutions that we can use in our project. For example, last solution that we was searching is Figma converter for Unity. It's just simple asset that will take your UI screen from Figma and create a ready built in Unity, ready prefab. I was searching it, I downloaded, I tried to build a screen with it, and like 2 or 4 hours, I understand that it's not the best way to build screens, because it will allow you to efficiently build only some simple screens without runtime generating. And also it doesn't work well with procedural images. Nevertheless, that creator of assets says that it worked with them, but a lot of additional images were added to this screen where I can see that I can create them with procedural images. So after that, we decided that we will not use Figma Creator. We returned money for it from the asset store, because you have like 14 days to evaluate asset, and if asset not suits you, to return your money, and we move on.
Yeah, cool. It was interesting to see the chat and a lot of overlap with assets that people are using and the assets that you're suggesting there. A couple of other popular ones. Just wondering, like sort of the dependency injection container type assets like Zenject and so on. What's your opinion of that?
I did not added them to list because it's like the whole new way to work with Unity projects. For example, we use Xzenject in our project, not Zenject because it's not updated in a few years, but there are not all projects that need to use Zenject or Xzenject. For example, when I worked on Minecraft, we could not use Zenject because of it's really hard on your GPU, because it uses reflection to get some information to insert values, and when it's really important for your project to run on every device, and there are really heavy processes. For example, in Minecraft, it's really heavy game for your GPU, because of you can build and destroy almost anything. And we just could allow us to add Zenject to our project. Or if you're working with some hyper casual games where cycle of creating that game is up to 2 weeks, I don't see any reasons to add Zenject to your project, because it's faster and simple to do it like straight away.
Mm-hmm. Yeah, it is very interesting that it is something that would change the structure of your project kind of fundamentally, whereas some of the other packages there are more about how they can add into your existing workflow, I guess.
Yep, that's the main reason.
Mm-hmm, mm-hmm. That's a good one. Another question we've got is, why would you use some of these packages if there are already solutions from Unity? I think Spine's a good example there. And if there's something that Unity provides, why would you want to use an asset from the asset store?
With Spine, it's a very interesting situation, because Unity provided, I think, about 2 or 3 solutions for Spine animation through last years. But when there's not one solution, they start to create one solution, they drop it, and they go to other solution. Mm-hmm. And it's hard to work with that kind of solution. Also, if you're speaking about Spine, it's a solution that is compatible with Unreal Engine, with Godot, and used in and have more use cases that Unity animation. So to find animator on freelance or to find animator in your team, it's really easier to find spine animators than technical artists that will create animation in Unity, because no one want to work with solutions that is very limited. And similar cases can be applied to almost any solutions that are works outside the Unity, and also for solution from asset store that Unity provide an alternative. As I said, the main theme of this list is to recover Unity shortcomings. Many of products that Unity provide for us is not really perfect. So you can remember TextMesh Pro. When Unity started, they have their own text, and it was dreadful. And that guys created TextMesh Pro, and nowadays Unity, I think, even deleted or put their old text to duplicated section and use only TextMesh Pro.
Very good. Well, thank you very much for a great overview of some fantastic looking assets there. It's great that there is such a thriving community and ecosystem of assets and plugins which can provide such great value, to be honest.
Yeah, thank you very much. That was very interesting.
Thank you too. Have a nice day and interesting discussions.
Yeah, thank you.
Thank you.
Thank you. Yeah,
Goodbye.
Nice. Yeah, so many talks have passed already. Could you just imagine? It feels to me like we just started. How come?
Yes, we've had quite a good set of sessions so far.
Yeah, and we are nearly ready for the lunch break. But before that, I would suggest run another quiz, a very short one with just one question.
That's
right.
Quiz.
So let me remind the rules. So read a question, and all you have to do is try and share your answer. Like if you're watching us online, just share it in the YouTube live chat. The first to answer correctly got the .ultimate license, 1 year personal license for .ultimate, covering ReSharper, Writer, and .tools. And like if you're on Cyprus or watching us in other streams, so like, yeah, share the answer to your host. And if you're the first one with the correct answer, you get the license. Okay, so let's do some game-specific question, right? So it will be, what was the first FPS game to use the right trigger to shoot? So let's wait for the answers.
Run that one by me again. What was the first FPS game to...
First FPS game to use the right trigger to shoot?
Wow, that was specific. I have no idea.
Yeah, it's a tough question before lunch. I know. But
wow.
yeah, we have to do that before the lunch. And yeah,
Okay.
I know that for some people, the time zones are completely different because we have like people from Australia and many other countries. So for some people, it's probably like breakfast or dinner or just midnight coffee, whatever you want to have.
Midnight snack.
in the next half an hour, just feel free to have this break, and don't forget to be back because the Godot talk will be starting right after lunch. Yeah, am I correct, Matt? And while we're getting,
we're just going to say we're going to go talking Godot after lunch. We've got some more Unity and we've got some Unreal as well. So there's plenty of great topics.
Absolutely.
Still to come.
Yeah. And while we're still collecting the answers, I will repeat the question for the people. So what was the first FPS game to use the right trigger to shoot? So while we're collecting the answers still, so I would like to say that me and Matt will say bye to you with this lunch break. And there will be another pair of hosts, so Khalid and Further will join you right after the lunch for like amazing second part of the day. Okay, so I think I saw the correct answer in the live chat, right? Yeah, it was like Pavlo Prokopov. It was Hala. Yeah, that's the correct answer. That's true. So I'll share my email again in the chat. Yeah, and if anyone has any questions regarding our tool, you can also use my email shared in the chat. Yeah, so
well done on knowing that one.
I don't think that's the top secret, actually.
No, there's a go. I had no idea what that answer was. Yes.
Yeah.
One thing we
Okay.
should do
Yeah.
as well, though, is if we're talking about assets in Unity Store, we need to give a shout out to RiderFlow.
Oh yeah.
So
Yeah.
if you haven't tried RiderFlow, it's an asset for Unity that we've built. It is a free plugin for Unity for the editor, and it provides a whole ton of fun features for the editor. Things like grouping in the hierarchy view, find usages, replace objects, and camera presets, and so much more. It's nice. It's RiderFlow, and it's free, and you can get it from the asset store.
Yeah, I guess it's important to say that it's actually a free asset, so you're just free to
yeah.
grab the free asset and use it.
This is great. Great. There's a great search feature in there as well. So if you're like used to the search everywhere from Rider, you've got a similar kind of thing in Unity now, and it's very cool.
Yeah, exactly. Okay, so we have 25 minutes break for whatever you prefer, coffee or tea. Or yeah, just grab some food or snack, or just have some rest. And please make sure you come back in 25 minutes for the next portion of Talks for Our Game Dev Day. Thank you.
Thank you. See you later.
I'm not the man you want. You've made a mistake.
I'm in touch with technological advances pretty well everywhere, and I can tell you that no one has produced anything like this.
Oh, hi Khalid.
Hey Fedor, how are you doing?
I'm fine. Was watching the previous sessions today. Was very interesting for me, and for you.
Yeah, they were really fantastic. I also have to say the break music slaps. Like that was I could see chat was asking, "Hey, what is this music?" Because it was pretty awesome. So
yeah, it will be a good vibe for the second part of our sessions.
Yep, for sure. Chat is also really excited for our next guest today, which is going to be talking about godot-playfab. For folks who don't know, Azure PlayFab, backend as a service, and integrated into Godot, which our chat is just kind of going nuts for. So I think we're excited. Fedor, do you want to introduce our guest?
Oh, maybe it's better to do for you because you are a known Godot fan.
Well, he did promise me some stickers, so I'm hoping to get those stickers. So, without further ado, let's introduce Johannes Ebner, who will obviously be talking about Godot PlayFab. We talked about that. He's a known gaming solution architect who helps game developers and publishers from all sizes kind of get into the PlayFab thing. So, Johannes, welcome. Really excited to have you here today.
Hey, it's great to finally see you in person, Khalid. Khalid, I'm probably not pronouncing your name correct, so I'm sorry for that. Can you help me?
It's good. It's good. It's all good. We're all friends here. You can call me whatever you want. It's fine.
Oh, lovely. I've been following you for a very long time on Twitter and in the .NET space, and now Mastodon, but it doesn't work for me so well. So.
Oh, okay. Well, I appreciate that. It's part of what
fanboy.
Yeah. Oh, thank you. Part of what we do is just help the community, and I think people like you are really the superstars of our .NET community. So, on that note, I'm gonna give you the stage so you can talk about Godot PlayFab. Fedor and I will be here in the background if you need anything, and also chat. Please ask questions. We're here to help you out, so feel free to ask questions, and we'll ask them at the end of this talk. So go ahead.
Fantastic. Thank you very much, both. I hope we will have time for questions at the end. So let's get started. Today I'm going to talk about Godot PlayFab, a little bit about me. Khalid has said something already. I'm the founder and gaming solution architect of Structure.me. I used to work at Microsoft as a gaming solution architect. I have been a game developer myself and worked in the C# space a lot, also PHP. I did MMO games, right? And my last kind of role at Microsoft was a gaming solution architect, where I helped like the really big publishers like do Azure stuff and for gaming, build infrastructure and so forth. And I kind of became the premier expert on PlayFab, and now continuing as my own company. So I've worked on things like Valheim with Pictive to kind of integrate PlayFab Party. I'm now consulting on Caged Elements, Warhammer 40k, Speed Freaks. So yeah, that's kind of what I do right now. But I also do Idea Azure expert sessions and blog posts for them to kind of help to spread the word. But enough about that. Today we're going to talk about Godot PlayFab, which is the premier PlayFab SDK for the Godot engine, and it's now used by titles like Domekeeper. First, let's talk a little bit about backends and why every game needs one, right? Even a single player game, because most people really think that only multiplayer, or a lot of people think that only multiplayer titles need a backend, right? They often think about multiplayer service and so forth. But what it's really about, and that's why I think it's so important, and is other things, right? And we talk about this in a second. But first, what is a backend, right? It's a remote system that supports your game with things like analytics and other things, right? And you can either build it your own by yourself, right? Which has a very high complexity. You need to invest a lot. You need to plan this. And the investments not only include money, but also obviously time and manpower. and you need to have a lot of expertise, because when a game launches, we have hopefully all seen that if you're successful, right, it can go through the roof, and then scaling is so important. And you can build it yourself, right, or you can buy one as a backend as a service, or a BaaS, as I've spelled it here. So what are the core components of that? And when we look at single player games, I think the most important piece is analytics, because when you build a game and you launch it, then, right, and first you test it, you want to understand your players. And by that I really mean you really want to understand where to invest, right? Because today a game is often a multi-year investment that you build. You constantly test it in between. Already there, you need to know where your players are going. Yeah. In an open world, for example, World of Warcraft, everyone knows that you want to see in which regions players walk around, right, and which interactions they make, right? And if you see that players don't go to a specific location, then you have, if you have the data to support that knowledge, right, then you can make a decision on whether you want to continue investing in that area and make it more interesting, right? And then watch how that changes when you've implemented something more interesting according to yourself. Or you can stop making it accessible, right, and just neglect it at all, right, and divert your resources to somewhere else where it makes a lot more sense for you, and for your players, obviously. And then sometimes you also want to segment your players, right? You want to understand who are your core players, or who are your potentially churning players, right? That you're about to lose, because in today's world, when we have a multi-year investment into a game, you usually also have a multi-year investment afterwards, and to make it really successful and really have your return on investment. And for that reason, it's also very important to understand those analytics. And it's important for your team to have an understandable system, because you can have as much data as you want if you don't understand it and if you're not using it, right? And this is where we really get into story time, right? Because I've worked with a lot of AAA game developers and publishers, and I've seen so many things, like many companies are collecting a ridiculous amount of data, and they have it, but they don't do anything with it, because sometimes they say, oh, we don't have the people to analyze that data, but really they are lacking, I think, systems to analyze the data and make it easy for them, right? And then another story why I think backends are so important, and particularly analytics, is that I've talked to an indie developer, and they were about to go into beta phase for their game, and I asked them, what is your analytics story? Because you surely want to know where you're going to invest. That's the purpose of the beta, right? Is to see where you're going with your game, what your players like and what they don't. And they said, and I couldn't believe it at first, right? But I've since heard this many times, oh, I'm going to use Steam achievements. And I think that is a horrible idea, because first, you're misusing a feature that you could otherwise use more efficiently for your players, right? Because your players really expect nice achievements. And also, it's a lot of work to integrate them on the platform, right? And you're kind of restricted in terms of what kind of payload you have, right? But you really want to have a very easy and flexible solution to kind of like log anything, or have events or analytics events sent to a backend platform arbitrarily, and you don't care in your game client. You just want to have as much data as possible to analyze what's going on. Okay, one other thing that I think is super important in terms of backends is for single player games particularly as well, right, is balancing, because all games really are a lot of calculations, and you have a lot of balancing variables, and you don't want to update your client just to make balancing changes. And in order to avoid that, or specifically not when you do console releases, because then you usually need to sim ship, right, across, or simultaneous ship on multiple platforms. So you don't want to have client updates, and the easy way of doing that is using a backend, right? You have the initial values in your client, right? But whenever your game client is started, it pulls new values from the backend, if there are any, and then it can cache them and work with those, right? And this also not only enables you to do easy updates, but also see the implications right away. And you can then track with your analytics implementation these effects and see whether you have made a right choice or a wrong choice, or how you can improve that. And the last bit, I'm really adamant on why backends are important, is doing experiments, or as some call it, A/B testing, right? You want to test out new balancing variables. You want to test out new features, right? And specifically together with segmentation that you can do usually with analytics and player analytics, you can determine a subset of players that you want to kind of push a certain feature or a certain balancing change to, right? And when you have like your top 10 players, right? Or let's say you define a group of insiders, right? You can kind of like, as a player, you can apply to be an insider, right? And you define an insider group, and then you can say, my insiders get the new beta feature, right? It's already in the normal client, but it will only be unlocked to those insiders, right? So you don't need to have a specific beta branch to test new features. You can just like remote enable and disable them. And you can then, with your analytics implementation, and really, really see how it works for you. And for the players, obviously. So let's talk a little bit about PlayFab and what a backend as a service is, right? PlayFab is a backend as a service. It is a hosted service that is free to use up until 100,000 players, with some restrictions in terms of multiplayer. But for like every single player game, it's way enough to use that for development and for the initial stages. And even after that, if you're not reaching 100,000 users, it's free of charge, and after that it's super cheap. And if you're successful, right, it doesn't really matter, right, if it costs a little bit. So this is a backend as a service that you can easily use and very easily integrate into into your game, right? And this is where really godot-playfab came into play, because there wasn't an SDK when I started messing with Godot, right? Where I wanted to build my first side project game, and I wanted to integrate PlayFab, right? And I kind of got into the position where I said, oh, there is no GDScript plugin or SDK for PlayFab, so yeah, let's build one, right? And I also didn't want to auto-generate it, because I was kind of frustrated by the auto-generated SDK. So I thought, like, developer experience is super important. So let's build my own SDK the way I want to use it. And that's how I got started with godot-playfab. So let's get into demo time. I'm going to show you now the PlayFab portal. So you get a kind of a feel of PlayFab, of what PlayFab is, and then I'll show you how to integrate it. So you go to playfab.com and you can sign in with your Microsoft account. I'm just going to skip that. When you launch it, you have an empty page here. Basically, you can create new studios, and within a studio, you can create a title. You can see here it is currently in development mode. I can have up to 100,000 users. This is a hard cap, so if you launch a game, you should upgrade the account. It still stays free until 100,000 users. And the title ID, we need this later. But let's look into this. So first you have a little dashboard where you can see a lot of like basic stats already. I'm doing this very quick because we have not a lot of time to finish this. So excuse me, and you can always ask me questions afterwards. If you look into players, right, you can create players and sign in players with any like platform agnostic account, or you can create your own accounts anonymously or with email and password. And here I have a couple. This is my last logged in. You can already see some base data, like how much they spend, because you can also integrate mobile payments like Xsolla or Android or iOS payments, and Steam, I think, as well. You can see where they are from. I'm from Fürstenfeldbruck in Germany. That's where I live. And you can see already there's a lot of things like friends and inventories and things like that. Files, you can upload files here, like save games, for example, right? So this is pretty awesome. You can just, this is also great for live operations. You can just grant people an item that you have defined. Let's quickly look into economy. This is we're going to look at the legacy one because that is often for single player things more useful. You can define items, you can put them into drop tables or containers. You can think of boxes, like in Diablo, for example, you open a box, that's what you get out of it, right? You can do stores. Again, Diablo, you have a vendor there. You can define that vendor store and then manipulate it. I think that's even for a single player game, this is an extremely cool thing to be able to do. And really all the features in Playfab, you don't have to use them at face value. You can also kind of misuse them in a way if it fits your bill, right? There's also like content. This is where you have title data. This is like balancing variables. You can do this as key value pairs or as JSON objects here. You can also do title news. So these are news like change logs that you see in the main menu very often. You can do things like that, even localized in different languages. And a lot more. Here are also dashboards. I'm not gonna go into this a lot, but what I wanna do more is events. So this is data. This is where you can actually see the incoming event analytics events. And this is what we're gonna do here in kind of the integration demo I'm gonna start in a second, is that we create our own playstream events that you can see coming in. So this is the basic data explorer. You can also go advanced and have a pre-prepared that. You can also have like a SQL-like query language, Kusto query language that you can use to kind of dive into the data, and you can also render this and stuff. All right. A quick word on events. Events you can do two ways in Playfab. So there's telemetry events that are ingested in not really real time, but like maybe a minute or two, or sometimes a little bit longer delayed. But you can then access them in the Data Explorer and kind of analyze it. There's the exact same API, but it's called PlayStream. And these are in near real time. And you can use them to react in the backend, for example, or gift items, for example, right? You can also see them coming in near real time if someone adds an inventory item, for example, which I did. And you can then see the actual payload directly. So this is kind of interesting to watch, right? This API, if you're in the paid tier, is a little bit more expensive than the other one. So if you're just collecting data, you should always use the telemetry events. This is also documented in the godot-playfab docs that you can find on the repo. All right, let's get started with the demo. I've already prepared a little bit, like a very simple game that was easy to implement. We are counting cats and dogs, right? You can just like click this, you can reset it. We're not logged in right now. So when we look at the scene composition, there's just one scene. It has a main node that is a abstract control. We have attached a script to that, the main GD, and in that we have a couple of layouts. I'd love to build this in real time, but the time will not be enough. I've tried it. I'm sorry. And because there are a lot of cool stuff in Godot that I'd love to share to everyone who has not worked with Godot yet. But yeah, we have a label here that says whether we're logged in. We have the cats button and the count label and so forth, right? What you can see here is this is a scene unique node. So you can define a node as scene unique. Over the context menu, this means that you can easily reference it in code by its very name instead of a path in the UI. The other thing is that signals are connected. Signals are a way in Godot to kind of like, it's the same, if you know C#, it's the same like delegates essentially, right? Where you can kind of like have an event triggered that you can observe then. So here I have connected, that's the term in Godot. I've connected this to this function, right? So let's look into the code real quick. So we have these event handlers for the free token, for the free buttons, and we have the count variables here. So this is GD script for everyone who's confused. And this whole script extends control because that's the node type of this node. All right, so let's get started by adding godot-playfab. So we have the asset lib. It's kind of the equivalent to a store. And I just did a new release yesterday because I added a new convenience function. So this means I was lucky to get in front here. So just click this, and then you can click download. It will download it. We actually I made an error with packaging. I need to fix this. You have to deselect all of this, or you don't have to, but it's encouraged to do because you don't need all of this. There's a lot of examples and the actual source code of godot-playfab in it, and you don't need all of this. So just look at the repo if you want to see the examples. Those are usually in scenes. The only thing you need is the add-ons godot-playfab folder. So click install. And you can see there's already a lot of errors. We ignore them. That's because the installation adds something, an autoload. Ooh, damn it. I just killed it maybe. First, we need to enable the plugin. And then we can go to autoload, and it adds an autoload. That's kind of like a fake static instance, so to say. Okay, and then we also need to set exactly one setting. Filter for playfab here. We need the title ID that we've seen earlier. So let's get this from here. You can find this in the URL, or you can find this in studios, my studios and titles as well. It's the same here. Okay, just here. And go. So now it won't do anything, just the same. We need to hook this up in code. So let's go back to the script. And first, we obviously need to log into playfab. So func ready. That is the initial function that is going to be called when this node is added to the scene tree. So basically when the script is first run. To do this, we're going to access the playfab manager, which has a client instance, and we do login anonymous. That's in fact all you need to log in. But obviously, we want to know when we're logged in or whether an error occurred. And for that, we need to connect signals. So we're going to paste this because I'm a lazy writer. Connect. And we use the signal name. The signal names I've documented here. So if you go down on the original godot-playfab repository, I have a user guide. Here's connecting signals. So we have a couple of signals that can be connected. For the login, I always recommend these two, API arrow and server arrow, to be connected, and then the logged in here. We're also going to register implicitly anonymous user, but we don't care. We just care for the logged in event for now. Okay. That also kind of leads me real quick, a quick side note. Why I'm using this static instance is you can also just drop a playfab client into the scene here and use that. The reason I'm not doing it is because I want to handle these kinds of errors globally, right? Otherwise, I would have to handle this or connect it to each individual instance here. You can have as many instances of playfab client in your scenes as you want. And in fact, you sometimes want to, because one of these instances can only handle one HTTP request to the REST API of playfab at once. That is kind of a limitation that I can only save with Godot 4 now, but I haven't solved it just now. So this is going to be worked on in the future. But it's very rarely that you need multiple requests at the very same time. You can also queue them in a way. So now we connect these. Oh, we can also bind a method. Actually, I like to define functions individually. We can also use lambdas now, but I prefer actual implementations because it's clearer here. So let's do this. We have a result, which is a login result. And we just manipulate here the label. And here comes a cool feature. I can just, if I don't remember, I can just pull this in, right? To log in. Also going to set the color to green because we like that. So we click this. We want to do a theme override. Oh, I need to go back here. Go here. What's going on? Here we go. We want to do a theme override colors font color. So there is no actual property exposed, but we can set a property via a setter. So we just do this again because I'm lazy. Set the property name and then green web green. That's the color I want. Okay. Fantastic. Okay, then we're also gonna copy and paste this and do this for the other errors. Error, server error, which we're gonna handle with their own methods. Error. Good. So we're gonna do the error message here. Print this to the console, and we do the very same thing for server error. Okay, so let's test this. We're logged in now. Fantastic. Alrighty. So we got this, and now we are going to send some telemetry events. And we're going to do this whenever someone clicks that button, because we want to know how often one of these buttons is being clicked on, right? So for that, we're going to drop a playfab event into the scene. Hang on. Ooh. Again. That's weird. I'm sorry. Maybe this is a problem. Sometimes, like, this is something that happens more often in Unity than Godot. I'm sorry. So we add this here, so we can make this also scene unique. We go to the script and we can just do that. So whenever we click on the dogs, we want to send an event, right? So let's first implement a function to send an event. And we're gonna say which animal. And maybe also the count, because we want to have payload. So we spell event. This is how you spell event. So we're gonna define a payload. That's a dictionary. And so see how easy this is. I love GTscript. So we give it. We also define an event name, animal count, or animal votes better, because we're voting for animals. And then we're gonna use the playfab event to write. Come on, autocomplete. This is sometimes when they had script errors. Kind of bugs out. I'm gonna use the dollar now. Maybe it's a problem of the scene unique name. Hang on. So we're gonna paste in the event name, the payload, and have a lambda that prints the like a confirmation, right? When it's returning. So let's see. It's funny, I don't get the autocomplete here, so I can't show it to you. But essentially, the lambda is upon finish, upon the event is sent, right? The playfab event class is written in a way that it automatically batches events, so you don't like spend the API cycles on it and pay for them, because you essentially pay a microcent or something per API use. I'm exaggerating, but very little if you're not in the free tier or in the free limits. So let's send an event. Whenever you click one of these buttons. Let's get started here. Open the PlayStream monitor. This is where this all comes in. Oops. Okay, so we should see this coming in here. Gonna vote for cats, and you see this coming in. And if I click this multiple times, these will come in multiple times, but I will only send them once in one batch in a flush when the play stream buffer is flushed. I like cats more, so that's why I'm gonna click cats more often. And we can see here the payload here. If we click on it, and if we go back to the Data Explorer, so we had, I think it was a total of 100 records. No, it's not 100 records. Well, you get the point. It's a little bit delayed, right? So oops, it's a little bit delayed. It's the right one. Let's select those. Oops. Oh. Double equals. Oh. So that's that. So yeah, you can. That's a little bit bad with the huge resolution here. I can't really show this here. Yeah, you can actually see the whole payload in here as well. So yeah, that's about it. I don't know how I'm doing time-wise, but that kind of marks the end of my presentation. And if you have more questions, do let me know. You can always contact me at any one of those social platforms, and primarily Twitter. So thank you very much for having me.
Very, very cool talk. I know Godot is hot right now in terms of people looking at it and trying to support it and do those things. So this has been like a pretty awesome talk. We do have several questions, specifically around GD script and like C#.
Yeah.
Does godot-playfab like help folks that maybe want to write their Godot games using C#? Can they still use the asset that you've created?
For C#, no, not directly. So this is specifically aimed at GD script. But the cool thing is with Godot, you can actually use both languages, right? It can be a bit tricky to use both in the same project, right? But you can totally do it, right? But there is a C# SDK for it. You should use that, right? It might not be as straightforward in terms of some of the usability features, but it's good, right?
Yeah, and I think that's a good point. It's like if you're using C#, use the C# specific SDKs and libraries. Like that's the whole reasoning behind you picking, say, C# over GD scripts. So
absolutely, yes,
it's a really good point. Fedor, do you have any questions you want to ask?
Yeah, we have some questions. One of them is, do you cut the whole API interface of Playfab with godot-playfab?
Yeah, so a good question, because that is a huge undertaking. Like it's a really big API. You have to understand that there is not only a client API and an event API that I just showed. There is also a server-side API and an administrative API that you kind of use from the backend. So it can do a little bit more, right? And as a single person, I cannot cover it. I don't want to generate anything. But also the API is very straightforward, and given GD script is super straightforward, right? And basically what you need to do, because I also did like the authentication, the background cached and everything, there's a very, very simple call that basically says, go with authentication, make requests with authentication, and you just put in a path and a payload as a dictionary, right? It's super simple to do that.
Yeah, you mentioned specifically like Azure PlayFab has that user limit, like the free tier and then the paid tier.
Yeah.
You were talking about user counts. Is that specific to user profiles created in your Azure PlayFab title, or is it active users per month? So, like, if you have active churn in your game, is that more the user, or is it just someone creates an account and that's automatically a user?
No, it's in fact those accounts that you saw earlier, right, when I demoed it. So for each account that is being created, you go closer to that limit, right? So once you have hit that limit, no one can sign up anymore for your title. So that's why it's so important before you actually go launch your title to make this production, right? But it doesn't matter in terms of pricing, because the free tier is still inclusive of that, right? Or it's still inclusive of the free tier, right? So you don't pay for the same thing, right? But it enables you to grow out of that. But arguably, with 100,000 users, you should be profitable, I hope.
Yeah, I hope so too. Like, but there's a lot of free to play games, so
indeed.
Sometimes you can get into a situation where, like, a good example is probably like Vampire Survivors, like, exploded. Yeah, like that might be like a tricky situation for a lot of folks. So,
indeed. But I don't think they have money problems either.
Yeah, I think they're doing fine. Yeah, for sure. I've wasted hours on Vampire Survivors. So, but another interesting question with PlayFab, like, obviously the API is expansive. There's a ton of features that people could kind of opt into. What do you think are like the most obvious ones for people to gravitate towards and actually put in their games? Like, because there's a lot there, but like, what are the core ones that you think people should be using?
Those are the ones that I talked about in my presentation. Is really the data, the data aspect for analytics, for balancing variables, and then the experiments. That is basically what every single game should be using, in fact, right? I personally, as a consultant, would not understand if you're not using it, right? Because you're missing out, right, on so many opportunities in optimizing your workflows, right? The other things is like really automation. I didn't show this because I can quickly. I think we have a little bit more time. So you where's the share button? I'm sorry. This is not Teams. I work with Teams every day. I can't. I'm sorry. I can't find it anymore. It's gone. It's not on the page anymore.
Oh, it's okay. No worries.
Anyways, so you can essentially you can have cloud scripts, so Azure functions that you create on the Azure platform, right? And these are very small programs that you can upload, like in C#, and you can actually trigger those with events, with playstream events, for example, and react to those events. Like if a player churns, right, you can send them an email if you're really obnoxious, right? And or when someone hasn't logged in for a long time, you can give them an item or things like that, right? And that I think is really great in a world where we have longer term games going on, right? That you need to kind of like post sales monetize in order to make them a commercial success.
Yeah, those are really, really good points.
Sorry, one other thing is leaderboards. Sometimes in the API you can also hear them talked about as statistics. They are a fantastic thing to misuse, right? It's basically a table storage, right? And you can rank, and that's a fantastic thing to misuse as a data storage, so to say.
Yeah, it's interesting too, because a game that comes to mind that, like you were saying, PlayFab isn't just for multiplayer games or massively multiplayer games like your Diablos or like just Warcraft and those kind of games. But recently I've been playing Street Fighter 6, and the first screen you see when Street Fighter 6 comes up is Azure PlayFab.
Yes.
And a one-on-one game like Street Fighter, yeah, it has leaderboards, it has balancing, like a lot of things you mentioned in this talk. So like backend as a service feels really, really important for any type of game that you're creating. A question somebody had, which I think kind of relates to what we're talking about, when you're working with smaller studios or AAA studios, like, have you noticed any difference in kind of their like development style, and has PlayFab kind of helped equal the playing field for a lot of these kind of studios?
In a way, right? I mean, you certainly noticed from the C# world, right? How like well equipped kind of like developers are in terms of backend development, right? That's not a thing in the games industry at all, right? In mobile, yes, people are well equipped to build backends because they are so ad heavy and everything, right? And have always been. The AAA games industry and also indies are kind of caught up in this we want to make a game, right? That's what they have always been doing, right? And there is literally no experience in building backends, right? Even with the big ones, only the very big ones do have that expertise, and so this is totally leveling the playing field, right? Because whether you're big or small, all of them are using PlayFab or other competitors in that field, right?
Yeah, I think Oles in our previous talk mentioned Firebase too as like a potential other option. But you know,
yeah, indeed. It's funny you mentioned that because there is a Firebase plugin for Godot, and I'm kind of good friends with the maintainer of that. And we actually wanted to do a talk together at the GodotCon, which is happening here in Munich, which I'm co-organizing, by the way.
Oh, cool.
And yeah, he couldn't come, but that would have been fantastic, right? Because we're essentially doing the same thing, right? And it's really about helping game developers continue concentrating on making a great game rather than building a backend, right? That's all it is.
Yeah, that's excellent. Like, I think it's nice to see two essentially like competing services and like asset authors still collaborate, and the main goal is to make sure developers get their games out there, help people find the fun in kind of building games and playing those same games. So I think that's really admirable of you. And
thank you.
Yeah,
thank you. It's also a lot of fun, and you know, you can learn a lot from each other.
Yeah. I guess here's another question. We saw you kind of structure your events, right? For I'm a dog person, so when you were clicking cats, I was like, I was slowly dying.
I did it. I was just doing it for you. Got it.
But is there a way like to structure your events? I noticed you were sending the state of the count every time, so like the state was being managed in your game. Is that the best way to do it? Is it better to kind of send the events and kind of compile them using that KQL query language that's on the Azure side? Like, what are some recommended approaches there?
I mean, for events, sending the actual count is probably not good, because that is what I would have been doing in a leaderboard. I just wanted to show that you can send this kind of payload, right? But you would track the numbers actually in a leaderboard, and you would probably write the leaderboard from a server side, right? Because otherwise everyone's going to cheat on you. And so you kind of want to send as a payload the data that you're interested in, and that is a hard question to answer, right? Because it really depends. For that, and just counting how many clicks you have on each one of these, you wouldn't need a payload at all, right? Because you would just count the or maybe just the animal name, right? And then do this in KQL and analyze how many dogs and how many cat button clicks there were, right?
Yeah, I can tell you're a consultant because you use the magic phrase, "It depends."
Oh yeah, all the time.
Yeah. Fedor, do you have any other questions that you've seen kind of come in from chat?
I think that we have one more question, and quite important nowadays. It's that by using PlayFab, one is collecting user data, and is PlayFab GDPR compliant?
I'm not a lawyer, so it's hard for me to answer this, right? So take it with a grain of salt, but it's you who makes it GDPR compliant, right? It's always dependent on the data that you collect. PlayFab does collect PII by default, right? Like I think PII is an IP address, right? And that is collected. You saw it geolocating me to my hometown, right? Which is in fact, I think, PII, right? So you need to definitely ensure that you have the right kind of disclaimers in your game, like when you do a website or whatever, right? When you use analytics, you kind of need to tell people about that, right? And so you can make this opt-in or not, right? And it's really on you, and you need to make sure that you also deleting user data when you get a request for that, right? So it really depends on you, but it can be. Let's say that way. Yeah, it's great that we had so much time for questions. I think I how it is in life in the real world. You time it all the time on 45 minutes, and then you rush through this in like half the time. So.
It's okay. I mean, there's a lot of good
Sorry about
stuff
that.
there. I shared some of the links to your repo, so folks can kind of go check that out. You know what? One more question for you, because I was like, when I was watching, I'm a more of a business developer. I'll admit it. I'm on game dev hosting duty, but I'm more of a business person. Hopefully people don't rush me out of here. But a question I had, like with PlayFab, you can kind of keep track, especially if you're building MMOs, you can keep track of your game's economy. Are there ways to kind of set anomaly detection so that if something happens where there's an exploit based on your economy, you can kind of be notified that something bad is happening, like someone's duplicating gold? Like if you're a Diablo player, you remember that gold duplication trick, right? Everyone's used that.
This is like kind of on you right now, as far as I know. There is some additions to the economy being made, but I'm not sure that there is a new feature that would enable that, right? But I'm sure there are a couple of best practices that I'm just not aware of. I'm sorry.
Oh no,
but
no.
Yeah, no, it's a really good question. Yes, indeed.
Yeah. Well,
and I'm kind of sure it's gonna be solved in a way, because Microsoft Flight Sim is using it, Minecraft, right? By the way, single player games. They also use it for mod management, by the way, which you can also do as well.
Yeah. Another thing you mentioned in the talk, I think, is like, whenever you have to deploy to platforms like Xbox or PlayStation, you potentially have to pay a fee to kind of like publish a few patches, right? But you mentioned that you can change things in your game by using Azure PlayFab that maybe can help you reduce the cost of operating your game. What are some kind of things that make sense to kind of handle through PlayFab versus just doing a complete patch release or update to your game?
So the famous commit we did back in the day was improved luck, right? For a random generator, because like luck is perceived very differently, and so a like kind of chance of like for loot to drop on a specific enemy, for example, is a very good thing that you should be controlling from the backend, right? Because you have to change this all the time. If you look at also look at games like Diablo, most of the changes they do is actually balancing, right? It's not like content, it's balancing that they are changing. So if you can do this without a client release, that saves you so much time and money and resources, and can make the community a lot more happy.
Yeah.
Another thing is maybe, I don't know, like the actual drop value or the value of a specific item or something like that, right?
Yeah, I mean, that makes a lot of sense, especially if you're having like weekend events or something like that, where you want to kind of engage your user base and want to give them like more for kind of playing during a certain time. I think that makes a lot of sense.
Yeah.
So.
Or like Halloween sub, right? You already patched this in like in March, right? And then in like just before Halloween, you enable this when you do your marketing event around that, right? So you just flip a switch in PlayFab and you have this running in your game, right? And
Yeah,
also
that's
kind of unlock additional items that you wanna drop and things like that. Right?
Yeah, I mean, we're doing a Halloween event here. I love kind of the game dev theme this year. So yeah, it's pretty cool. So yeah, Fedor, do we have any more questions, or should we
I should I think they should proceed to the next speaker.
Yeah. All right.
I'm
Well,
sorry.
oh no.
Thank you.
Yeah.
Thank you very much for the
Thank you so
conversation. I
much.
really enjoyed that.
Yeah. Thank you so
Thank
much.
you very much for having me.
Yeah.
Have a good one.
Yep. Bye, Johannes.
Oh, I'm
Bye.
sorry.
Bye.
Was it too quick?
No, you're fine. You're fine. Thank you so much. We really enjoyed this talk. Chat was great. We enjoyed this conversation. So we'll see you
Lovely.
next time, and have a great day.
You too.
Bye.
Bye. Thank you.
Bye.
So that was a really cool talk. Yeah, I'm kind of also excited for our next talk. I know we say that as hosts all the time, but we've had some fantastic talks today. Our next guest is going to be talking about how to apply software engineering processes to the game dev process, which, you know, I've kind of hinted that I'm more of a business dev person. So I'm really kind of excited to see how these things kind of relate to each other. Like, can I, as a business dev, maybe transition into game dev and kind of use my skills in there? So I'm excited about this. So let's introduce our next guest, Ryan L'Italian. Let's bring him on, and we'll say hi. Hi there.
Hey, Ryan.
I love your background. This is the way, you know.
This is the way. This is the way. I'm going to show you the way. I'm going to show you the way.
Yeah,
Thanks for having me on.
Oh yeah, we're so happy to have you here. I think this is a really great topic because, you know, building games isn't just about one person doing it. It's really about teams and process and trying to make it as efficient as possible. So I think your talk is really going to resonate with a lot of people.
Yeah, absolutely. And I'll kind of not skew it towards the business development, but anybody can take these concepts and go forth with that. So anybody can be an indie dev. So we'll talk about what I've learned, and we'll go from there.
All right, great. We'll give you the stage, and we'll mosey on back there. So good luck.
Awesome. Thanks, guys. Yeah. Great. Good morning, gamers, indie devs, experienced software engineers, colleagues, game developers, and enthusiasts who've gathered here today to explore the traditional software engineering processes that coincides with the dynamic, fast-paced world of game development. Welcome to How to Apply the Software Engineering Process to the Game Development Process. My name is Ryan L'Italian. It's my honor and pleasure to talk to you today about the world of developing a game using the structured pipelines of Perforce, Helix Core, Unreal Engine, and the JetBrains tool suite. Since game development can be, or is it, an art form, I thought it'd be a bit fun to get a bit creative with word choice today. So software can be a bit dry, so let's spice things up a bit. So my name is Ryan L'Italian. I'm the gaming and media and entertainment evangelist for Helix Core. It's a product on the Perforce suite of products. It's a source control product. We also have other tools in that suite, digital creation, project planning and testing, and kind of creating content for game developers. Our product is not just for game developers, it's for semiconductors, software, and companies who really want to care about security and collaboration in the DevOps toolchain. So myself, I've actually been a software developer for 15 plus years. I was tempted by the dark side of sales by one of my friends, and I switched to kind of a solution engineer. But now I'm a evangelist for the game dev industry for Helix Core. So I'm excited to kind of take you what I've learned through the CI/CD, the DevOps mindsets, kind of the build once, deploy everywhere, you know, strong builds, promotions, build once. And so I want to take you kind of what I've learned through DevOps, apply that to the game dev process, and make your pipeline more efficient. So today, we're not merely attendees in the webinar, but explorers embarking on a journey through the digital realms of software and game development. We'll discuss the structured methodologies of the software development lifecycle and dive into the vibrant and imaginative world of game development. Our exploration aims to unveil the tapestry where those two realms connect, where the structured meets the creative and where the logic blends with imagination. As we embark on this journey together, we'll explore how methodologies which have been time-tested, proven in the software engineering realm can be beautifully melded into the game development process, creating pipelines that are not only efficient and reliable, but conducive to fostering creativity and innovation. The software development lifecycle, or SDLC for short, has long stood a pillar in the software engineering domain, providing a structured and systematic approach to developing software that is robust, reliable, and user-centric. It is not merely a methodology, but a guiding philosophy that prioritizes quality, user experience, and systematic progression through the stages of planning, analysis, design, development, testing, and deployment. The essence of SDLC is not just in its structured approach, but also in the principles and philosophies that it embodies. Consider the shift left mindset, a philosophy that advocates for integrating and testing early and throughout the development process. It's a principle that ensures that quality is not a destination, but a constant companion throughout the development journey. The steps of the SDLC are planning, analysis, design, development, testing, implementation, and maintenance. It provides developers with clear goal descriptions, ensuring objectives and deliverables are not just understood, but embedded in every phase, mitigating the risk of squandering time and resources. With a testing process embedded before merging into the broader source code, it ensures that software is not merely functional, but clearly commented and reviewed. The clear sequential progression through each stage, requiring peer sign-off, ensures rigorous adherence to quality and milestones. The well-architected documentation provides a safeguard, ensuring team member transitions do not derail the project, offering a continuity and consistency in development even amongst team changes. That old hit by the bus factor. The iterative nature of SDLC, with the stage capable of feeding back into its previous step, facilitates continuous improvements, the CI and the CD, refinement of the project, and moving the needle on what product manager intends to deliver, and that CD part, continuous delivery. Moreover, the comprehensive documentation and structured guidelines ensures that no single team member becomes the linchpin, safeguarding the project against timeline disruptions in the face of personnel changes, sustaining a stable and robust journey. It sounds really complicated and boring, but it's actually a really fast iterative process. So the overview of the game development process. So transitioning into the realm of game development, our path takes a distinctive twist, venturing into territories where creativity, imagination, and experimental design come to the forefront. Here, the process, while embodying a structural resemblance to the SDLC, emits vibrant creativity, artistic expression, and a focus on crafting immersive and engaging player experiences. Game engines like Unity or Unreal Engine are powerhouses in the game development industry. Here becomes our main toolset, enabling developers to create, innovate, and bring life to the world's adventures and experiences that were once confined to the realms of imagination. The engine is not merely a tool, but a conduit through which ideas are transformed into interactive experiences, crafting worlds players can explore, interact, and be immersed in, or just chilling on the couch and zoning out. Concept art is generated, given the scope of world building. Technical artists then generate those art assets, usually in DCC tools, digital content creation, tools like Maya, Houdini, or Blender. Those assets are then stored in a source control system, like Perforce's Helix Core. Unreal game developers then import those assets, manipulate them, create the textures, the materials, the substances, creating the skeletons. Game builds are then generated and distributed to QA testers for thorough playthroughs. After signing off on the gameplay mechanic, level design, or art style, the build is promoted and then built for various platforms like Xbox, PlayStation, or the Switch. This building is not like traditional software, as it requires many heavy-duty build servers, either on-prem or in the cloud. So with the SDLC, there's kind of 7 straight stages. In the game development process, you kind of have 3 main pillars: pre-production, production, and post-production. So as we stand at the crossroads of the SDLC and game development, we witness a landscape where similarities and differences cross over, but are aligned. With both processes, they traverse the stages of planning, design, development, testing. The focus and approach and outcomes diverge, crafting unique pathways through the end-to-end deployment of that artifact. Artifact in software could either be a zip file with a couple source files, or in game development, it's a large executable application that gets burnt to a DVD. In the traditional software development, utilization of Git in a branching model like Git flow orchestrates the development, ensuring features and fixes are isolated, structured, and systematically integrated. Small branches are created to isolate those fixes, usually in text files or small images, making the merge backend quite easy. In contrast, game development with Helix Core navigates content through the streams branching, creating a visual and structured progression of those changes, ensuring builds are not merely structured, but stabilized in quality as they ascend through that development stream up to mainline, through the testing streams, integration streams, and then landing into a release stream. So depending on your team's project's complexity, you might use tools like Unreal Game Sync to help move binaries between Helix Core and maybe an artist's workstation. Since Helix Core is centralized, we rely on one central location to handle who has access to what, allowing tighter restrictions on files, folders, and file types. Let's dive into what that means in the next slide. The required role of source control. Source control emerges as a linchpin in the development journey, acting as that constant throughout that pipeline that ensures stability, reliability, and collaboration through both software and game development. Doesn't matter what you're creating. When we dive into Perforce, we're not merely exploring a tool, but adopting a philosophy where version control is seamlessly integrated in the development environment, enabling real-time collaboration and providing consistent processes of the project at every stage of the pipeline or workflow. Envision the landscape of a game development project. The combination of assets, code bases, binaries, documentations, and versions could easily cascade into chaos without a structured, centralized version control system like Helix Core. I've seen game files being sent over email and Dropbox and Google Drive, so it's all over the place. It becomes then the beacon guiding development process that every asset is tracked, managed, and controlled, safeguarding the integrity and consistency of the project. In a traditional Git project, the marking materials, documentations, or other microservices like authentication or leaderboards and the binaries and artifacts are not usually stored within the same repository or depot on the Helix Core side. So Git was initially built for source code, but game developers are trying to make that work with large non-mergeable binaries. Helix Core can keep all of those files in one location for easy access. Let's dive into Helix Core a bit more. And in this picture here, we're showing that since Helix Core is centralized, all of the different types of scale on the global forefront, proxies, edges, replicas, they're all kind of pointing back to one master location. So you can control the flow of data in and out. So as we navigate through the development, source control with Perforce becomes our anchor, providing stability, consistency, and structured management of all of our project assets. Picture the combination of assets, code snippets, and documentation that intertwine to form the tapestry of our game. Helix Core becomes the custodian of that tapestry, ensuring that every weave, every thread, every color remains consistent, traceable, and systematically managed. Tools like Handsoft, which is our project management software, can also assist in the planning of those resources as well. Who wants to check in what and where and when, how? Perforce doesn't merely manage our assets, it facilitates the collaborative harmony among the development team, ensuring that every member can contribute, modify, review, and collaborate while maintaining the integrity and consistency of the project. It's like a symphony where every musician, every instrument, and every note contributes to a harmonious melody, orchestrated and guided by Helix Core, ensuring the melody remains harmonious, synchronized, and true to its intended composition. Helix Core is designed to manage and track assets and project files, ensuring optimal coordination among development teams. It provides centralized management of all digital assets and source code, allowing developers to work on files concurrently by locking files that are checked out, which prevents conflicts and overwrites. As I mentioned earlier, there's not really easy way to merge binary files. So that in order to control that flow of features coming in and out, artists and users can actually check in, lock a file, work on that file, prevent other people from checking files in, which would overwrite, and then check that file back in, following that kind of process. Helix Core facilitates parallel development, code isolation, ensuring various code lines and versions coexist without interference. With capacities to handle large binary assets and files, it's particularly pertinent in game development, where managing large versions of asset files is crucial. There is no file size cap in Helix Core. We don't charge on files or storage uses. Furthermore, Helix Core integrates with CI/CD pipelines and various plugins, such as those for JetBrains GameDev IDE's Writer, JetBrains Build System, TeamCity, Unreal Engine, Unity, and other game engines, enabling seamless, automated, and consistent development workflow. This enables teams to manage changes, control versions, and ensure integrity and reliability of the end product. So in that SDLC, we have planning phases, and in this case, concept phases for the game development. So embarking on the planning and concept stage, we set sail into the ocean of creativity and strategic thinking. It is here the seeds of our project are sown, where ideas take the initial steps becoming reality. In this stage, it's imperative that we dive deeper into defining our project's scope, carving out clear objectives and giving shape to our initial concepts through mock-ups, storyboards, and prototypes. Imagine the genesis of a game, an idea, initial sketches of characters, gameplay design, and the conception of worlds yet to be explored by future players. The concepts of worlds, characters, and adventures begin to take shape, providing a tangible form of ideas and creativity that will become our game. At this phase, the importance of detailed planning, clear documentation, and establishing coherent, feasible timelines cannot be overstated. It becomes our roadmap, guiding us through the stages of development, ensuring journey is structured and aligned with our objectives. To manage these projects and schedules, teams usually adopt a waterfall or agile planning style. The usual software development tool becomes Atlassian's Jira or Monday or Handsoft, which also has its pros and cons. In the game development pipeline, it's traditionally a waterfall style, where the game design document, the GDD, is referenced continuously, and schedules are planned out with tasks broken down possibly to hour, where software usually defines tasks as bugs or features, epics, or mountains. Game development's tasks are usually an asset completion, like adding light to a level, or an asset's material that's finalized. Since video games have a stronger deadline than software, as they need to be packaged, built, and deployed, timelines and task management becomes paramount. So in our analysis in the pre-production phases, we transition to the pre-production stage. The roadmap unfurls further. The emphasis pivots towards detailed feasibility analysis, risk assessment, with a sharp focus on finalizing games design before building, gameplay mechanics, and asset requirements. It's a phase where the abstract begins to take a more defined shape, where envisioned worlds start becoming structured entities, and where ideas are starting to be scrutinized for feasibility, risk, and aligned with objectives. Imagine those crafted characters, designed worlds, and the intended adventures. Now we analyze them through the lens of technical feasibility, user engagement, and development pragmatism. Every character design, game mechanic is dissected, analyzed, validated against the project's scope and timeline, ensuring that we progress further. Our development means aligned, feasible, and true to the concept. Both software and game development pipelines are closely matched here, as planning is paramount. In software, usually an iterative approach works to improve the software to test out new features. It has a tight build test iteration. Game developers and artists will usually create a new project to focus on prototyping out an innovative game mechanic. Since Helix Core can have many depots or repositories in Git language, so depots, that prototype mechanic can live in its own depot away from the main game. It can work in isolation. A benefit to using Helix Core streams is that you can easily import your shared game engine, so you can ensure the mechanic will work when integrating into the mainline stream. I'll go into streams in a little bit, but you can carry code over, import, and we can reference other projects similar in game development as software. Entering into the design and development phases of our process, our concepts begin to team with life, right? The characters, adventures, the worlds, once confined to sketches, concept art, and documentation, begin to materialize, become entities that move, interact, engage with the player. Unreal Engine plays a pivotal role here, providing a platform where core characters, stories, and worlds become tangible and interactive. The live editing view is practically required here to view your changes. This is similar to using JetBrains Writer to easily code and compile a project. When Unreal Engine assets and Writer code are submitted to Helix Core, a new build can be triggered using our APIs and SDKs to provide testers with working with a tangible build. In this domain, code becomes the lifeblood of our project, where efficient, scalable, maintainable code is not a requirement, but a necessity. JetBrains Writer emerges as a valuable companion, offering a platform for efficient coding, debugging, profiling, and ensuring the code base is not merely functional, but optimized, robust, and reliable. Linting tools, in-editor tools, external commands allow engineers to develop and stay focused within their tools to prevent time lost and increase productivity. At the end of the day, you'll need to put your head down and code, develop, put those headphones on, lo-fi girl, and you can create beautiful art, well-written code, or the best damn test suite possible. Need to put in those hours, got to grind it out. In order to improve velocity, reduce tedious hours, Helix Core has several integrations to assist and make your life easier. And I'm going to press play on an example. What I have set up here is a P4V, which is our client-side application. I have JetBrains Writer open with my example project, and we have some code, Luke C++ file, and I'm going to kind of take you through the Perforce integration with JetBrains Writer. So I'm going to press play on here. That should work well here. Great. So we have a right click, we have Perforce connected. We're going to edit that file. We're going to make in a really important comment. We're going to save that file. And then we're going to notice how on the pending change list, we have a file on the default change list. So what we're going to do is we're going to try to view that change list. We can make some options here. We can do a difference of the file. So within the tool, you can right click and say compare changes. Great, those are the new changes. That's the code view. We can close that, and then we're going to update the change list description. We're going to make an important change. And notice the hashtag here. We have the skip CI button. Press submit. And now we've got a submitted file. One of the important things about that hashtag was that is an extension that we added to kind of ignore spitting out a build, so that if it's a README change or a documentation change, you don't have to run a full CI build on it. You can kind of skip CI. So and that was the source code view. So this is the integration of Perforce and Helix Core to make things a little easier. So we've got our Goomba in a Mario type level. We've got Perforce connected to Helix Core. I've already set that one up. And you can right click and say check out. So we've checked out the file using Unreal's integration. We have modified a blueprint on the event tick. We will save that, and we'll go back to view the changes. We've that by default, the files go into the default change list. So we're going to do another submit similar to P4V, but this time we're in Unreal Engine. We're going to move Blueprint, and we're going to run a TeamCity build on this. So a hashtag TeamCity. So we've included that as part of our process, submitting that change list and staying in editor. So really kind of automatically kicking off CI, staying in that build, running through that kind of SDLC process, but in the concept of game development. So in this case, what I was just working on was on the development stream. So right in that kind of middle of your screen. So I was working on the development stream and working on let's say a new feature, making Goomba move around. And as kind of code gets merged in, you can visually see how that code flows through your application. As I mentioned, as the SDLC, you kind of shift left. You want to test early. So we're going to be running more tests, faster tests on that development stream using TeamCity. As that code gets more solidified, we're going to promote that content into mainline. And then that's where it merges with other folks' code bases. And then if we're ready to make a deploy, we can actually promote that from mainline into staging. So this is an example. We also have a stream on the right for Unreal Engine. We're referencing the Unreal Engine build in this case, or we're just doing it as an import. And that's a whole different talk. Stay tuned for Unreal Engine training. So we have quite a few integrations, APIs, SDKs. Our software has been around since 1996, give or take. So we've got 30 years of integrations, and a lot of them are open source now. So we can please comment, review. We love Git, we love GitHub. So that's on our GitHub page. It's community driven. We roll those features into our products as well. So as we dive into integrations, SDKs, and plugins, we explore Perforce seamlessly integrates with enhancing and expanding the capabilities of the development environment. Integrations like Helix Core API for various languages and plugins for IDEs serve as bridges connecting our projects to a large number of tools, platforms, and environments, enabling a seamless and efficient development workflow. From triggers to extensions to SDKs, you can create anything the team needs to improve developer velocity. I've heard of customers actually replacing P4V with our APIs and SDKs so that they can control the artist's flow in the artist workstation. Consider Helix Core for Visual Studio or JetBrains Rider, which facilitates the seamless interaction between the IDE and Helix Core, but enhances development environment, providing additional functionalities, tools, and capabilities, like I mentioned earlier with that pre-commit hook, development, testing, and deployment processes. It's like having a toolkit that constantly expands to enhance our development journey. A lot of these, if not, are open source on our GitHub page. So please feel free to use, modify, fork, and open pull requests. We'll be happy for any contributions. An example of this is our P4 EXP plugin, which if you look at the context window, it has the Helix Core option, and then you can edit that file. You can check that file in, so you can kind of stay within Windows Explorer. We have all those options as well. So continuing down that SDLC pipeline, we've really kind of focusing on that our game is functional, stable, and performant, but also provides a fun, reliable, and engaging user experience. Here, the concept of shift left testing, which involves integration testing early and often, becomes pivotal, ensuring that quality is embedded throughout the development process. It's not merely a final stage before deployment. Shift left essentially means that you're shifting your tests from the end of the pipeline to early in the process. Essentially fail faster. If you want to see the problems and see the errors before it's spent building on expensive hardware. So instead of running tests on a staging or release build, you're running tests as part of a continuous integration and delivery workflow. In software, an example would be to run a pre-commit hook to run your JUnit or RSpec tests. In the realm of game development, testing covers more than functionality and logic. Venture into user experience, engagement, immersion. Can you walk through walls? Things like that. Automated testing ensures logical and functional stability, while manual testing ensures that the game provides an engaging, immersive, and seamless user experience. It's a balance between how to run tests on a pre-commit hook, code submissions, stream promotions, or final build deliveries to a build tester. For software, you start with unit testing, a fundamental practice where the smallest conceivable parts of an application, such as functions and procedures, are code reviewed, examined in a collaborative environment, ensuring their optimal functionality, enabling early detection and resolution of those issues. The progress goes into integration testing, which pivots on combining grouped units with other services that will combine to make it a more complex project. This path extends into system testing, which is a holistic examination of the entire software's functionality across all scenarios. As you progress through that pipeline, you add more complexity, more services, and more end state testing. For game development, embracing the iterative mindset, developers engage in continuous testing throughout the development cycle, pinpointing and addressing issues in real time, and paving the way for refinements based on feedback loops. The goal of user testing comes into play here. So user acceptance tests, UATs for short, where every facet of the game mechanics, design, art, and player interaction is critically assessed, not to just guarantee usability, but engaging immersive player journey. Compatibility testing takes center stage here to ensure the game performs seamlessly across multiple platforms and multiple devices, getting any hardware hiccups and safeguarding a consistent player experience. Then we dive into performance testing, evaluating the game's test speed, reliability, and resource utilization under varied conditions, ensuring that it not only functions smoothly under peak loads, but also remains stable enough to avoid potential disruptions like latencies, crashes, thus making the gamer happy, which is always a good goal. So one of the examples that we have on our GitHub page is a P4 action. And so you can kind of connect GitHub to Helix Core using GitHub Actions. And in this case, we have a example CI/CD run from our developer, Andy. And that is running integration tests on a code submit that run on small GitHub Action runners that will run your code with a kind of pre-set up environment and respond back with successes and failures. In this case, it's testing Windows, Ubuntu, and Mac. And it's lightweight. It tests kind of code, Node, C++, possibly C++. That's a little different because of the make environment with a Linux machine gets a little more involved. On the game development side, TeamCity has been fantastic to use for myself. So one of the things earlier I mentioned, we did a hashtag with the blueprint, right? So moving the blueprint around on the Goomba. I added a hashtag of TeamCity. So in my build script on TeamCity, I was able to make a regular expression that parses for the changeless description. And whenever I see that changeless description, I will read it and run a build. And so in this case, there's 3 changes ready to be built. And as they were kind of queued up as well to take that on. So that's an integration on the TeamCity side, but that can also add ones to our code review tool, like Helix Swarm. We have that code review tool. We have hashtags and integrations into that. So we can say maybe hashtag review. Maybe on code submission, it generates a new code review on our Helix Swarm product. So it depends on who your team is, how your team is makeup is it mostly artists? Is it mostly developers? Is it a combination of both? So we have all the tools that you need for both sides of that process. So going down that SDLC, we're getting close to the end here on building that project, right? So stepping into that realm of building the project, our focus sharpens on compiling game assets, code, and resources into build versions, intricately crafting platform-specific builds aimed at targeting game deployments. The build force transforms our code from assets and code into individual components into a unified, interactive, and engaging game, ready to be explored and tested. The diverse, complex, numerous assets, code snippets, resources that have been developed or built using workers across workstations, both in and out of the cloud, across various systems and flavors of operating system, Linux, Windows, etc. So that building process becomes a crucible where diverse elements are melded together, forming an interactive build. As TeamCity, as previously shown, emerges as that pivotal tool, automating that build process, ensuring consistency and transformation from a functional build that's consistent and reliable. And I wanted to take a quick second on Tom's 10-minute test. That was a really fun test that I've learned earlier in my software. There's the smoke test and UAT test, but Tom's second test does the application, or in this case game, do all the bare minimum things to make sure that that end-to-end process provides happiness for that gamer or that user, right? Can they sign up? Can they create a widget? Can they move that widget? Can they play, interact? Is that kind of 10-minute test of manually testing this out? Does it pass that test? And I've kind of used that throughout for my career as well. And so here's kind of a configuration where we said to that really important change with that Luke C++ file, and it was to skip CI. We didn't need to build it, so it was kind of in this. And we can talk. I think there's another talk by Daniel. We could talk all day about TeamCity build configurations, but that's not for this talk. So great. We're getting close here. So upon reaching the deployment and release processes, our journey nears its culmination, the final game build, having thoroughly developed, tested, and built, now prepares for launch. Development on this is a stage where our game, once confined to just the environment, an idea, a sketch, is released into the world, ready to be installed, experienced, and explored by players across the globe. Consider the various platforms, environments, and user bases our game will be released to. The deployment process must ensure that the game is not only accessible, but provides seamless, error-free installations and gameplay experiences across environments. Concurrently, the release processes encompass not only distribution of the game, but also the execution of marketing strategies, user communications, post-release support, implementations, leaderboards, anything external, authorization, ensuring the game is not only played, but experienced, enjoyed, and celebrated amongst the gaming community. Great. So your build was successful. What does that mean? It's not merely an achievement of getting a build through, but it's a testament to the structured, meticulous, and development process following the SDLC. Here we witnessed an amalgamation of structured version control, efficient project management, integrated development environments, automated buildings, testing, seamless asset integration, and dedicated post-release support, converging to make a great game that's not merely a product, but an experience. Reflecting on our journey, we've observed how the implementation of a centralized version control system like Perforce Helix Core, the utilization of JetBrains Rider for efficient coding and debugging, the establishment of automated build processes with JetBrains TeamCity, and Unreal Engine to create that experience, all converge to facilitate a development process that's structured, efficient, and quality-centric, using software methodologies that not only improve your game, but your velocity, reduced cost, security, and increase customer happiness. So, arriving at our summary, we've contemplated the journey we've taken today, exploring the myriad of facets of software engineering and game development, weaving through the structured pathways of the SDLC, navigating through the dynamic and creative realms of game development. Our exploration enriched with insights, methodologies, and tools unveils a tapestry where structured methodologies and creative innovations coalesce, crafting a development pipeline that's both structured and innovative. Our journey has revealed how structured methodologies, principles, and tools such as Helix Core, Unreal Engine, and JetBrains can seamlessly integrate into the development process. It enhances reliability, quality, and development process. The final game is not merely a product, but experiences. We have quite a few options for our tools and resources to get learning more. We have 5 free users as part of our default install. We've got Handsoft, which is a project management tool, Helix Swarm, which is a code review and collaboration tool, We've got Helix Dam, which I didn't mention very much. It's kind of that asset review. So Helix Swarm for code review and Helix Dam for asset reviews. Can you see the assets, comment on the assets, go back and forth and track those assets? And we have a relatively new Perforce YouTube channel where we're adding relative new content through how to set up a workspace, how to set up a depot, how to add users, how to create a stream, how to kind of do anything. So we're trying to be that centralized Perforce. So we also did a game dev report and kind of what are some interesting statistics about Unity versus Unreal, on-prem versus cloud, Maya versus Houdini. So it's really interesting to take a look at that. So thank you very much. I can be reached on my email below and on LinkedIn. So I wanted to say thank you, and I really appreciate your time today talking about game development.
Yeah, that was a really, really cool talk. I think the thing I took away from your talk was, you showed us what Perforce can do and what Helix Core can do, and you talked about the technology part of it, but it was really about people, right? You're working in a team, you're trying to facilitate that collaboration that's really important to kind of getting your games out there and feeling confident in them. So these tools are really about bringing people together. And I think that was like a really strong message throughout your entire talk. And I really appreciated that.
And I'm glad that came through. And that's really important. So I remember in 2014, I was working on a DevOps process, and I was just really making it really efficient, efficient. It was fantastic. But I went too fast, and it sounds a little, opposite. Why going fast is great, but the culture wasn't ready for it, right? I did too much too fast, and the team could not catch up on the processes, right? Code meeting 2 thumbs up on a code review, or this person needs to look at it, or how fast does code get into the pipeline? So I think understanding that culture is at a certain size company, culture is the hardest thing to change. Technology is easy to change.
Yeah, absolutely. It's funny because from just development in general and user bases in general, people can only absorb so much change and so much like feature sets, right? Like you can release a game with 1 million features, but if folks can't literally absorb that much, your game's probably not going to be successful, right? Whereas like your simple casual games can really hit with an audience because they just have such a small absorbable surface area. And I think the same is true for like development processes and just humans in general. So I think you make like an excellent point. I 100% agree with you.
That's great. Absolutely.
Fedor, do you have a question for Ryan?
Yeah, we have a question from Yanni, I think, and he said that I don't think that waterfall model has been a method for a long time, at least not in the mobile space. I haven't heard AAA studios would use waterfall either or opinions. And so is there a common style of project management to see your customers using more?
Sure. And one of those things is that we help create the tools. And so people sometimes come to us for how to build a video game, right? So we're a DevOps company, and don't get me wrong, I love helping them and jumping in. But sometimes we don't have a lot of insight into that. But I do know from personal experience that Call of Duty comes out every year, right?
Yeah.
Call of Duty comes out every year. So there is a deadline, there is a date, right? So there is a time based. So it says, okay, well, if you need to deliver on December 1st, if you walk back, it takes a month to develop the build process and testing, and it takes this long. So there are waterfall methods because there is a deadline sometimes to get investor money, right? So in order to ship a prototype or a first pass of your mobile game, there is a deliverable that you need to work towards, a deadline. And that's that crunch factor where sometimes when they set those deadlines so far in advance that they can't hit those, and then they realize, oh, we're behind because we didn't use the proper planning tools, and that we overestimated, underestimated, didn't plan. So it would say waterfall, is not really common in the software development industry anymore. It's still relevant. It's still relevant when you have big trains that need to move and you have kind of big things that need to deliver. On small mobile games, probably not. you kind of iterative, you kind of work agile, work in smaller deliverables, maybe weekly, bi-weekly deliverables. So AAAs, you start running into marketing, and release dates. And so I'm still waiting for Black Flag to come out.
Yeah, I'd love a pirate game
Yeah.
around now. So, one of the other things, I think Tiago said this, they felt like stream graphs were really, really important, especially for small and medium-sized devs. Does Perforce have any kind of documentation, video tutorials, or anything like that around really mastering stream graphs?
Sure. And stream graphs here is a feature of Helix Core, right? And so mastering stream graphs is a double-edged sword, right? So you can master the technology, but how do you master and kind of incorporate our technologies into your pipeline, right? Into your game dev process. So I've seen teams that just use one mainline, right? Everybody kind of merges in and out, and they kind of use checkouts and locks further if they're flowing traffic. Some companies use a 3-step, kind of that what I showed earlier: the development, the mainline, the release. Epic does it. Epic Games does it a different way, right? Other big AAA games do it differently. I was at Unreal Fest last week, and I talked to one game studio, and they are on their 5th version of the stream graph, right? And they've showed us kind of 5 different versions of what that stream graph is. So it really will depend on how your game build process works, how you import engines, how do you kind of work through that process. We do have more YouTube videos coming out soon, so please drop me a line, let us know. And one of those things is we're starting to get feedback from our customers. And I made a joke earlier about we don't make games, but people are coming to us saying, how do I make this game? Where do I put my assets? Where do I put my things? So we're starting to take feedback and starting to pull together those ideas and concepts. So please let us know if you found something that works, that doesn't work, if you need assistance. So a lot of us are on the internet web, and we have a support channel as well.
It's funny you make that joke, like you don't build games, but someone in the chat mentioned that you had said Perforce has been around for almost 30 years, and they had asked how many people watching the stream are actually younger than Perforce and the technology that we provide. So don't sell yourself short, because you probably have a lot of institutional knowledge in dealing with a lot of publishers and game developers. So
absolutely, we've learned a couple of things on don't do this, and we have just some basics, right? We got some basics, but maybe we're getting into what does a Unity mobile template look like? What is an Unreal Engine architecture diagram? I use this picture a lot. They're using LED walls, virtual production using Unreal Engine, right? So what is an example virtual production stream setup and depot setup? So we'd love to hear what you're making.
Yeah, if I could ever get an invite to one of those spheres or those LED things, I'd love to go to one of those.
I'm under NDA. I can't help you. Sorry.
Another thing I noticed, especially when you were showing kind of like TeamCity and GitHub Actions, you were running builds on Mac OS, Ubuntu, Windows. So clearly you're everywhere. With kind of the rise of mobile gaming and Steam Deck, which runs on like a Linux variant, are you seeing that cross-platform like builds and targeting is becoming more and more important in the game industry?
Absolutely. We're getting more questions about Unreal Game Sync and sending binaries to developers' workstations, right? And those workstations being of all different sizes. Usually Windows kind of is the most popular environment. But that's kind of the important part, that we store the source code on the Helix Core side, and we enable the triggers. So once that code is promoted outside and sent to that build server, that's kind of in a different world. We work with other partners like Incredibuild as well to help building out those assets, kind of get those assets faster to more machines to build on more devices. So we can help connect the dots for you, but your mileage may vary on that one.
Yeah. Here's another question for you. You know, we're talking about storing code and doing things with Perforce. Clearly, there are teams that maybe start doing their development on Git and trying to use Git LFS and maybe run into issues with that. I was actually talking to a couple of game devs earlier on Mastodon, and they kind of can't use Git. They just find the binary management's just not there. Like, what are some ways for folks who are maybe stuck on Git and maybe not liking that experience? How can they transition their projects over to, say, Helix Core?
Yeah, absolutely. And I want to just preface this with we love Git, right? We've got Helix, Helix for Git. We've got graph depots. We got integrations between both. So we have partnerships with GitHub. So there are file size limits. Just fundamentally, you know, it's a decentralized model, right? So Git on the basis is decentralized. You make a copy of a repo and you make the entire copy. So you're making a copy of the game. Some of these AAA games studios, you can't make a copy. It just won't fit on your hard drive, right? So how do you kind of limit what the artist gets to work on? Like if you're working on a tree, a rock, you know, Captain America's shield, right? So you're not pulling the entire project. You're only mapping your content to what you need to work on. If you were in the Git world, you take everything. Right. And so one of the things, we don't have any file size limitations, or we don't have any, we don't license based on infrastructure. So it's a user base, right? Seat based licensing. So I've been in the Git world for a long time, and Git submodules is really difficult. I always used to screw it up, right? So so we have a thing called stream components. We have that kind of concept, but I would say start looking, investigating. We have a free license, free for 5 to play with it. We've got options across all clouds. We've got Amazon, Microsoft Azure. We've got Google Cloud and DigitalOcean to get started quickly.
Yeah, and I guess kind of a follow-up question, you know, like, you know, you can obviously host this stuff on premises, but that comes with like a lot of individuals who have to manage that. You know, like, sometimes you just don't have the resources or the spend to kind of bring in those experts. Is there kind of a hosted model for any of this, any of the things that Perforce offers?
Yeah, and that's kind of one of my main objectives, is to make it across all clouds, make it really easy to use, and in the environment that you are, right? So I had during early COVID, I had a customer call us up and said, "Hey, I'm working on this new sci-fi show. I'm the most technical person here, but I need Perforce, and I don't know what it is. I just need it. I don't know how to run it." And so we started kind of building lots of different options. So we have options for technical artists, ITs, developers, etc. So we've got the Enhanced Studio Pack, which is kind of a best practices cloud formation and Azure ARM templates that'll run infrastructure on your cloud. We've got partners like Assembler to help host them Perforce on their cloud. Kind of a managed service. We've got Helix Remote Admin, which is a white glove service where we will maintain your cloud environment. And then the fun part is we do have a SaaS coming, and it is I can't say the release date yet, but it is coming. We announced it in partnership earlier in the year with Microsoft. So.
Oh, very cool. You said sci-fi show. I'm guessing you're under NDA. You can't tell me anything about that.
Well, I can just say it's Star Trek. I can't tell you anything else.
Oh, okay. All right. That's really cool.
Yeah.
Very, very cool. Fedor, do you have anything else that folks are asking? I see people are asking for my Mastodon handle. I'll put that in chat. That's not really a question for our guests here,
but I don't think that we have any question left.
Oh, okay. Yeah, I mean, again, this was a great talk. Like, the fact is, when you work in teams and you work with tools are really supposed to facilitate the connection between the humans that are there, right? I guess a final question for you, since we're talking about that, and maybe we can end on this. It's like, you know, you start on a small team and a small project, you gain some success. Like, is Perforce something that can kind of grow with you over time? And have you seen that happen to studios that you've worked with?
Absolutely. It's almost it's a knock on wood, but it's a daily occurrence, right? So we had a customer not in the Git environment, but using an SVN, and it was an older project, and they were working on it. I think it was about 4 or 5 people working on this project. We were talking to them. They were hitting some file size limits and kind of some growing pains because you have to script it, right? You have to script, you have to code around limitations. So get LFS and submodules and things like that. So we don't have to worry about anything where ours works out of the box. But what happened was that the game prototype went out on Steam, and it was a fantastic hit. It was a fantastic hit. And I have to double check this number, so don't quote me on it. I think they got 100 million in funding or something ridiculous, and to build out this game. And they said, okay, now I have to build it for real. And I know that what I have today doesn't scale. And that we set up our infrastructure and our examples with the hope that the game will succeed, right? So the only thing you have to do is just add more licenses. So there's no changes. Maybe you add some proxies or replicas across the globe, but those are additive, right? Those aren't changing the way you do game development.
Yeah, and what you described is like every game dev's like dream, right? Like you spend years building this thing, like just sacrificing, putting your energy into it, and you release it, and it's like a mega hit, right? So it's a great problem to have. I think any game dev would welcome that kind of problem. So that's awesome. So yeah, on that note, Ryan, this was a fantastic talk. I loved it. Made me think a lot. Yeah, we really appreciate your time. Anything else you want to maybe kind of remind people where to go to get more Perforce stuff or learn a little bit more? Now's your opportunity.
Yeah, we've got training, Perforce U. It's a kind of a college online course for virtual production, which kind of uses game engines for M&E and the VFX industries. We also have adding more and more content to our YouTube channel. So hit us up with suggestions. I'm floating around Discords, plural, on there. And so, and if you think we need a Perforce branded Discord, let me know. Hit me up in the comments. Smash that like button.
Yeah, that's the life of a YouTuber. You have
to throw it out there. I had to throw it. Smash that like. I had to throw it out there.
Well, again, thank you so much, Ryan. This was a fantastic talk.
Awesome.
We'd love to have you back. Yeah,
sounds great. Happy to be here. Thanks, folks.
Bye.
Thank you.
Yeah, Fade, what do you think? That was a great talk, right?
Impressive.
Yes, that's an excellent word.
Yeah. I think that we still have some .ultimate licensing to ruffle, maybe, and maybe just have a little rest and rethink what we just learned about the Perforce.
Okay, all right. Do you have a question that you think the audience would be interested in answering?
Yeah,
Well, I was going to say, before you ask it, let's remind people, if you're in YouTube chat, we're going to ask the question. The first person who responds with the correct answer wins a license. So, Fedor, go ahead.
Yeah, it will be just a simple one, I hope. What is JetBrains company slogan?
Oh, what is the JetBrains company slogan? I might be a bad JetBrains employee. I don't actually know what our current slogan is. Oh no.
It's been for a while.
Yeah.
Actually.
If you get this correct, you get to have my job. I think that's how this works. What is the answer? I don't know. Somebody help me here, please.
I'll help you.
Ooh, I don't know. You do know it, right, Fedor? You're not just okay.
Yeah, I think that we already have a right answer.
Okay. I mean, people keep guessing.
But other variants are quite nice also. We got you.
Yeah, like who knows? You might actually come up with our next slogan. So just keep putting things out there, and we'll see if you're part of our marketing team next week. Ooh, I like be calm and debug. Oh, that's a good one. I don't think that's correct, but I like that one coming from our chat.
Yeah, so I think that there are many right answers, and it is the drive to develop.
Okay, drive to develop. I knew that was one of them. I know we sometimes switch them around a little bit, but develop with pleasure was one from a long time ago as well. So I remember that. So
yeah, but afterwards there were some kind of rebranding of the whole JetBrains team. Yeah, so I think that the winner is Nathaniel Alcala. So I think it was the first correct answer.
Okay. Yeah, feel free to email us. I think we'll put the email in the chat, right?
Afterwards. Yep.
Okay, cool.
And the next one will be a little bit trickier. What was the first person shooter game to introduce aim the mouse instead of WASD keys?
Oh, wow. That's a good one. So instead of WASD controls, you use the mouse to shoot.
Yeah.
Wow. You know, it's wild.
Actually, I didn't know the answer before this quiz.
It is wild to, you know, if you ever go back and play retro games, it's wild to see how controls evolved over time. Like the analog controllers didn't exist until like the PlayStation ones had them, right? Dreamcast only had one analog controller. So it's kind of fascinating to see how controllers in game dev, like games, have kind of evolved and kind of come to this PlayStation 5, Xbox controller style that we're kind of all familiar with at this point. So,
by the way, what was the first gaming environment that you had?
Oh, that's a good question. You know, I remember playing Tank Wars on Atari, right? Like with the cartridges and the joystick. That was a good game. That caused a lot of fights between me and my siblings because once you figure out that you can just kind of hide behind walls and shoot each other, people got upset. So I think my favorite console though of all time probably was the Genesis, the Sega Genesis, or growing up in the European era, the Sega Mega Drive. People probably know it by that. So Nathaniel seems to be shocked that I played on an Atari. Come on, man, I'm not that old.
I'm the same old as you, man, because the first gaming setup was Atari with these cassettes and something like Missile Command and so on and so on. So.
Oh, I love me some Missile Command. That's such a good game. So yeah, has anyone got the answer right?
Yes, and the correct answer is marathon, actually, and we have I think we have a winner, Janne Huhtanen.
Yeah. Oh, congratulations! That's awesome. Again, we'll put the email in the chat. Feel free to email us, and you folks have won a license. So, very cool, very cool. Yeah, our next speaker has kind of been patiently waiting in the wings here. Fedor, do you want to introduce them? Should I introduce them? I'm a big fan of them, by the way, so I'm super excited.
You're welcome. I'm just writing to our winners.
Yeah, so this next individual, he has his own YouTube channel, Turbo Makes Games. I've watched a couple of his videos. I really like his zombie themes. I'm really, really excited to introduce him. And he's going to be talking about data-oriented design in Unity. So please give a warm applause. I can't hear it. He probably can't hear it. But the folks in Cyprus can definitely hear it. Give him applause. Let's welcome Johnny Thompson. So,
hello. Thank you so much for the kind introduction. Really appreciate that.
Yeah, I actually went and played some of your games. I think it was on itch.io or something like that. So, yeah. It was really, really fun. So, Yeah, I definitely recommend folks go play them. They're very, very cool games. And yeah, I'm really excited about this talk. I think I saw a little bit of it too on YouTube. You have like another kind of introductionary to data-oriented design. So I'm really excited about this one.
Yeah, definitely. I'm looking forward to it as well.
All right. On that note, Fedor and I will disappear into the background. If you need any help, reach out to us. Let us know. We'll be watching. Folks, if you have any questions, please put it in the chat. We'd love to ask them of our guests here today. And on that note, we're going to disappear.
Wonderful. That sounds great to me. I'll go ahead and rearrange a couple windows here. And I think we are all set to go. Okay, everybody. So today's talk is going to be an introduction to data-oriented design in Unity. So with today's talk, I just kind of wanted to introduce the concepts of data-oriented design and show you a little bit about the development experience of using data-oriented design in Unity. So I'm going to be going over a couple code examples and then just kind of talking from my personal experience of using Unity dots for quite a while. And just kind of give you a little bit of an update about, what the development experience is like if you do decide to use dots in Unity. So anyways, just a quick little introduction on myself. So I'm a Unity developer. I don't work for Unity. I'm, completely independent. I do content creation on my YouTube channel called Turbo Makes Games. Over there, I do a lot of stuff mostly focused on Unity's data-oriented technology stack and their entity component system, a bunch of topics that we'll be talking about today. So I do like tutorials and kind of like news updates if there's any kind of new features coming to that, as well as just making like cool little showcase games to showcase what you can do with the technologies and all that. And because I've kind of been like come to be known within this like niche of Unity's dots, it's been leading me to get some like contracting and consulting type work. So I've been able to work now professionally with a bunch of companies ranging from all different shapes and sizes and stages of development for people who are kind of wanting to add more performance to their game or non-game application, things like that. So anyways, kind of diving into the actual talk here. So what is data-oriented design? So this is kind of the most kind of general way that I could figure about describing what data-oriented design is, where you're basically just making decisions about how to structure the data and transformations in an application that best fit how the computer stores and processes data. So as opposed to something like object-oriented programming, where we're creating these different objects to solve problems, we're really just kind of like focused on the data. How can we most efficiently store that data in the computer and process that in the CPU? So to kind of break down an example implementation of data-oriented design, this is kind of how I approach solving different problems using data-oriented design. The first thing I do is look at the input data. What is the data that we already have? Kind of what's our given data? So again, our input data. After that, we want to look at our output data. What's the actual thing that we're trying to change? So something happens within our game. Also very important to consider the scale of the data. Is this only just like one element of data, or do we have like many of these units of data? Because this is really going to influence, how we structure our data how we structure our data and how, we process that within the CPU. So when we look at actual data transformations, like, how do we actually do this most efficiently based off of, again, our input data, our output data, what the scale of that data is. So these are just kind of like all the factors that we sort of need to consider when we're using data-oriented design. So to give a little bit more of a practical example, let's just say we're going to be moving 1,000 entities within our game world. So here we can just kind of break down, what some of our input data might be here. So of course we'd have, like the current position of our entity. This is going to be in a type of float3. This is very similar to a vector3 if you're just kind of familiar with regular Unity, but a float3 is kind of a, more efficient burst compatible type that they've created. We'll talk about some of these things a little bit later. And of course the scale is going to be 1,000 because we're going to have each entity is going to have its own current position in the world. Next up is our move speed. So we figure that, each of these entities can have their own unique move speed. So maybe some can go a little bit faster, some can go a little bit slower. This is just a regular scalar floating point number. And of course, we have 1,000 of these because we're going to be having one per each entity. Now let's say we have some player input. We want to give the player the ability to actually control all these entities within the world, so they can say, use the joystick to, move around all these entities in the game world. So the type of this is going to be float2. Basically, we just kind of need the XY coordinates of where the joystick is. And the scale of this is only going to be 1 because, in this example, we just have, say, one player controlling all these 1,000 entities. Also, we're going to need delta time. Of course, if we just want to normalize for frame rates, we're just going to have one instance of this delta time here as well. And then looking at the output data. What the thing that we're actually trying to change is going to be the end position, at the end of the frame, where is each entity going to be? Again, this is a type float3, just an XYZ coordinate basically, and we're going to have 1 per each entity in the world. So kind of based off of this input data and output data, we can sort of consider, what our data structure is going to be like. So of course, the player input and delta time, these are just going to be stored as local variables that we can, just use and kind of access from wherever. And then we need to be a little bit more efficient about how we're kind of storing the position and move speed. So we're going to store that in a structure of arrays. By the way, we are going to come back to this example, and I'm going to show you how to actually implement this in code here. Before we do that, I do just want to do a little quick point on SOA, which is structure of arrays. So the whole idea behind structure of arrays is we basically are storing these different data values within tightly packed arrays, but these are kind of like separate arrays. So we have like a separate array for all the position components associated with an entity, and a separate array for all the speed components associated with all the different entities. You will notice that these are essentially parallel arrays, meaning that, say, everything at element 0 of a given array is going to be, we can say, associate that with one entity. So one entity is, say, going to be representative of this element 0, and that first element has the position and speed component associated with that. And then the next element, element 1 in both those arrays, those are going to be associated with a separate entity. So that's kind of how we can sort of keep track of these. Now, the main advantage of structure of arrays, this is something that you're going to see a lot of times in data-oriented design. The main advantage of this comes when we get into like SIMD programming, which is single instruction, multiple data, because it allows us to easily just take, say, the first couple elements of an array, store that into the actual assembly instruction. So we can basically process multiple things in just one single instruction. And that's what really leads to some of these massive performance gains that we can see here. So kind of orienting this discussion a little bit towards Unity Dots, we can talk about what it is. So Dots stands for the Data-Oriented Technology Stack. Basically, it is just a collection of packages based off of data-oriented design principles. So the kind of core package that we see is the entities package. You'll see this also sometimes called ECS. We'll be breaking down these packages in just a moment here. But we also have the C# job system, the burst compiler. There is their own physics, new physics library, and there's also the Havok physics, because they recently kind of partnered with Havok, and you can now do that through Unity Dots. They have a netcode for entities, which is kind of the data-oriented design multiplayer, which has been super nice. And there are more than these things. I do just want to point out that you can use these packages individually. You can kind of, pick and choose and kind of use these in your own, existing projects. But they really work best when you're using as many of them together as you can. They all just kind of like work hand in hand. So going a little bit more into detail on what some of these different packages are. So ECS, this is kind of the core package. I should mention that just kind of ECS as a concept isn't anything specific to Unity. It's kind of, like maybe a design pattern, I guess you could consider it. But Unity does have their own implementation of ECS, which is kind of known as the entities package. So yeah, basically the whole idea with ECS is it's kind of a separation of your data from your game logic. So when you think about ECS, the entity component system, it's not like one thing. It's not like, you know, a system of entity components or something. It's more representative of 3 different things. So we have entities, components, and systems, and these are all kind of separate things. And this leads us to, you know, do some really cool optimizations, as you'll see a little bit later. So an entity is just kind of like a thing in our game world. It really is just kind of like an association of data components, you know, kind of going back to the SOA example. We figure, you know, all the elements at, you know, one particular, or all the data components at one element in an array, you know, we can consider those all associated together. So they're just kind of, an association of data components. And we can be a little bit flexible about how we kind of determine what an entity is. So it can represent one thing, which is probably the most common. But one entity can also represent, say, multiple things, or even just a small part of a larger thing. The only thing that an entity really has is just an index and a version number. And this is just a way to uniquely identify that entity in the game world. So next up, we have components, and these are really important because this is kind of the core, the actual data associated with our entities. The thing about, you know, typically for these components, we wouldn't be using unmanaged data. So these are just, you know, simple types like integers, floating point numbers, Booleans, things of that nature, because we know the, you know, actual like bit size of these particular types. So when we do that, we can basically store this unmanaged data inside what are known as chunks, which are just 16 kilobyte blocks of pre-allocated memory, which allows us to do some kind of more efficiencies that Unity takes care of. It also integrates really easily with the C# job system. You know, normally you can use the C# job system with regular game objects, but you do kind of have to like copy data over to native memory and then, you know, read that data back. So there's a little bit of overhead with that. However, when we are using data components in ECS, it integrates really easy. The data is already stored the exact way it needs to, so it allows us to do pretty easy multi-threading in most cases. Then finally, we get to systems. So these are the actual data transformations. So, you know, taking our input data, doing some processing on that, and converting it to the output data that we want. So this actually, you know, modifies the data to make gameplay happen. By nature of the way that systems are created, basically just, you know, us writing the system code, it'll just automatically, you know, create that system and it'll start running within the game world. So we don't need to do, you know, anything specific to, you know, start it running. It's just going to start running by default. And it's going to run on groups of entities, which are called entity queries, which again, we'll talk a little bit more in detail about later. I do just want to point out that systems by themselves, they are going to run on the main thread. However, they can schedule jobs that will go ahead and run on worker threads. So speaking of jobs, we can talk about the C# job system. So the C# job system, you may have heard of it. It's just a way to achieve multi-threading in Unity. The really nice thing about the C# job system is it really handles all the kind of scheduling and dependency checking. So this is a really important thing with multi-threading. So because, you know, there is always the possibility of a race condition where, you know, maybe we have one thread that's kind of like modifying some bit of data and another thread's trying to like read to that same bit of data. So we don't know if the data had been modified, you know, before or after we're reading it. So we just kind of like need to make sure that, you know, all the jobs are completing at the right time and everything, so that we get, you know, very deterministic results of, you know, when we're reading data, that the, you know, change data is going to be exactly as it's expected. And it's really nice that Unity kind of like handles a lot of that kind of like nitty gritty stuff for us. So we just, you know, don't need to worry about it all too much. So the C# job system is best used for performance-heavy calculations to be completed within a single frame. So I'd say this is a little bit different than, say, like async programming, where we might have, say, some like longer running work kind of running in the background. The C# job system really works best when we're like actually needing to complete some work within one single frame, but we still don't want to be blocking the main thread. Some reasons behind this is because, you know, sometimes when we're working on entity data, we can't always guarantee that, you know, when this job completes, if, you know, we had some kind of input entities, we don't always, you can't always guarantee that that input entity is going to exist once the job actually completes. So it is possible to have jobs go past the frame boundary, but in most cases, we want to be completing these jobs within one single frame here. So next up is the burst compiler. This, again, is another very important one here. The whole idea behind the burst compiler is it basically converts our, our C# code down into native CPU code. We can actually see here, this is the burst inspector, which you can open up inside of Unity. And you can really see the whole disassembly of, what the C# code actually breaks down to. So this is actually a code example that we're going to be looking at a little bit later in the video, where we're kind of moving these player entities through our world. And you can see in purple here, these are basically all the assembly instructions that the CPU is calling. So you see that there are things like vmol ps. So that P stands for packed, which basically means that it's packing multiple elements of data into that one single instruction call. So again, this kind of goes back to the SIMD, the single instruction multiple data. You also see v-add ps. So it's, again, packing multiple bits of data into one single instruction. And we get a lot of really good efficiency gains from this. Now, the burst compiler, there are some kind of like restrictions on when and where we can use it. As long as you fit inside those instructions, in general, the burst compiler is pretty easy to use. You can just kind of like, tag some block of code, say, hey, I want this to be burst compiled. But for more advanced users, you can get like really in depth with it. Again, check out the disassembly, see what things are happening, and see if there's any ways that you can kind of like optimize what the output assembly is. So it is definitely a really excellent thing to have. And I'm sure you may have seen some of the results online about, people using the burst compiler and getting these massive performance gains. So this is kind of how it actually does that. So now I want to transition to talk a little bit about the Dots development experience. So we're going to start with a little bit of a code example. We're just going to go back to the whole thing about, say, moving 1,000 entities, where we can have this input data and output data. So let's kind of get into it here. So we'll start with creating a data component. So the data component that we're going to create here is a move speed data component. There are multiple different types of data component that we use, but we don't need to get into all those right now. This is just kind of the standard data component. You'll see that it is a public struct. We've called this move speed. The important thing that we're doing is we're implementing this iComponent data interface, which basically is just kind of like saying that this is the kind of standard component type that we're using. And you see that the only thing in this is just a public float field called value. The reason that I've called it value here is for, data components where we just have a single field here. I call it value because it makes a lot more sense to say, when we're accessing this data, we can say move speed.value rather than saying like move speed.movespeed. The naming is just kind of a little bit redundant in that case. So yeah, this is basically just a data component. You see it's very simple. We don't have any methods on it or anything. Again, it's just kind of that separation of data from the game logic here. So just to show you kind of like how we might be able to actually set this data in the inspector, what we can do is create an authoring component. Now, an authoring component essentially starts with a regular mono behavior. You'll see that it is public class. We call this player authoring. You see it's inherits from mono behavior. And this basically just allows us to edit this field over in the Unity editor. So you'll see that, if we attach this to a game object, you'll see that we now have the ability to just modify this public field for move speed down here. Now, the important thing is if we have this game object in sort of a subscene, which is going to convert this game object over to an entity. Don't necessarily need to get too deep into that right now, but there's kind of a difference between regular game objects and ECS compatible entities. So this kind of conversion process is known as the baking process. So we have to use a baker to essentially look at the authoring components. And then from there, you see that this kind of last line, what we're doing here is we're saying, add component, we're adding to this new player entity that we've created. we're going to be adding a new move speed. And here we just set the underlying value to authoring.movespeed. So that's how we can kind of, have the ability to set things in the editor and have them reflected on the ECS side. Now, again, because this player authoring component is just a regular mono behavior, we can do, all sorts of, custom inspectors or, editor tooling, anything that we need to with a regular mono behavior, as long as we're just setting kind of that underlying data in our Baker component here. So now once we have our data over on the ECS side, how do we actually process that? So the kind of easiest way to do that is by using what is known as an idiomatic for each. So here's kind of just the general overall setup of a system. I probably don't need to get into this too in depth right now. A couple things that I do want to point out. You'll see that we're running this in onUpdate, which is just, of course, a regular update method. So it's going to be running once every single frame. You'll see that I am burst compiling this method. So basically, all this stuff inside this method is going to be compiled with the burst compiler for the maximum efficiency. So before we even get into the loop, you'll see that I'm just kind of getting my, the single unit data. So I have my delta time as well as getting my player move input, and then just kind of converting that over to a float 3 so we can easily modify the position. But really the important bit is this last bit down here where we have this for each loop. Now you can see that the air quotes collection that we're going to be iterating across is actually an entity query. So we're doing a system API.query to create our entity query. Essentially what this means is we're looking for any entities with a local transform as well as a move speed component. Now we do just kind of need to be careful about how we structure these entity queries, because this is basically going to return us everything in the game world with a local transform and a move speed. So this could be players, this could be enemies, this could be vehicles, just anything that has these particular components, we're going to be returning. Now we can get a little bit more granular with how we create these entity queries, so we can, filter for things that have specific components or are missing other specific components as well. So we can get, a little bit more granular to make sure that we're targeting the actual entities that we want to. Now, this system API.query, again, not only does it create the entity query, but it also gives us access to the data components so we can actually modify them. So you see on the local transform, I have this ref RW. That just means that we're opening up this local transform for write access. Again, this kind of goes back to the whole job dependency checking thing where we need to know what bits of data we're writing to and what bits of data we're just reading from. So the whole job dependency scheduling can make sure that we're, again, not overwriting any particular data or anything like that. But you see that basically we can just access the transform and the move speed via this tuple here. And, the actual work that we're doing is literally just one line here. We're just basically updating the position based off of our input vector multiplied by move speed multiplied by delta time. One other thing that I want to point out with the for each is that in this particular case, this is just running on the main thread. However, again, it is still burst compiled. Now, if we do want to actually multi-thread, this same work, we can create an iJob entity, which is, one way that we can. This is kind of like one way that we can create a job struct, so we can multi-thread some of this different work in Unity. You see that here there are kind of a lot of similarities. We're basically creating a job struct, which is just going to be separate from our system here. We have our public fields for delta time as well as our player's input vector. And then down here in the execute method, this is where we're actually going to be doing the particular work on a per entity basis. So this line of code is essentially going to be running on every entity. The way that we kind of set the default query up in this case is by whatever types we pass into the parameters of this method. Again, looking for everything with a local transform and as well as a move speed. And you see I do have the ref and in keywords. Those are kind of like denoting, again, read and write access for the different data components. Now, us just creating this job struct right here doesn't do anything for us at all. We actually need to schedule this job. So the way we do that is, again, back in a system. You see that this, again, has some very similarities to the first system. Again, we're just getting our delta time, player move input, things of that nature. However, instead of like running that for each loop, we're creating a new player move job, going ahead and passing the values for the fields in there. And then at the end, we can choose how we want to run this job. So we can do a .run, which basically just runs the job immediately on the main thread, or we can do a schedule or schedule parallel if we want to schedule the job onto one worker thread or multiple worker threads. So there's just a quick overview. I just wanted to show you a little bit of kind of the development experience and what some of the actual code looks like. Of course, you don't need to, really memorize all the details right now or anything, but do just kind of want to go over a couple, code observations. So you'll see that there is a clean separation between data and our transformations. So again, our data components are just, separate things. They don't have any, logic inside them. They're just kind of, regular raw data. And then our transformations, you can see that, those are completely separate. They don't have, they're just separate from the data components that we're iterating across. You will notice that there is some boilerplate code. We kind of have to do a decent amount of setup to get to like literally just that one line of code that is, actually updating the, position of these different entities. Because the actual work of the transformations are extremely simple, but there is kind of a lot of setup to kind of get to that point. So that can be one of the things that maybe is a little bit challenging earlier on in development, is the speed at which you can kind of like get something to happen on screen is maybe a little bit slower than just in regular Unity. However, because this is a JetBrains talk, I do just want to give a quick shout out to some of the amazing dots tools that they've added into JetBrains Writer. So you can see when you're adding a new script, there's this new menu option for dots right here. And this pulls up basically another window here where we can essentially create, there's a bunch of templates for the different data components, systems, authoring components. So it really automates a lot of kind of that repetitive code and templatizes it out. And of course, JetBrains Writer is extremely powerful, where you can create your own live templates and file templates. So I have a bunch of those created myself, and that has been a massive, massive time save for me. Just kind of, not writing a bunch of repetitive code. So that is something that has been extremely helpful for me. So I want to talk a little bit about, why I continue to use dots. Of course, performance is the kind of like main concern, main reason that most of my clients kind of come to me in the first place, is because maybe they're creating some application where they're trying to do something a little bit more ambitious, and they're, quickly running into some performance limitations. So I think, performance is kind of like the, almost like the hook, the reason that people start looking into, dots and ECS in the first place. But one reason that is something that's really important to me, one reason that I stick around, is kind of like modularity. So the way, because we have this separation of our data components from our logic and everything like that, it leads to code that is much more maintainable in the long run. We don't have these like nasty web of dependencies where, a bunch of code is all, connected to each other. And then if we try to, rip something out or change something, then a whole bunch of things breaks and a bunch of things fall apart. In my experience, it hasn't been like that as much, where, there have been some times where I need to, recreate some larger portions of the application. And I've been able to fairly easily just kind of, rip those things out and replace them for something newer and better. Because again, there is that kind of like, separation. So, things are, just kind of a lot more modular. You can, pull things out, plug other things in. And it allows you to do some really cool things too. Like, for example, you can have multiple systems that essentially do the same thing, but maybe in different ways. And so you can maybe have like a designer, you can like give a hotkey to a designer that can like literally just like toggle back and forth between these two systems. So they can say, test out maybe multiple implementations of some different movement mechanics, like literally just side by side, just by toggling between the systems, because they're going to be iterating across the same entities. So there's a lot of really cool things that you can do with it on that front. So if you are considering using dots, I do just want to kind of point out a couple things that you should consider. So not everything right now has an ECS compatible equivalent. So, you will be needing to essentially create a bridge between some of the things on the ECS side with things on the mono behavior side. UI is kind of a big one of these, as well as animations. There are some animation solutions from third parties right now. But, if you want to do it just kind of all through Unity, you are going to have to kind of, bridge the gap a little bit there. So there are separate physics systems. So if you are using the dots physics system, it's not going to interact with the regular Unity's physics system. The main place that I've kind of noticed this to be a little bit of an issue is with the XRI, the XR interaction toolkit, because that is all based off of the regular physics system. So if you are kind of using the dots physics system side by side with the XRI and the regular Unity physics system, you're going to have to again kind of do some things to make sure that things stay in sync, and you have to kind of manage two physics worlds at this point. So a little bit of things in there. It is still a bit buggy in the Unity editor. So when you click on things, or it can be kind of difficult to inspect the correct entity that you want. And they're just kind of little things where if you're editing a field and you hit tab, it doesn't always go to the next field. So it's there's just kind of some little kind of buggy things that they're still kind of working through at this point. Also, a major consideration is that the pool of developers to hire from are going to be a lot smaller than just kind of regular Unity. So it's kind of hard to expect somebody to have dots and ECS experience. So just kind of consider, if you are using dots, they most likely are going to have to learn on the job. And then the last thing that I do just want to point out in the talk here is just kind of some learning resources for learning dots. So again, if you are kind of building up a team and wanting to point to some different resources, here's some good ways to do it. Real quick though, I do just want to say that if you are going into learning dots, you really need to have a good fundamental understanding about how computers work. Because again, if we're going to be optimizing for how the computer best stores and processes that data, it's really important to understand that at a good fundamental level. So you kind of know, you kind of have an end goal of the optimizations that you need to make. So, if you don't really have that understanding, it can be a little bit harder to see maybe some of the benefits of, why we're, going through a little bit of this extra trouble to, get a little bit more performance here. After that, you're going to need to learn some data-oriented design principles, which can be a little bit of a shift from an object-oriented programming mindset that a lot of people may have. And then on top of that, you do need to learn the dots API, which is going to be quite a bit different than just regular Unity game objects and everything like that. So I would almost consider this pretty close to learning a new engine or even a new programming language, just because there's so many different little things that you need to understand. And, the way things that are done on the ECS side are just a little bit different here. As far as learning resources go, Unity has some fantastic ECS sample projects on their GitHub that are a really great learning resource. I would highly recommend them. The ECS source code is also available open for inspection. So you can just kind of, F12 into whatever function and just kind of step through it and see what's going on in there. So that's been extremely helpful for me as well, to just kind of, read through some of the ECS source code, see kind of what's going on behind the scenes. And I'm definitely pick up little things here and there. And then finally, YouTube, of course, is a great resource. My channel, again, Turbo Makes Games. I do a lot of kind of tutorial videos, and there are, definitely some other creators who are starting to make more ECS videos, as ECS is now kind of in its 1.0 production ready phase and everything like that. So a lot of good stuff out there online. So anyways, that's just about all I got for my talk today. Once again, if you want to check out my YouTube channel or Twitter, just go to Turbo Makes Games. And if you want to talk to me a little bit more directly about any projects that you're working on, you can hit me up by email as well. So thank you so much, everybody, for paying attention to the talk. And thank you so much to JetBrains for putting on this wonderful event here today.
Oh, I'm sorry. I was just taking some notes here. There's a lot of good stuff in this talk.
Sweet.
Yeah, I shared your channel in the chat, so folks
Thank you.
definitely
Cool.
go check out Turbo Makes Games. A lot of cool stuff there. You had mentioned you actually consult for dots and stuff like that. You know, an obvious question a lot of people who might be watching are thinking to themselves is like, how do you look at your game? How do you look at your application and determine, okay, this is a good use case for using this technology to kind of get more out of my game?
Right. Yeah, definitely. I think like the first step is always like, you know, if you have kind of a prototype existing already, a good first step is to just kind of look at the profiler and see, you know, what exactly is going on. One important thing that I should mention about ECS is the optimizations are really geared towards CPU and memory efficiency. So it doesn't actually really give us that much on the rendering side. So if you're kind of like, you know, heavily GPU bound, then you might not get, you know, some crazy results that other people are seeing from ECS and all that. I'd say in general, like kind of a way to look at some of the optimizations is if you're doing anything with like, you know, heavy calculations, but maybe not on like a large scale where you have like, you know, thousands and thousands of like data units that you're doing that on, then that might be a good candidate for just using the C# job system, just kind of standalone. Because that's going to be, again, you can kind of like offload some of that, you know, heavy processing to worker threads and things like that. However, when you start to get to the point where you have, you know, larger scales of entities, you want to have, you know, more enemies, or you want to have a bunch of, you know, dynamic asteroids or something like that, then that's where it starts to become like a good candidate for using ECS again, where you can kind of, you know, parallelize a bunch of these, you know, fairly simple kind of operations, things like that.
Yeah, the chat just mentioned, Thomas said he's making a narrative-based game. Probably not a good use case for this kind of technology, right? I mean,
not necessarily, but again, kind of going back to, you know, some of the modularity aspects. Like if you want to kind of like use the advantage of the composition over inheritance, and you want to be able to, you know, kind of easily plug and play things for different behaviors. You know, just because your game doesn't use many thousands of entities doesn't mean that you can't use data-oriented design for other things.
Yeah, that's a very good point. You know, something that was interesting, kind of seeing your code samples throughout your slides. First of all, a lot of struct usage, right? So things are being stored on like the stack versus the heap. So that's really for memory efficiency. Things are being passed by reference. So like you're not copying a lot of things, you're just reading from memory space.
Exactly, yeah.
But one thing that kind of stuck out, I'd like to ask you, like, what if, as a naive dots developer, like that I would be getting into this, why don't I just slap burst compiled attributes everywhere and just kind of like win, right? Like
totally.
Yeah, like
so yeah, I mean, definitely you want to use burst as much as you possibly can. Again, I kind of hinted at this in the talk a little bit, but there are some restrictions around the burst compiler of, you know, things that you can use it on. So when you're looking at like managed data types, where you're looking at like more classes or like, you know, traditional Unity components and things like that, we can't use the burst compiler on those. Again, this has to be all on unmanaged data. And it is actually pretty surprising, like what you can accomplish by just using unmanaged data. Just kind of like, you know, again, basic simple things like, you know, floating point numbers, integers, Booleans, things like that. But yeah, when you start integrating maybe some more existing Unity features, that's where, you know, you're not going to be allowed to use the burst compiler. But yeah, totally use burst as much as you can.
Oh, so I was being kind of like wacky, but you're saying go ahead, go wild and see what happens, and just kind of like experiment. I think that's kind of what you're saying, right?
Yeah, totally. And then like if there's any you know, restrictions or any kind of issues, you know, you'll get a warning in the console, and then you can just with the kind of debugging experience, like it doesn't give you a lot of information for burst compiled code. So you typically will need to, temporarily disable the burst compiler, run your application again, and then you can get some better error messages to see, what exactly is going on.
Yeah, I mean, I guess that brings me to a good follow-up to that. Like what are the drawbacks? So obviously you're compiling down to native code. Like, are you going to see slower compile times? Is it going to be harder to handle exceptions? Like, what are some of the drawbacks that you've seen using this approach?
Yeah, that's a good question. I mean, compile times are a little bit slower, but I mean, I haven't necessarily done any like really side-by-side comparisons or anything like that, but I guess like percentage-wise, it isn't like much slower than just kind of like regular Unity compilation, because that already takes a little bit of time. So it isn't like much more than that, but it is like a little bit of overhead during the compilation process. Again, as far as debugging goes, a lot of times you'll just kind of see an error in the console. It says like, this code was like compiled with the burst compiler, disable burst to get, better errors or whatever. So then you can just kind of, go up to the little burst menu, disable burst, run your code again. And then, it'll point you to the, specific location where you're getting that error from then.
Okay. Very cool. I guess one more question from the audience. Is there any good approach to connect dots with a regular mono behavior? Like, I'm not exactly sure what they mean, but maybe you understand that particular question.
Yeah. I mean, it's definitely something that you're going to need to do because, like I mentioned, ECS doesn't have like there isn't like an ECS equivalent of everything just quite yet, and most likely there probably never will be. So things like this, again, that you see a lot of times with is things like UI, where again you kind of have to sort of bridge the gap between the ECS side and the UI that you kind of have over on your game object side. Now, it isn't necessarily as straightforward as just kind of like assigning references, because the way that ECS works is like most of the entities that you're creating, they're going to exist in what's called a subscene, which is sort of like a separate scene than your main game object scene. And Unity doesn't actually allow you to do any like cross scene references. So you can't just like drag in references in the inspector between things in the main scene and things in the ECS subscene. So again, you kind of have to do a little bit of workarounds about how from the ECS side can you like find things that are existing on the mono behavior side and vice versa, depending on what you're trying to do.
Okay. Yeah. On that note, Fedor, do you have any other questions, or?
No.
I think we're good. Again, folks, if you enjoyed this talk, definitely go subscribe to Turbo Makes Games. Awesome channel. Thank you so much, Johnny. This was a fantastic talk. And again, we'd love to have you back in the future. So
I'd love that. Yeah, this was an awesome experience. So thank you so much for putting this on, and looking forward to a couple more of the talks that you guys got going on today.
Yep. Thank you. And
Thank
we'll
you.
see you next time.
Awesome. Sounds
See
good.
you.
See you guys.
Bye. All right, Fedor, who do we have next? Let us know who's up next and what are we talking about?
Okay, so the next we will have Nick Titley, and he's a CTO and co-founder of SP Rockets game. So with a huge experience in game development, and so he will be talking about how SP Rocket games achieve good results with the Unreal Engine, with Kotlin DSL, build graphs, and AWS. So some crazy stuff.
Yeah, it's some crazy stuff. Like, let's introduce Nick. I also have to either thank him or blame him for millions of hours of productivity loss, because I saw in his profile he worked on Bejeweled, which apparently runs on any platform on the planet. So if your grandma has lost decades of time to Bejeweled, you can kind of thank or blame Nick for that. So let's introduce Nick. Let's add him to the feed. Nick, should I thank you or blame you for Bejeweled? I don't know which one I should do.
Both if you want. That's fine.
Your talk is really fascinating to me because, for me, like when I think Unreal, I always think C++, and here you're using Kotlin to essentially work on the build graph XML stuff and created a DSL. So it's all really fascinating. I'm kind of curious to see what you have in store for us and the audience. On that note, I think Fedor and I can fade into the background and kind of give you the stage.
Thank you. Thanks for having me. Right, so welcome to my talk. As I was introduced as, I'm Nick. I'm the co-founder CTO of Sprocket Games, and my talk is how we 10x our playtext velocity for an Unreal Engine game with build graph, TeamCity, Kotlin DSL, and AWS, which is the longest title of any talk I've ever given, I think. So, hi and welcome. Who am I? I'm Nick. I'm the co-founder and CTO at Sprocket Games. It's an all-remote game development studio founded last year. We're 14 people, mostly based out of American time zones. Before that, I was a little alluded to before. I started my career making mobile games at a studio called Jam.Mobile, where I made Bejeweled for phones, and then transitioned into being a backend developer kind of by trade and into infrastructure. So I went from backend lead on EVE Online at CCP Games into architect on shared platform tech for Riot, and then co-founded Pragma Platform, and now most recently co-founded and am still CTO at Sprocket Games, where all the stuff I'm going to be talking about today was implemented, tested, and kind of deployed. So here's a quick rundown of our agenda for today. First, I want to talk about why CI/CD is important, as people kind of throw around that word or acronym, and sometimes we don't take the time to appreciate why it's important. Then I'll introduce build graph, TeamCity build chains, Kotlin DSL, and then we'll put all that together and show how at Sprocket we did our build and deploy pipeline using all of these things, and we'll kind of look at our results a little bit. So let's do it. Why apply CI/CD is important. So first we CI, and then we CD. That's it. We're done. Boss, mission accomplished, right? We're done. Okay, but why? Why is this important? What are we trying to achieve? Making builds is cool, or having a CI is fun, but there has to be a reason for this. So at Sprocket, and your mileage may vary, but for us, we think of the end goal of CI/CD as increased studio agility. So our developer time is our most critical resources. A lot of other things are more fungible, but developer time is something we're very careful about. And we make games. This is a game day presentation. So we make games. Games are creative projects, and they're not the easiest project to fully predict or define. It's rare these days to have a full design Bible with everything upfront decided. So what that means is that our ability to test an implementation or a feature and react to that test is super important, more maybe important than in other software projects you might encounter. So for us then at Sprocket, CI/CD is a way to make the best use of our developer time, react really quickly to change in product directions, and then experiment and validate our assumptions quickly. And quickly is really important. You'll see it throughout the talk of why I think that's so important. So where did we start? Because we'll talk about where we ended up, but it's interesting to think about where we started as a studio. Well, we started like most project or studios. The game was built on a developer machine using build, cook, run. For those that have done Unreal Engine development, that's the kind of the traditional way of building locally your package game. It was manually pushed to a manually provisioned AWS instance, and then we had to manually coordinate uploading that build to shared storage somewhere and have everybody else download it, kind of show up at the same time for a playtest. And we tried to do this roughly once every 2 weeks. We tried sometimes more than that, but it failed. It failed often. It would either not compile, it'd have a nasty breaking bug, it would fail to start. And improving this took real effort. And I've been on many projects throughout my career, and a lot of projects will stay like this for a long time until well late into development. This talk is a story of how we got ahead of this and fixed it before it became a problem for us. So what were the consequences of where we were then? The consequences were we were losing hours of developer time making builds. And this was our top developer trying to make a build that was workable instead of making features and making a game, which is what they would want to be making. We lost developer time to broken syncs. They would sync ahead from Perforce, and then the editor wouldn't compile, or it wouldn't run. We lost the ability to interact with our own game, which perhaps of all the things we lost, that was the worst. We did not have a relationship with the product we were building. We didn't play it very often. We didn't experience it. And that was super detrimental to us. And then we had no clear feedback loop organized to test our implementations and get that feedback and then iterate on those features. So we were frustrated. Everybody was frustrated. No one was happy. And we figured we could do better. So what did we do then? Okay, to get to the point of talking about what we did at Sprocket, I will talk about build graph, build chains, and DSL first, and then we'll put it together. So build graph then. The definition from Epic goes something like this. I'm going to read it because it's that good. A build graph is a script-based build automation system that features graphs of building blocks common to Unreal Engine projects. Build graphs integrates with Unreal Build Tool, Automation Tool, and the editor. Build graph can also be extended and customized for your projects. That doesn't really say anything, or it's not super helpful as a description, I don't think. So here's my shortened version. Build graph transforms the description of your build to a set of tasks and relationship needed to realize that build and can then run those tasks. That's it. Forget everything else. Just remember that. That's what build graph does. It ships with the engine and is used to build your game. So this is what a build graph kind of script, XML script looks like. You can kind of glean that it's a XML document, and you can also kind of glean that there's a lot of placeholder variable names or stuff that looks like environment variables, really all those $signs, parentheses. And these things will be replaced later with parameters to get an actual concrete build. And the output of an export from build graph looks a little bit like this. It's a JSON document, and it specifies build steps and their dependencies. And that seems kind of obvious or unimportant, but it's actually crucial. It's pretty difficult in an abstract way to figure out all the dependencies of the build step and what needs files from where and what needs to run before what. And build graph orchestrates all that, including transferring files from one step to another. Okay, why use it then? Build code works, right? It works on your machine. Time-honored tradition of building it on your machine. It works. Why change anything? Well, build code run doesn't have any parallelism. It just runs the whole build in one go, start to finish. Okay, that works, but it takes a long time. And if you want to make a CI that reacts and is able to give valuable information back to your developers, it's just too long. There's no way to cut it. It doesn't scale to that. And if you use it, if you do decide to try to use it in CI, we found that the usage is really brittle and hard to maintain. Stuff breaks a lot. You end up writing bespoke script to try to maybe make something that looks like a parallel version of this, but it's not helping you do it. And when the tools are not helping you do it, then the tools are wrong. The tools have to help you do it. So using build graph then, you specify your parameterized build description using XML, like the file I showed, and then you can use that to generate any number of actual concrete builds, different branches, different platforms, different configurations. And those graphs will express the underlying concurrency that you're desperately going for, that you need. And then build graph can run the whole script, or it can run parts of that build. And we'll see how we use it a little bit later. At Sprocket, then, all UE builds are expressed in one build graph XML file. And we've so far found that that's not a big problem. It's worked out really well. Maybe it'll change in the future, but so far we're good. Okay, so what does build graph need to run then? It needs a build graph XML script. We went through that. And then it needs a set of concrete values to use as parameters to replace those $sign parentheses things that were everywhere. What are the parameters used for? Configuration to build, platform to build, where to put the result, really anything. It's a pretty generic system, and it has, I wouldn't say it's a programming language because it's not, but it has loops and it has conditionals. So you can do a lot. It's pretty expressive. What do you get then? As we talked about, you get a JSON document listing the build task and their dependencies. Now, what you don't get is a build system, and that's kind of the crux of how we put it all together later. There's no off-the-shelf CI/CD system, including TeamCity, that can interpret build graph exports. No CI/CIs or CI/CD system can do that, except Horde, which we'll talk about later. But that's not production ready, so it's not a real CI/CD system just yet. So, however, it is still a crucial building block, and interestingly, it doesn't contain its own parameters, so that's going to have to be worked around later in how we put it together. Okay. One of BuildGraph's most awesome ability when it comes to building your game is that you can run it locally. So not only can it run a distributed build or a concurrent build, but it can run that sequentially locally. And that has two giant benefits that are uncommon in production grade CI systems. It allows for a local iteration of the build system. So most of the build system I've encountered in my career so far, the way you debug them is to submit to the build farm and hope it works. And that's a very, very slow turnaround thing. Not great. With BuildGraph, you can test it locally, and you are nearly identical to an actual CI build. So you use it to iterate your build system, and you also use it to debug build failures, right? Often in many companies or projects I've been on, you would encounter a build farm failure, developer says it works on his machine, and you end up down the rabbit hole of chasing what the differences are between that build environment and the other build environment. BuildGraph reduces that a lot. I mean, there's always going to be differences, but there's a lot less with this paradigm. So it's pretty useful. Okay, BuildGraph, done. Build chains. This is a JetBrains talk. People probably know about TeamCity. It's an awesome CI/CD tool. What are build chains? Just so that we're all on the same page. So from the docs then, a build chain is a sequence of builds interconnected by snapshot dependencies. That's a great description, much better than the epic one for BuildGraph. Sometimes they're called pipeline in other CI/CD systems. They connect build configurations together. And the gist of it is they're connected build configurations. You can define them in the UI or via the Kotlin DSL, as we'll do in a little bit. But they have to be defined before the build start, right? They express your build, how it's connected. They're not generated as part of your build. Some people call those dynamic build chains or dynamic pipelines in other unnamed CI/CD systems. These are not it. They're statically defined prior to the start, and that is critically important. Then I'll just touch on one more thing that we're going to use. It's composite build. So if you've used TeamCity, you make build configurations. They have build steps. They produce an output maybe. Composite builds are a little different animals. They have no build steps. Their job is to aggregate the results of other build configurations, and then they can, if they want, re-expose the artifacts of those dependencies. In our system that we're going to show here, we use them to re-expose all artifacts built by all steps of our system, and then the composite build at the end of our build then is the one other parts of our systems depend on. So if you're wanting to get the result of an Unreal Engine game build, then you depend on that composite instead of the parts. That keeps things neat and organized. Graphically, from the UI, which is always a pretty UI in TeamCity, this is what it looks like. And you can see that we start by building an editor, and then we fan out to build on multiple platforms. If you know about building Unreal Engine games, that's kind of the rough steps you'd expect. If you don't, it just is what it is. And then we composite up at the end via the aggregate build all the artifacts. Okay, that's build chains. That should be pretty good. Kotlin DSL. Maybe you know about this, maybe you don't know about this. TeamCity can store its config and source control, and that is great. Please don't use the UI. Please don't go and manually configure your things. If your server disappears, that's really sad, and no one can review changes, and that's not great. So you can store the config as code in source control. You can either store it as an XML document or as Kotlin DSL. I like XML as much as the next person, but I much prefer a programming language, and that's what the Kotlin DSL is. So we can write code then with Kotlin DSL to generate our entire build system programmatically at evaluation time. The way we do that is we create a .teamcity folder at the root of our project, and that's where we're going to put all the DSL stuff. That has a special treatment from TeamCity, gets read and gets executed. So as I said, the Kotlin DSL then is a real programming language. It's a statically typed DSL. It's super well integrated in IntelliJ. You can run it locally to test its output, mostly, which means you can generate your build pipeline locally and see if the number of configuration you expect is about correct. It's not one-to-one. It could use maybe some work, but it's still super useful. However, the most important thing, writing CI config with autocomplete is the most awesome thing. I've done this with many products, many different CI/CD systems, and having a nice, well-featured programming language with autocomplete to author all of this is just a joy. I don't know if it's a drawback, but the limitation perhaps is a better way of describing this. of the DSL system as implemented in TeamCity, the DSL is executed only once after TeamCity detects a change in your .teamcity folder. Specifically, what that means is that it will not rerun before a build job. So you cannot create dynamic pipeline, not possible. You have to create your pipeline, and then later on your build will trigger if you do changes to the source tree outside of the .teamcity folder. Apart from that, though, I have not found any limitation using it. Everything I've ever wanted to do with it just worked flawlessly. Okay, we got build graph, we got TeamCity, we got Kotlin DSL, we got a starting point where we have difficulty making builds and doing playtests, and the studio is not working well and is frustrated. So let's put it all together and see what we can come up with. So first, we create a build graph script. That part is pretty easy. If you're using Unreal, do yourself a favor, and immediately after this talk, start writing your build graph script if you don't already have one. It's pretty simple, certainly to get started. It can get very complicated. You can do it locally, no problem. There's an amazing example in the engine source tree. I will say that the documentation, as is often the case with Unreal Engine, is not necessarily the best or the most up-to-date, but the source examples are amazing. So go into your engine source tree, find the build graph examples, and work out from there. I highly recommend writing batch files to wrap those build graph invocations for your local development and your developers. No one wants to remember 7 or 8 or 9 or 10 parameters that are needed to start the thing. It'll help you keep things neat and simple. I highly recommend doing this, even if you're going to stop here. Even if you're not going to do CI, if you're not going to do CD, if you just do build on, if you're a solo developer with no source control and it's all local on your machine, please just use build graph. It'll set you up for a CI/CD later. It will make things way more reproducible. So definitely invest sometimes in this if you're using Unreal Engine. Then the other thing that I'll mention, I'm not going to touch on it very deeply in this talk, but if you're going to use build graph, you should take the time to investigate what Unreal or Epic calls Auto SDK, which is their method of distributing standardized SDKs to build environments. So for Sprocket, we use it to deploy our SDKs both to our build machine and our developer machines. And so we keep all version of SDKs in sync across the build farm and developer machines. And we found that that reduces our false build problems that are due to just versioning difference to an absolute minimum. So definitely look into that too. Okay, so now we have an export from, or we have our build graph script that can define our builds. We can use it to have a JSON file that tells us all the steps, and we can use it to run those steps, but TeamCity doesn't understand build graph or steps or things like that. So we need to somehow transform this into a build chain. And this is where things get a little bit complicated or a little bit difficult. What we would want is when we detect a build graph, something impacting the build graph script changes to generate a new build chain. But that's not really possible, or we haven't found a good way to do it. And that's because running build graph means compiling your project. And you don't have access to your project when the DSL has to run. The DSL runs with only the .teamcity folder, no access to the rest of it. And so it's not quite possible to generate those chains at the moment you would want to in a normal kind of Unreal expected pattern. So concretely, this means no build graph export from Kotlin DSL, no build graph export as a pre-flight step on a build, let's say, or as part of an early step of a chain that would generate a second chain. Other CI systems sometimes can do this. We don't have that luxury in TeamCity, so we got to find a way to work around that. So how do we do that? Well, the path that we followed, that kind of we tried, and it worked relatively well for us. And by no means do I mean that this is the only or maybe even the best one, but it worked, so it has that quality. Given that we have to generate all pipelines when the DSL runs, and that we only have access to the .teamcity folder, then we don't have much choice. We're going to put all the exports from build graph in the TeamCity folder, and we're also going to find a way to add the missing parameters to the .teamcity folder to create our build chains. And then when that is true, we can finally write our Kotlin to transform those JSON files into build configurations. So how did we go about doing that? Well, exporting build graph to .teamcity or creating the export file, that's really easy. That's all it takes. If you want to do it running locally, that's all you need to do. The line will get longer as you add parameters, trust me, but at its core, this is what you need to do. So there's no complications here. But it gets real tedious to have to do that manually and for different build chains. And so it's not just doing that manually and stashing it in a .teamcity folder is not the end all be all, but it's not a hard part. It's not a hard step. The solution that we found is to organize our files in what we call job definitions. So inside it, we kind of abused the .teamcity folder a little bit and put more stuff, perhaps that JetBrains ever intended in there. But so far, it's working well. So we put our job definition there in the .teamcity folder. For us, these are just I think I'm back now. Somebody should probably confirm that they can hear me on stream. Yep. Oh, okay, cool. Thank you. So then, okay, where was I? Yes, the job definition files. So we start the job definitions in .teamcity. They're JSON files, and they contain the parameters that are needed for the export and the parameters that are needed to run the actual build steps. These are the same, funny enough. You can see what they look like on the right. They're not very complicated. They specify which project we're building, which platforms, which configurations, and so on and so forth. And these are arbitrary. You can add as many as you want. And we can use them then to export our stuff. So what this looks like in our .teamcity folder, if we kind of take a look concretely at what ours looks like, we have jobs definition. They're in the jobs folder there at the top. And then we need the JSON export of build graph. These are inside the JSON export folder. The kind of less great part about this is that developers have to refresh manually the JSON exports whenever they change something that causes build graph to change. And that's quite a lot of things. Changing the XML script causes that. Changing the engine source code, which we do from time to time, might change that too. Changing the parameters of the job certainly will do that. And so we kind of just abstract that all away by having a little Python script called refresh all there. If you have a key now, you might have spotted it. And that just refreshes all of our JSON exports, and we just run it whenever we feel like it might be needed. And it takes care of all of our perforce checkout, perforce check-in of all our .teamcity files. So it pays dividends to treat your developers well and make their life easy. They will use your tool. And talking to build engineers here in particular, they will use your tool way more if they don't have to remember how, or if it's very, very easy. So then, okay, cool. We have job definitions, we have build graph export. Now we can finally use Kotlin DSL to turn them into build chains. In build graph parlance, stuff is organized in groups and nodes and dependencies, and these will map literally one-to-one to build configuration, build steps, and snapshot dependencies. We wrap everything up in a composite build at the end, collect the artifact, expose that, and then we organize everything in neat little sub-projects to keep our UI clean and good looking. In the UI, it looks like this. So this is our incremental builder. It runs after any check-in in the game, and it tells us if we broke the compilation of the game on any of our target platforms. And you can see that we expose only the aggregate really in terms of what's useful on a daily basis. All the build graph step are hidden inside a sub-project. And that's because normally, unless it breaks, we don't really care about them. They just run, and we're happy to not see them kind of pollute our UI. How does this work? How do we write this Kotlin DSL? Where do we write it? Well, when you onboard onto Kotlin DSL's way of storing your TeamCity configuration, everything will be rooted in a settings.kt file that will be stored in, of course, the .teamcity folder. This is a little snippet of our code that we run to do that. And you can see that we've a kind of a extension method there for those that speak Kotlin called build graph build type. And this is, of course, not standard out of the box, but you can add it because it's a programming language fully featured. You can extend this DSL to your own needs. And this was our need to build graph projects for Unreal. But if you wanted to build something different, you can just as well add more stuff like this. So we define a build type then to extend the DSL to support build graph. The way we tie everything together there, you see the little cheeky name equal incremental. The build graph build type name has to match a file that isn't present in both the JSON and the JSON export, or the job definition and the JSON export. If that's the case, no problem. We generate the build chain for it. If it's not the case, we just error out and keep using the old definitions of the pipeline from the previous DSL run, which is great. Okay, I'm not going to show all the code that's needed to transform a build graph export into a TeamCity build chain. Suffice to say that it pays to go and learn Kotlin. If you haven't played around with it, please do yourself a favor and go play with it. Our game is a C++ game. Our backend is mostly Kotlin. It's that good of a language. It's not just a DSL for TeamCity. Do yourself a favor, go learn it. It is great. We make extension methods to kind of follow the DSL style. You can kind of see that at the top. And then we make class extensions or classes to do our build graph type. And that works super well. Super well. No problem at all. The result looks a little bit like this. You've seen the slide as I've alluded. I've added the artifacts here. So what this kind of shows you is that TeamCity now knows how to invoke build graph step by step. Instead of invoking build graph to run one process and start to finish, it can involve the sub-step. Now, build graph will take care behind the scene of synchronizing the files it needs in between its dependencies, so long as we give it a place to put those files. More on that later. And then TeamCity will collect the artifacts from all the packaging steps and re-expose them as one nice, kind of easy to depend on composite build. And this has been working super well for us. Okay, where do we run this then? Yeah, I don't have 12 machines at home. Or where do you want to run this? For now, at Sprocket, and this may change, this will likely change. For now, we run all builders in AWS. We use non-spot instances, which is weird, but you'll see why in a second. We create them from a launch template, so they're all standardized. We add them to a TeamCity Cloud profile. If you haven't looked at TeamCity Cloud profile, also go look at that. Super powerful, great way to save a ton of money. TeamCity will then stop and start our instances as needed. So even though we're not using spot instances, we are only paying for the compute minutes that we need to build our game. This is useful because we don't work much on weekends, so there's not much need to run all those machines. And the reason we use non-spot, because of course it would be cheaper to use spot instances, is because we want to reuse intermediate build products. This is anathema in general CI/CD circles to not main clean builds, but Unreal is so long to build that it's kind of, you don't really have a choice if you want an answer in minutes to did someone break the build to reuse prior build products. So we don't make clean builds for every incremental build. The inter-agent storage that I talked about earlier is stored in the cloud on AWS FSx as an OpenZFS share and mounted on all the build agents. And build graph takes care of cleaning that up and moving the files that are needed before and after build steps, kind of automatically. We start all our builds in S3 using the S3 plugin for TeamCity, and that also works super good. So if you're interested in not storing them on your server, the S3 plugin is a great thing you can use. What about our deployments? Well, they're all defined in Kotlin DSL as well, because once you start doing that, you're not going to want to stop. We use templated build configurations. You can see it there on the fourth line where I call templates, deploy to template. This allows you to kind of abstract even more jobs that are similar to each other. So this one is how we deploy to our daily environment, when and some information you need to kind of go and do that. Install stored in .teamcity, configuration as code. We love it. Works super good. Okay, graphically what that looks like for those more graphically inclined, we take build graph plus our job definition, we put that in a Python script, and that spews out all the files we need to then give to TeamCity. TeamCity takes over, runs the Kotlin DSL, generates our pipeline. When the pipeline runs from code changes, we put the results in S3, and then TeamCity can be used to deploy those artifacts from S3 to our Amazon game server instances, our Steam beta branches, and our Play Store internal tracks. And this is how Sprocketeers can then get there in the morning, open the Steam client, and just get in the playtest. Okay, so let's look at what changed when we did this, and perhaps what would change for you if you went on a journey of doing something like this. Developers can now build, cook, and package their game locally, fully, and easily. They have nice little scripts that do exactly what they need them to do, and it just runs build graph locally, and they don't know the difference, and it makes them a local build, and that's great. We use Auto SDK, like I said, to distribute our SDKs, keeps our tooling consistent, super good. And then we use build graphs so that they can run either before check-in to validate that with high likelihood that the build won't break, or after a break to triage why it might have broken if it wasn't broken prior to that. Our release builds run nightly and on demand. They take about 2 hours, which is long in the world of making builds, but not so long in the world of making Unreal Engine deployment builds. We have plans to make that faster, but it's good enough for us at the moment. It allows us to run them nightly, and it allows us to run them in the morning before the playtest if we have a critical issue that would endanger that day's playtest. Our incremental builder run on all change lists, and they run in about 20 minutes, both for PC and mobile platforms, for Linux and Windows builds. And that's fast enough for developers to wait for the result when they check in. And it's a critical metric. How fast you need to make them is exactly how fast your developers are willing to wait before they go home or go for dinner or do something else, and stop caring about if they've broken the build or not. And so 20 minutes for us is just fine. It's fast enough that right now we don't coalesce changes very often or nearly at all, which is great. Doing it for every CL means it's easy to pinpoint where the failure comes from. If you coalesce too many changes, people start to blame each other, and then it's a rabbit hole of figuring out why it's broken. We're very careful about where we report failures and successes. We try to keep Slack spam to an absolute minimum, so the signal to noise ratio is really, really good. By the way, you can send Slack notification easily from TeamCity, so service messages cannot be used for that. You just, if you are interested in that, ping me after or go look into service messages. They are great. The failures then and the recoveries, and only the recoveries, are reported to a dedicated Slack channel, CI failure as we call it. And so if a message goes there, something's broken, that shouldn't have been broken, and we're all kind of keen to jump on it and go fix it. The build outcomes are reported to CI builds, and you see it as I have muted there for those that are keen-eyed Slack users. And that's because it's quite noisy, and we only really go and wait on our build when we check in something in that channel. If not, it's more informational than it is useful. Perhaps the most amazing metrics that we've discovered is our time to fix. So even with all our local running abilities and our diligence around not wanting to break the build and be good to each other, we still break it roughly about twice a week, which for us, we work 4 days a week. That's every other day. And that may seem like it's not that much, but it has impact, and so it needs to be addressed. Now, we have an average, we track the average time to acknowledge a failure, and it's about 10 minutes, which is great. This is post CI notification. And the incredible metrics that we found is that a fix, we submit a fix on average 22 minutes after a break. And that is very, very fast. The credit to that is because we don't have too many changes, because the developers themselves are looking at this channel, they have full context. They know generally what was broken, and it can be fixed really quickly. I should add that this is compile errors or blueprint errors. This is not automated testing, deep game introspection breakage. These do still happen, and they're not caught, of course, by this system. As I said, we deploy every morning, and we can also deploy on demand to our testing instances, our Steam beta branches, and our Play Store internal tracks. It takes about 10 minutes to deploy to all of this and get an environment to a new version. We have the ability to go back and forward between any release candidate. I highly recommend you build yourself those capabilities as well. You will have to go back sometimes or do funny games with your deployments. We promote our builds between 2 environments, and that's good for now. We have our daily environment, nightly deployed via continuous delivery, TeamCity, of course, and then the playtest environment, which we manually deploy to via build promotion within TeamCity. That allows us to have a super high velocity iteration with the daily test, but also a stable environment at all times for demonstration. And we used to lose a lot of time when the moment came to make a build for demonstration. It was a very stressful thing, but because we keep one around and just do the hard thing all the time, it became not hard. Highly recommend doing that too. So did we succeed at rapid iteration, the real goal, right? Yes. We went from not being able to run a playtest to every day Sprocketeers get into work and they start their day by opening Steam and pressing play. And that's the extent of the overhead that they need to go through to get themselves into a playtest. Everything else is automated. And because we keep the build working, it just works. We use that critically to gather daily feedback on all our work now, and we adjust in real time, which it's not uncommon to iterate the same feature 3 or 4 times in a week. Interestingly, it has resulted in us allowing ourselves to experiment way more. We used to be reticent, I would say, to try things because we didn't know when we'd get the chance to really experience it, get feedback on it, and decide if it was a good idea or not. We now know we will have that chance, so it's much easier to commit to an experiment. And as I said, demo builds are always ready, so way less stress when the time comes to demo the game. So to recap, we went from we using TeamCity, Kotlin, DSL, BuildGraph, AWS, Steam, Play Store, altogether, we went from one super high friction playtest every roughly 2 weeks, and those playtests had a, I don't know, 50-60% chance of not working correctly, to a daily, reliable, consistent, enjoyable, and nearly frictionless playtest and feedback loop, of course. This has completely transformed how we work. And if you have multiple developers, I recommend you do something similar. You don't have to do it this way. There's many ways to do it, but like allow yourself to get quick iteration feedback. It will transform how you work. I so strongly believe that. Where do we go from here? As Sprocket? Well, the next adventure for us is to continue down the rabbit hole of CI/CD, and that's going to look like automated testing, like a green build with no warning, deploy daily in a demo environment, always being ready is great, but it's just the beginning. I've alluded to that earlier, but without automated testing, we do have instances where even if the game deploys and starts, it doesn't necessarily mean that it's playable the way we expect to, and we do encounter the occasional playtest that's not very effective because the game's fundamentally broken. So we're currently looking into how we deal with that, how we approach making a best-in-class automated testing framework integration. We don't have to write it ourselves. If we can find spots that or products that do it for us, we love doing that too. But that's where our mind is at. If you want to help, stick around. Also, a thing that to be aware of if you get into the how to build Unreal Engine game in 2023, Epic Games is working, has released, but not officially or isn't fully production ready, a thing called Horde, and they define it as a scalable, cloud-ready, distributed build framework designed for Unreal Engine. How well would it work? We're starting to get some talks and some reports that it is looking pretty good, and that could be really useful. But it's a lot of buzzword. We'll see how that comes out. Hopefully, it goes production ready, and we can start playing with it in a more non-testing kind of a way. Or if you have a bigger company and you're willing to spare resources, you could go and investigate it now. Just be aware that it's not blessed yet by Epic Games as production ready, so it may change completely. If you thought this was useful and you want to read more, I highly recommend Googling either of these two talks. Both would be better. The Vela Games about how to use BuildGraph in AWS has amazing gems. A lot of what we did was inspired by them. And June's talk on using BuildGraph is probably the best talk there's out there about how to use that. So strong recommendation on both of these. And that's it. That's me. Thanks. If you love build systems and making systems to make games, and you like to maybe work with us, we have tons of opportunities. So just ping us there. Work at sprocket.games. If not, that's me.
Woo! We love build systems. That's why. Yeah, let's do it. I have to say, Nick, the journey of your talk was really like inspiring, and I think the thing I took away from it was you've created an environment of fearless deployment and safety at Sprocket Games, because the amount of times you can deploy, the amount of times you could roll back to a previous build probably gives people a lot of psychological like safety working at Sprocket Games. So I think if there's one thing people should take away from your talk is like putting these systems in place can really make your environment just that much more fun and open to experimentation and make everyone just kind of feel safe. So I think that's what my takeaway was. Is that a good takeaway?
It is, absolutely. Yeah. It's super important for us at Sprocket. Like we great devs and happy devs make great games. I don't know why that would be so controversial, but maybe it needs to be said somehow. And so yeah, like creating that environment when people can do their best work and tools help them truly do that. Yeah, it's what we believe will unlock the next best generation of games. So yeah, we're pretty all in on this stuff.
Yeah, and you said something at the beginning which I like. It even applies to anyone doing any kind of development or providing solutions for people. Is like being disconnected from your work is just not good, right? Like,
oh, it's terrible.
Yeah, like you if you can't empathize with like your users, your players, because you're not experiencing the same thing they're experiencing, like then why are you doing it to begin with, right? So I think that was a really strong takeaway as well from your talk. I enjoyed that moment. I did hear a couple TeamCity feature requests masquerading as bullet points. I mean, this might be a good time to reiterate those so our TeamCity folks get those. But also file issues in UTrack. If you have any feedback, our devs are excellent at communicating with our user base and love to talk to our customers. So
I've got great experience. Like absolutely loved using it.
Yeah. I did notice something. You said you were running your Python scripts manually. Our IDEs actually have a file watcher feature, which you can say like, if these files change, just automatically run this script. You're nodding like you've tried it. It just maybe doesn't work.
Yeah, I mean, no, it's good advice, and we're always looking for places to reduce the friction. We just have a habit of not reducing it until it causes issues, and we try to have a keen eye and a keen sense of where those frictions are. And at the moment, that hasn't been an issue for us. So we're a small startup. I mean, 14 people. So some will say we're a small startup. Some will say we're a big startup. I don't know. Depends where you're sitting, I suppose. But so we try to be really lean and only do what's critically needed. I think we'll end up with something like that. It's made complicated because we let developers choose the IDE they want to run. And so, we experiment with it, having the CI server run the refresh script and then commit back to the Perforce branch. But there's always that weird uncertainty around having a check-in trigger a check-in on your CI server and then it going into a loop. So yeah, because it hasn't been a problem so far, we haven't solved it. But ask me next year. Maybe I'll tell you how we went and solved it and how made that bit better as well.
Well, that's a really good point, though. It's like when you're putting processes in place, like you really need to be pragmatic and think about it. Am I just adding process to add process, or is it like really solving a pain point? So I think like constantly iterating, thinking about your process, organically pruning things out, adding things back in. I think that's really great advice, I think. So on that note, I don't necessarily have any more questions. I think the audience were just kind of enthralled by the entire process that you have at Sprague Games. I'll give you kind of the stage here. Like, any last comments or thoughts that you want to kind of convey to our audience today?
Yeah, I'd say two. First, if you're using Unreal Engine, please do yourself a favor and just use BuildGraph. Don't wait. Start with it. You can get it done in a day locally. It's worth doing, believe me. And then the second one, probably the most important one, is recognize your most critical resources. It's your time and your happiness. If you hate going to work, you're not going to do good work. And if you're always doing unrelated tasks just to get stuff done, you're not going to do the cool shit that you really wanted to do, especially in video games. That's why we are in video games, right? Because we like to make games that are fun, hopefully. So take care of your developers, and if your developer is just you, take care of you. Like, take the time to write the tools that you need to make your process faster. Like do that analysis of, can I make my life better by writing a tool? And if so, yes. But don't go writing tools just for tools. These don't result in video games. So be pragmatic about it.
Yep. Don't worry, be happy is what I got. So a Bobby McFarlane thing there. So on that note, Nick, definitely folks go check out Sprague Games. Definitely sounds like a cool environment to work in. So hopefully you get a lot of job applicants. Just tell them JetBrains sent you. And then,
yeah, absolutely.
On that note, Nick, thank you so much. We'd love to have you again next year. And
it'll be a pleasure.
Yep. On that note, have a great day.
Thank you so much. Thanks for having me.
Yep.
Thank you. Bye.
All right, Fedor, who do we have next? Who's up?
So the next speaker will be Dan Miller, and he is a senior software engineer at Unity, and he is working on the XR team, and he will be telling us how to get started developing for Apple Vision Pro with Unity. So we're welcoming Dan.
I'm kind of jealous. I'm just wondering how you get the Apple Vision Pro headset. Like maybe Dan can send me a Vision Pro headset at some point. I'm hoping so, but we'll see. Everybody in chat, just pressure Dan to send me this headset because I really, really want it. On that note, let's introduce Dan. Dan, thank you so much for joining us.
Hello.
I'll
Hi,
keep
Dan.
checking the mail for my headset on that. But this is a super exciting talk. I think this is kind of the future. I know XR has been really big. Conversations around VR, AR, and kind of what we're seeing with like all these new headsets. The Apple Vision one is really exciting, so I'm excited to see this talk. So
yeah, thanks so much for having me, and excited to share this talk and just show what we've been working on here at Unity and things like that. So
okay, excellent. So Fedor and I will fade into the background, and we'll give you the stage. We'll be here again, folks. Be sure to ask questions in chat. We'll ask them at the end of this talk. So
great. So hello, my name's Dan Miller. I work at Unity Technologies on the Polyspatial team. And today I'm going to be talking about getting started building for the Apple Vision Pro, specifically with Unity. I did want to say a couple things first at the start of my talk, just to kind of set the stage a little bit, and then we'll dive into kind of the agenda here. So first, I can't personally grant access to Unity's Apple Vision Pro. I strongly recommend applying on the website unity.com/spatial if you haven't yet. It is currently a closed beta program, but we are, letting in more participants and things like that. And you can go ahead and submit your application there. On that note, I can also not personally grant access to Apple Vision Pro developer kits. That's all managed through Apple, and they actually have a specific portal on their developer site that you can apply to work with them, get access to developer kits, and they're also doing in-person labs at specific locations around the world. And this gives you the opportunity to go in, work closely with them, work with the hardware, as well as test your applications. So I strongly recommend doing that as well. There'll be a couple of questions I can't answer, just depending on what they are. I'll try to answer everything to the best of my ability. And then lastly, some things are subject to change. This talk is really about kind of our current support for Vision OS through Unity. And we're working hard to enable more features as well as kind of build up the support for everything that's available on Vision OS. So with that, let's go ahead and dive in. And first, what I want to do is kind of talk a little bit about a variety of different topics and how we're going to kind of set the stage here. So first, talking about spaces, and this is really understanding some of the core features on Vision OS, so that when I talk about how we're supporting them in Unity, you really understand the different kind of terminology and things like that. Then we'll dive into VR versus MR, how we're actually get started building with Unity, this new technology we've built called Polyspatial, input, and then finally how to get started today. And this will cover whether you have access to the beta or not, talking about some of the samples and things that we're shipping, as well as how to leverage existing Unity packages and features that will work on Vision OS. So first, let's talk about the building blocks of spatial computing on Vision OS. And how Apple defines this is through two different contexts. So one is the shared space. And this is really the default space that apps launch into. And it's really about having multiple apps. So you can have different windows or volumes. So basically 2D with some depth, or volumetric, so like a cube. And these can exist all around the user. You can open up multiple apps. You can multitask, whether you're, browsing Safari, playing a game, and, sending off an email. These kind of exist all around the user. The users themselves can actually move and reposition these apps all around them in their space. So a couple things to keep in mind is that the apps themselves don't know where they are relative to the user. So you can't actually have a piece of content within an app that exists in the shared space to kind of like turn and look at the user, because they themselves are kind of self-contained and don't know where they are relative to the real world. There's no ARKit data available for apps that exist in the shared space. So I'll talk a little bit more about what ARKit data is available on visionOS, but for apps in the shared space, they don't get access to it. So this is things like tracked planes or tracked images. And lastly, you can only use the spatial tap input for apps in the shared space. And I'll dive into this a little bit later with what types of inputs are available. But for now, keep this in mind when considering these types of applications. On the opposite side is an immersive space. And you can think about this as kind of full screening an application, where the shared space might be like a desktop where you have, multiple windows. An immersive space is really a single application that takes over your entire space. So if you have other apps available, they'll kind of fade away and you're just focusing on a single app here. Now, in the immersive space, there's actually 3 styles of immersion. So first is the full style, and this is what you can really think about as virtual reality. All the content you're looking at is virtual. You don't see the pass-through video, and you're just interacting with that content. Next is the mixed style, and that's what you're seeing here in this GIF on the right. And that's allowing you to look at the pass-through video or really look at the real world and interact with it by placing virtual content in it. And lastly is progressive, and this is kind of like a style on mixed, where you're in the real world, you can place virtual content, and you also can supply a skybox or some 3D content that is managed by the users themselves. So maybe you're watching a certain type of immersive video and you can provide an additional level that then the user can use the physical dial on the device to kind of control the level of immersion that they want. Some things to consider for apps existing in the immersive space is you do get access to ARKit data, and this is with special permissions. So you can place content on different surfaces. Here you're seeing the user interact with a plane, in this case, the wall, and have it procedurally spawn some content. You can also do things like image tracking, as well as meshing. The other thing to keep in mind is that apps can actually transition to an immersive space. So you could have an application that maybe has a main menu or a small piece of interaction in the shared space. And then when the user wants to engage more deeply, they can actually open up an immersive space, and vice versa. You can go from an immersive space back to a shared space, etc. And so I think, for me personally, really thinking about this transition, thinking about what space the app exists in is how you're really going to be able to leverage or take advantage of some of the unique features of this platform. So now let's talk a little bit about virtual reality versus apps that exist in the mixed and shared space. So at Unity, what we've done is we support virtual reality, which, as mentioned, is a full style immersive space using something called metal compositor services. And so this is basically rendering a metal texture stereoscopically. And you still get access in virtual reality to the ARKit features. So things like ARKit tracked hands, device position, planes. And if you're using the universal render pipeline, we also enable foveated rendering. Now, if you've developed virtual reality in Unity for other platforms before, this should be a really familiar workflow. On the opposite side, when supporting and building applications in Unity to support the mixed or shared spaces, such as, immersive spaces in the mixed and progressive, as well as volume and window content, we've built a new technology called polyspatial. And with this, all content is rendered with RealityKit. And so there's some caveats and things to consider with that. There's also just some kind of platform limitations to think about. And lastly, you still get access to ARKit data like tracked hands, etc., when in an immersive space. So for virtual reality, as mentioned, it should be a really familiar workflow, and a lot of your content should kind of just work. Because we're rendering in metal, things like custom shaders, particles, etc., should render fine if they are supported on the Metal rendering API. You also get access to things like ARKit data, hand data, and more complex interactions, leveraging existing packages that are available on Unity. So for ARKit data, that comes through AR Foundation. For ARKit hands, that actually comes through the XR hands package. And then for interaction, you can use the XR interaction toolkit. Some things to consider when developing virtual reality content for visionOS is this is really a hands-first platform. So if you have an existing virtual reality app that uses controllers, you really want to think about kind of, how can you transfer those interactions, or how can you build this kind of hands-first experience, whether that's, thinking about kind of redoing some of the interactions or just leveraging what's possible with just hands rather than buttons on the controller. Next is thinking about the spatial tap input versus fully articulated hands. And again, I'll talk about this a bit more when we dive into input, but this is this concept of, using the kind of gaze and pinch gesture versus looking at the full joint data that you get with ARKit hands and when to use that and where. And this is probably a bit of a stretch, but if you have an existing virtual reality app that you want to test that it'll work with visionOS on the virtual reality side, you could potentially build a kind of 2D version for macOS or iOS, and that'll let you check things like custom shaders and effects using the Metal rendering API. So now I want to talk about building for mixed and shared spaces, and really this is why we've enabled and built polyspatial. So at a high level, polyspatial allows you to build a Unity application that has kind of this simulation layer. So gameplay logic, physics, asset data, and then we transfer that over to the platform itself, in this case, visionOS, and then we leverage RealityKit and ARKit to kind of consume that data, build up the content that you have in Unity, and then also send some of that data back to Unity so that you as a developer can use those APIs to target some of that custom data. So whether it's things like input, AR data, etc. And because when leveraging polyspatial, everything is rendered with RealityKit, there's some additional kind of caveats or things to consider. So RealityKit itself is really, at its base is kind of a PBR-based solution, so physically based rendering, and they have a lot of really good technology in order to kind of seamlessly blend the content in with the real world. On the Unity side, what we do is we enable using the built-in render pipeline standard material or the universal render pipeline lit material and map those textures directly over to a RealityKit physically based material. So you can see here in this visual, I have a material set up for this vase. It has a base map, metallic, normal. And then on the right, this is the Apple Vision Pro simulator. And here we can see the vase in this kind of museum environment. We can actually change the lighting, and you can see the lighting adjust a little bit there. And what this does is just kind of, take into account the lighting. It also takes into account the real world. So it'll build up this kind of dynamic IBL or cube map that updates as the environment changes and really blend that content in. Now, if you're using custom shaders, we leverage something called Material X. And so this is actually a kind of open standard for node-based shader creation. And RealityKit can actually consume these Material X graphs and render custom shaders. So on the Unity side, we support this by enabling our node-based shader graph editor and translating those over to Material X and then supplying those to RealityKit for custom shaders. So if you want custom shaders in polyspatial or on visionOS, then you'll need to use shader graph to author those. Now, there are some nodes that we don't fully support, but we're working hard to support all the nodes that is available within Unity shader graph to enable those for custom shaders on visionOS. Now, ARKit specifically, if you're familiar with ARKit for iOS, Apple's actually made a specific version of ARKit for visionOS. And on Unity, we enable this through AR Foundation. So AR Foundation is our abstraction on top of a variety of different AR platforms to really give you a single API that you can target for building to these platforms with specific features. So we have something that's called AR Plane, and that works across a variety of devices and platforms that provide AR Plane data. So for Vision OS, ARKit features need to be enabled with permissions. So there's a world sensing permission for things like plane detection, scene geometry, which is meshing, as well as image tracking. And then there's a specific permission for hand tracking. And this gives you access to what we call the fully articulated hands, or really the hand joints specifically. So the available AR features for Vision OS are device tracking, anchors, plane detection, scene geometry, image tracking, and hand tracking. And something that I found is really interesting, as well as a really kind of fun thing to leverage or take advantage of in applications, is those semantics that come with both plane detection and scene geometry. So that gives you the ability to kind of understand different parts of the environment. It'll label things like plant, ceiling, wall. It can also do things like window, etc. And then you can have kind of unique interactions depending on the surface and how it's been defined. Next, I want to talk a little bit about the volume camera. So this is a specific component that we've built in Polyspatial to enable some of the features on Vision OS. So the volume camera is really what enables what sort of mode your app exists in. So in the camera mode, we have bounded and unbounded. And so bounded volumes are really apps that exist in a shared space. So this is something like a volume. And then unbounded is how we enable the mixed immersive space. So what that means is you can actually have a single application that has one scene that's in bounded and another scene that's in unbounded. And when you load that second scene, it'll kind of transition into that immersive space, and vice versa. You could load back to that first scene as well. On the actual volume camera itself, we have some dimensions, and then we have an output configuration. So this configuration is you kind of defining all the different sizes and the different types or modes of volume cameras that you want within your application. So these are little scriptable objects that contain this data, and then you can reference those directly on the component. So the dimensions of the volume camera is really the size of the volume in Unity space. And you can see this kind of green gizmo that we actually enable within the scene view. And then the output dimensions is the size of the volume in the real world, how it kind of builds itself on the Vision OS side, or in this case, the Swift UI side. Now, a couple things to consider for bounded content. So again, this is content existing in the shared space, and how you can actually interact or think about things with the volume camera. So the volume camera itself, again, kind of defines this, volume of content, or this space at which the apps can exist. And you can see on the far left, if we translate or scale those kind of dimensions, you can actually see the content move throughout the volume. So in the shared space, the app exists or the volume exists there wherever the user puts it. But as you move the content or the volume camera on the Unity side, the kind of content going through it can be manipulated, whether it's translation, or in this case, we're actually scaling down the rendering. Another thing to keep in mind with bounded content is there is a hard clip at the edge of volumes. So you can see here in this center example with the sphere or the globe, it actually clips right there at the edge. Now, this is an opportunity to do something like, show back faces or have a special rendering effect, but it's something to consider where, when the users are interacting with content and getting kind of near the edges of the volume there. And then last but not least, I think, really considering, what is your application doing? What sort of interactions and things take place within the shared space? So, the user could be, responding to an email, watching a piece of content, and then have your app up as well. And whether that's some kind of light passive interaction or, what sort of experiences they can have, I think you should really think about that, because apps that exist in the shared space will probably exist alongside other apps as well. Now, for unbounded content, or this is content that exists in the immersive space, it does leverage a lot of existing Unity paradigms with things like an XR rig. So you have like a tracked pose driver, which will then translate over to the device position. In this case, the headset's kind of position and rotation. And similar to virtual reality, you can enable a lot of the familiar features from other XR platforms through the packages that we already release. So ARKit data comes through AR Foundation, hand data comes through the XR Hands package, and interaction or more complex interaction can be enabled with XRI. Now let's talk a little bit about input. So input on visionOS is a really kind of unique part of the platform that enables some really interesting kind of input paradigms. And one of the kind of key pieces of input that I've mentioned before is this spatial tap. And what this is this allows the user to look at a piece of content and then use a pinch gesture to actually make a selection. While this pinch gesture is maintained, this kind of input is maintained. And so you can do, certain translations and things like that. And the gaze and pinch is considered an indirect pinch. The user can also directly pinch on content, as well as touch or poke content to interact with it as well. So we enable this on the Unity side through something we call the spatial pointer device, which is enabled in the input system package. And there's a lot of conditional data that you get while this input is maintained. The most important pieces of data are probably the interaction position. So this is the position that the interaction actually takes place at. The device position and rotation, the interaction kind, which is going to be the differentiation between, direct pinch, indirect pinch, poke, and then the target object. So you actually get the object that you're interacting with. Now, the interaction position is really where you're looking at on the object when the input is actually initialized. And while you kind of maintain this, you'll get a delta from that initial position. A couple things to keep in mind is inputs only happen on colliders. So this is true in the polyspatial side of things, so in the shared space or mixed reality. And what this means is that if your object doesn't have a collider on it, you won't be able to get input and you won't register input. So there's no concept of kind of an ethereal input where you're not looking at anything and you start to register things, at least on the spatial tap side. In this case, the device is actually equals the pinch position. So where you're kind of moving this pinch around, you'll get updates relative to the device position as well as the rotations. You can kind of grab objects and then inspect them and things like that. The interaction ray is the gaze vector, and this is really only available for a single frame that the input is registered, as well as only available in the immersive space. And lastly, some of the data similar to that interaction ray is only set in the began phase. So it only happens for a single frame, and then it basically stays that data, while some of the other data like device position, interaction position is updated as you maintain the input itself. So how does this look on the code side? So in this case, we're actually enabling the enhanced touch support to get the proper pooling API for active touches. So we can do this in the on enable. And then here in the update, we'll get the number of active touches. And if it's greater than 0, so a touch is active, then we can actually use the static method to get the pointer state passing in one of those active touches. And so here we're getting the primary touch data. And if we're in the began phase here of the active touches, then we get all the access to the data that I just mentioned in the previous slide. So you can get the interaction kind, the actual object that you're looking at or interacting with, as well as things like the interaction position. On the other side, there's also access to ARKit hand tracking. So ARKit hands are available only in the immersive space, and it gives you access to really these articulated joints. So you can tell, where the user's index finger is, where their thumb tip is, etc. And you can start to kind of calculate custom gestures or really do any sort of logic relative to the user's hands themselves. A couple things to consider is that this joint layout does not conform to the OpenXR standard. So there is some different joint naming and things like that, as well as the rotations themselves. And by default, your hands actually occlude the virtual content, but there is an API to kind of enable or disable this. So if you've used the XR Hands package before, you can actually get access or use the same code and same logic to get access to ARKit hand data and these articulated joints as well. So basically, you can subscribe to the hands subsystem, which has an update hands method. And then from there, you can link into the success flags and call or check the success flag specifically on hands. In this case, we're checking the kind of right hand pose to make sure that it's tracking. And then from there, we can use the subsystem's right hands to get data to specific joints. In this case, I'm doing kind of a custom method here for actually detecting a pinch. So I'm getting access to the right index thumb tip joint and the right index tip joint and the right thumb tip joint. And then I'm just calling this detect pinch method, which basically gets me the pose of both of those joints. So that's what contains the position and rotation. And then we can just do a small distance check between those, that if it's crossed a threshold, then we just instantiate an object. So this allows us to kind of pinch with both hands, instantiate objects relative to that user's pinch based on doing a distance check between it. And this is how you get access or do a kind of custom pinch on other platforms that are supported with the XR Hands package as well. And lastly, I want to talk a little bit about the XR Interaction Toolkit. So this is something that we're still working on enabling, and we're really approaching this from a couple different ways. So first is a custom interactor. So we're calling this the XR Spatial Pointer Interactor. And this actually leverages that spatial tap and allows you to kind of position itself as an interactor relative to the objects that you're looking at or interacting with. So you can do things like direct or indirect pinch, and then it'll put that interactor on or relative to the object itself, so then it can be kind of picked up and managed then through the XR Interaction Toolkit. So, you can have things like grabbables, apply certain like physics properties and things like that. The other thing we're doing is enabling button controls. So if you're familiar with XRI currently, it uses the input package in order to enable all of these different kind of control states that then fall back to different types of controls depending on the platform you're on. So really, we're trying to enable this to enable existing existing applications that leverage XRI so that it can feed into those existing bindings. Now, right now, we're looking at leveraging kind of the spatial tap gesture as well as ARKit hands. So you could kind of leverage or use both of them. One of the big challenges with this is that existing XR platforms as well as XRI specifically really relies on handedness, and the spatial tap gesture does not contain handedness. So, if you are looking at a piece of content and you trigger here, this will be kind of the 0th index. You let this go and then trigger with your other hand, that'll also be the 0th index. So there's kind of no handedness relative to the tap gesture. And XRI really kind of leverages things like left hand, right hand. So that's kind of one of the challenges that we're looking at with the kind of button controls. And lastly, I wanted to mention this hover component. So VisionOS does not provide data to the developer or to applications when you're actually looking at content. So it never provides eye tracking data. It never provides gaze data, except for that one frame of interaction when you're actually doing an interaction. And so they do have a special component called a hover component. And so we've enabled this in Unity, and it allows you to attach a custom component to any sort of object that has a mesh renderer and a collider. And what this will do is this will actually highlight the object to the user as they're looking at it. Here I'm in the VisionOS simulator, and you can see me kind of going between, and you'll see this light hover effect that applies to it. So some things to consider is it only works on colliders. So this is similar to input. And that means that complex collider setups might not properly translate it. So if you have an object that has multiple colliders on it, make sure that there's some collider that's relative to the actual mesh renderer in order to properly enable this component. All right, so that was a lot of information, and now I just kind of want to dive in and talk a little bit about getting started today and what you can do as a developer if you're interested in building for VisionOS. So today we've actually enabled the VisionOS build target in Unity 2022 LTS. So this is available in the latest version of the 2022 LTS. And this is what we're thinking about as kind of windowed mode or compatibility mode. So you can build an existing Unity application, whether it's a mobile game or a full 3D game, and target the VisionOS platform. And this will build in this kind of windowed mode. So here we're actually seeing an image of Boat Attack, which is a 3D game that's kind of being played here on this 2D slate within VisionOS. So you get access to input using the kind of existing Unity input paradigms like input.touch. Now, if you want to enable more of these volumes or immersive spaces and things like that, you need access to the polyspatial packages. And so that's currently in closed beta, but that's how we enable these kind of more rich features within VisionOS. And lastly, if you want to develop a full immersive space or a VR application, you also need access to that beta, and that's available using the VisionOS XR plugin. That is also an additional package that we're shipping. Now, something that we're distributing with the polyspatial packages is the template. So this is something I worked on, and it allows you to interact with content here in the bounded mode. So here we have some kind of light, playful physics interactions. You're able to, directly or indirectly grab these objects, move them around within the volume itself, and then you can actually hit that expand view button and go into an unbounded mode as well. And so here we're kind of seeing that. And then we have some, kind of UI that you can then click through and learn a little bit more about the project. Now, this is something that we're shipping with each of the package releases as well as updating. And really it's meant as kind of a lightweight starting project that's pre-configured with all the settings and things like that. The other thing to mention with the template is we currently are really targeting polyspatial. So it doesn't currently cover any virtual reality features, or really just the setup for a virtual reality app for VisionOS. The other thing that has been really my primary focus is getting started with these samples. So with the polyspatial packages, we're actually shipping samples alongside the package that you can import into your project. And it has things like a project launcher to go through and select a variety of different scenes. And some of these scenes are really trying to showcase, how do you use input? How do you take advantage of some of the features? What things are supported? What are some kind of best practices and things like that? So in the middle there, you see there's this object manipulation scene to kind of grab and stack some little cubes. And then on the far right, we have like balloon gallery, which you can either use an indirect pinch, so you can kind of look at the balloons and start popping them, or you can actually use the direct pinch or the poke to pop those as well. And so these are shipped as open source. You can look at the different scripts, how the objects are set up and things like that. And it's really just trying to help, kickstart your development and really get started quickly. Now, the other thing I want to mention is that while, the polyspatial beta is currently in kind of a closed beta, there's also lots of existing packages and features and things we have at Unity that will basically just work on VisionOS. And that's what I've been mentioning with the supported packages and how we've kind of enabled that through existing packages and features that already are out there. So one of the big ones is the XR simulation within the Unity editor. So this is enabled through Aare Foundation. And this visualization that you're seeing on the left is actually one of the samples that we ship for mixed reality. So what it does is it goes around and builds up dynamic planes as well as a mesh, and then adds these little labels to each of the surfaces that describe the kind of semantic data that I mentioned earlier. And again, this is a great way to kind of test ARKit features, start getting started with some of the gameplay logic as well as things like that. And you can do it directly within the Unity editor without access to polyspatial and without access to a dev kit as well. Next is the XR device simulator. So this allows you to kind of use WASD controls again within the editor. We're also supporting different hand gestures as well, which will then kind of fall through and leverage those XR hands kind of articulated joints so that you can add some custom gestures and logic for that too. And then lastly is the hands interaction demo. So this is a demo that we're shipping as part of the XR interaction toolkit, and it leverages articulated hand tracking on other platforms and allows you to kind of directly or indirectly interact with content, as well as do things like two-handed gestures and things like that as well. And again, these are kind of packages, features, things that exist in outside of Polyspatial that will work on Vision OS because we're leveraging those same kind of packages. And lastly, I kind of want to end with just some kind of general getting started. If you're thinking about building a project or you're thinking about porting a project over to Vision OS, these are kind of the general guidelines as far as packages, what sort of versions, and really just some kind of strong recommendations here. So definitely check out the latest Unity 2022 LTS, the Aare Foundation package, XR Hands package, XR Interaction Toolkit. We strongly recommend using the universal render pipeline. This gives you access to things like shader graph, as well as foveated rendering on the full immersive space or VR side of things. The input system package for enabling the kind of spatial tap gesture. And then really just, I think this is going to be kind of one of the more heavier kind of technical lifts, but think about porting a lot of your shaders over to using shader graph or leveraging, a fully, let's say, PBR, physically based rendered game using a lot of standard shaders. And lastly, a couple, final things to consider is thinking about kind of abstracting input, whether you're building a cross-platform application or just targeting the Apple Vision Pro. I think you should always think about, how your input feeds up and what sort of data that's possible on certain platforms and how that's kind of surfaces itself. Really be creative with the platform constraints. I mentioned this a little bit earlier about the different kind of modes and transitioning between the shared space and immersive space and back. And I think that creates a really kind of unique opportunity for apps to take advantage of that. And then lastly, use existing simulators, emulators, devices. The Apple Vision Pro and our support with Polyspatial is kind of a unique package itself, but a lot of these features, packages, and things exist on other platforms. And so there's ways to kind of get started thinking about what might be possible and how you can kind of filter this out and start building applications today. And with that, I'm all done. Thank you.
Very, very cool. I'm still going to annoy you about getting a headset, but that first slide, you said you weren't going to do it, but no, actually the thing that popped to mind when I was kind of watching, Vision OS introduces this concept of shared space. This is maybe a weird question for you, but if one Unity app developer builds something that goes into shared space, could their app interact with another Unity app within that same shared space? Could you have your video game characters essentially emerge in that shared space and like fight other video game characters?
Yeah, I mean, out of the box, apps do not kind of what we'll call like send data or know about each other, just like the calculator app doesn't know about your web browser. But there's really nothing stopping you as a developer from basically sending data to other apps or kind of making that connection. So potentially someone could build an application that does that, or really build a framework that kind of lets apps talk to each other. But out of the box it doesn't, but there's certainly nothing stopping it there as well.
Yeah, that would be a pretty neat feature of Unity to kind of create like a shared space mesh that these apps could talk through to each other. So I'm not making any feature requests, so this is just I'm just throwing ideas out there. A person asked this question. I'm not entirely sure if I understand it, but maybe you will after I read it. Can we know how transferable particle systems are in the mixed space? I'm not entirely sure what you mean.
Yeah, no, it's a good question. So I think the question is really, particle systems. So this is something I didn't really touch on, but as mentioned, when you're in the mixed immersive space as well as in the shared space, everything is rendered with Reality Kit. So Reality Kit actually has their own particle system. Unity also has actually a couple particle systems. And so currently we are transferring some of that data over. So we have a Unity particle system, in this case for Shuriken, and we translate that over to the RealityKit particle system. Now, there are some differences and some things we're working through with that. So, certain modules within Shuriken are not going to work in RealityKit, and we have some documentation on, what's supported and what's not. And we're also building up and exploring a kind of more robust solution for particles in those spaces. So it's a good question. It's a little bit of a TBD. We're trying, hard to kind of support that, but that is a certain caveat or something to really think about or consider when porting to Vision OS for sure.
Mm-hmm. Okay. I think Fedor has a good question that he just picked out. Fedor, go ahead.
Yeah, we have a question that are blend shapes supported in the latest version of the package?
Blend shapes are not supported. So currently blend shapes are not supported in RealityKit. And so while blend shapes are supported in Unity, when we're rendering or leveraging polyspatial, we have to kind of take advantage of some of the platform specific features. So not yet supported. I do want to do a small call out. If there are features like this, or there's certain things where it's not yet supported, or you don't kind of see it there, and it does end up being a little bit of a platform limitation, I strongly suggest, reaching out, submitting a feedback to Apple. They're also really eager and excited to hear what developers are looking for. So, they have the feedback assistant. They also have these kind of in-person labs and stuff. And so definitely reach out and ask them about that. So, but currently blend shapes are not supported, but that's also a good question.
Okay. I guess a question for all the Unity devs out there that may have VR or AR, applications out there. From your experience, kind of seeing, the interaction between Unity and Vision OS, do you think they'll have an easy path to transition their applications over into kind of the Vision OS space?
Yeah, I mean, that's certainly our hope or goal. I think, again, it really, unfortunately, there's no easy answer, as every application is just so different and unique. And so it kind of depends on what features their application uses or things like that. I will say on the virtual reality side, I think there's going to be a much easier path since we can leverage those metal compositor services. A lot of things like particles and custom shaders should mostly just work. When you're starting to take advantage of using polyspatial, that's when I think there's going to be a little bit more of a kind of heavy lift or a technical challenge, especially with things like custom shaders. The nice thing is if you have an app today that leverages ARKit for iOS and uses AR Foundation, a lot of that logic should mostly just work. You're placing content on a plane, it's doing something relative to that plane or surface. You're say, hey, this is a wall, put a picture frame on it. That stuff's really just going to work the same because it feeds through that same kind of abstraction layer at AR Foundation. So,
yeah, our chat's saying things like, love that there's so much to explore in this space, between what Unity's bringing, what Vision OS is kind of bringing to the table. Yeah, it's super exciting. I'm looking for more questions here, see if a lot of people are trying to get into it. Again, just to reiterate what the website is for sign up. I think it was like
so unity.com/spatial. And I know lots of people are excited to get in. We've also know that there's lots of applications. It is kind of a rolling basis. So we are, as we're scaling up some solutions on our side, we're trying to get more people access. We're also really eager, we want people in the program, and we know there's a lot of people to get excited about and start building. And so it's something we're constantly looking at. We're constantly trying to let more developers in. So the main answer there, unfortunately, is kind of just be patient, but you can certainly start thinking about some of these existing tools and things as well.
Well, I guess one more question for you, like seeing kind of like all the AR, VR platforms that are out there and the ones that developers are targeting, is there something in your opinion that kind of makes Vision OS kind of stand out, or might something that maybe developers want to take advantage of specifically on Vision OS compared to maybe some of the other platforms out there?
Yeah. I mean, I don't want to do any direct comparisons or things like that, but I will say, Vision OS itself being this, full kind of operating system and things, I think the shared space is really this kind of unique and unexplored opportunity for, applications to potentially have multiple kind of modes or things that you're enabling there, as well as just like starting to think about what sort of user behavior might exist there, where if you think about other platforms, you launch basically a single application, you're in the application, you're really kind of focused on that that core application or that single application. And with the shared space, I think there's opportunities for users to kind of fill their space with all sorts of virtual content, whether that's a virtual bonsai on one side and a virtual cat on the other, and really just kind of, giving users access to a lot of different kind of unique experiences, and then having like different layers of interaction within that. So that's personally something I'm really excited about, just kind of like all these little apps and volumes and things existing around me.
Yeah, it's funny because when you were showing your sample that you built, I was thinking to myself, like, you single-handedly killed the desktop fidget market instantly, right? Like, no one's going to have anything physically on their desk anymore. So it's going to be these virtual widgets and stuff like that. But no, this is super exciting stuff. So again, thank you to you, Dan. I know I won't be getting the headset, but you said it in your slide. You can't do that. I get it. But if folks are interested, please go to the website that Dan talked about. It seems very cool. I think a lot of Unity devs can get a lot accomplished in Vision OS. So I'm excited about that. Again, thank you. And we'd love to have you back. Hopefully when Vision OS and the headset gets released.
For sure.
Nice box.
And thanks for having me.
Yep.
Thank you, Dan.
All right, Fedor, Christmas. Remember, you're gonna buy me a headset for Christmas. So everyone here heard it first. But as we kind of wind down, how about we do one more kind of giveaway / raffle? Do you have any questions that you think our audience can answer for license?
I think yes, we have a couple of such questions. Quite an easy, I think. Okay, let's start.
Okay, let's go.
Okay, if we were talking about Unity, so the question is, what is the name of the special type of breakpoint for debugging in Rider for Unity? Just a simple one, I think.
Yeah, that should be. We should get a few answers here really quickly. So let's see. Yeah, this is Matt Ellis has demoed this a lot. I think it's burned into my brain at this point. So I'm hoping to see the folks answer this. No answers just yet. Come on, folks, free licenses. What are you doing?
Maybe I'll repeat the question. What is the name of the special type of breakpoint for debugging in Rider for Unity? Or maybe everybody is just Googling it in the Rider help.
It's not okay. I'm going to give people a hint. Oh, there we go. I didn't need to give a hint.
Yeah.
So it is called a pause point. So what a pause point does is it pauses the game so that you can kind of see the current state of your Unity game. So the Saint Rider, we'll put an email in the chat. Please email us and we'll get you that license.
Yeah.
Do you have another question?
Yeah, another two. The next one will be about Unreal Engine, and it will be what year Rider officially got Unreal Engine support in the release build.
This is a tough question. Yeah, I don't know.
One more time. What year Rider officially got Unreal Engine support in the release build? It's a tricky one.
See, I think chat is quiet because they're all Googling as fast as they possibly can. Here we have a year.
We have a year, and
Is that correct?
Yeah, it's 2022.
All right, Tanuj, you'll email us and we'll get you a license.
Yeah,
Fedor, you said one more
yeah.
question.
Yeah. And this is, I think, it's quite hard. Okay, that is, what was the slogan of JetBrains' most popular reshopper T-shirt?
Oh, this is a throwback. Like, when did ReSharper come out? It's like 2012 or something. It was long ago.
No, it's more than I think it's 2004. I think it's quite a long way.
Oh yeah,
for it.
yeah. So say that question again.
Okay, so what was the slogan on JetBrains' most popular reshopper T-shirt?
I think we have the answer. I see it.
Just a second. Yep, I see that code. Yep.
I see that code.
Yeah. So somebody with us for a long time.
Freddie, you won as well. You won a license. So yeah, Fedor, put that email in there, and all the folks that answered correctly, please email us and we'll get a license to you.
Yeah, just a second. I'll write down to the chat.
Yeah. I will also say currently Rider is in the early access program, also known as EAP. So now's a really good time to try out Rider, kind of no risk, and see kind of what's coming up with JetBrains Rider. Also, all of our other IDEs also are in that EAP period. So if you wanted to try out our tools, maybe the price is kind of like made you on the fence. Now's a good time to try it. Give us feedback, and you get to kind of use the latest and greatest of our tools. So it's always a good deal, I think. Surprised more people don't do the early access that we provide. But if you're more of a I need to be on stable, definitely use our trials. We also have great special offers as well on our site for students, education, open source maintainers, people who are part of appreciation programs like MVP or Google developer. I forget what that title is, but you know what I'm saying. So yeah, on that note, this is wild. Before we kind of close the thing, I just want to see in chat who here has stayed almost 10 hours with us throughout the whole game dev day. So Fedor, you've been here all day, right? All day.
Yeah.
I'm a sleepy American, so I only showed up halfway through because I was sleeping. Yeah, we have a lot of people who've been here throughout the day. If you're kind of watching this and maybe you missed something previously, make sure to subscribe to JetBrains TV. Like, subscribe, hit that notification bell. You'll get kind of a notification about when all these sessions go up. We usually try to break them up into individual videos. So if you need to go back to a particular talk because you found something interesting in that, you'll be able to do that as well. So really recommend folks do that. So yeah, man, there's a lot of people. Someone from Kansas. Wow, you must have really, really stayed up this whole time. That's amazing. So Fedor, do you have any last comments as we kind of wind down Game Dev Day here?
I want just to thank everybody who was with us during this quite a long day for us. I think everybody learned something new, or just have some inspiration for doing some great things, great games.
Yeah.
From the talks.
Oh, go ahead. Sorry.
Yeah, it's okay. What do you think?
Well, I want to thank really all the people you didn't see at JetBrains who really put all this together. So the JetBrains team did a fantastic job behind the scenes, organizing this. Definitely thank the speakers who joined us today and kind of shared their knowledge. Sharing knowledge is always great. So if you have an opportunity, share it, share the knowledge, share the ideas that you have. I want to thank all the hosts, Matt Ellis, awesome. Anastasia, awesome. Yeah, everybody did a great job. So thank you, everybody. And as we kind of wind down, hopefully you enjoyed it this year, and hopefully there's next year, and you join us then. So thanks, everybody.
And have a great weekend.
Yep. Bye.
Bye.